Hello everyone. Hello everyone. If you can hear me, if you can see me, if you can hear and see us, please set the thumbs up in the YouTube chat so we will know we can start. That's going to be exciting day for you. It's already very exciting moment for me, and that's almost midnight, or is it midnight already for our guest speaker? Hello Vinay.
Hey, yes, it
Yeah.
is. It is midnight, right in the midnight.
You are located somewhere in the United States, I believe.
Yes, I'm in California.
Oh, that must be quite a sweet place, but maybe too hot those months.
It is. It is. It's hot right now in California. We're going through the heat wave.
Okay. We are hearing there is an echo. Shouldn't be any. Let me check. Okay, I hope we are good now. Anyway, let us start. I see almost 200 people joined the conference already. And we will start very well. Yes, good. So let's walk quickly through the things happening today. What is going to be, and how do we going to get? How you can get maximum out of the event today? So it's Cassandra Day India 2021. We wanted it to be a live event, but now we have to do it online because of all the restrictions. But that's maybe even better because we can get people all around the world, and that's amazing. So, what is going to be about? It's going to be about Apache Cassandra. Apache Cassandra, what is it, and why do we have a whole conference dedicated to one single database? Isn't that too much? No, ladies and gentlemen, that's not too much, and by the end of the first few talks, you will know why. So, most of you, I believe, have no prior Cassandra experience, so in 2 words, what is it and why it deserves a standalone event? Apache Cassandra is a distributed, decentralized NoSQL database ready to work with a huge sets of data, like really huge. You will hear some numbers soon, providing highest possible level of availability, elastic linear scalability. You need to have more, you can have more from the output, from the volume point of view. Geographical distribution, which is very important for companies like Netflix. Hello, Vinay. Because
Hello.
the clients all across the world, it should be very important to keep your database close to your clients. Then highest possible read, not only read, also write performance and write scalability, which overcomes most of the other databases. And also it's now Apache Software Foundation project, so it's vendor independent, it's managed by Apache Software Foundation. Who uses Apache Cassandra? A lot of familiar names again. So basically you are using Cassandra already. Do you know about that or not? You are a Cassandra user because mostly probably you have an account on Instagram, or maybe you have an iPhone, or maybe you watch Netflix, or maybe you have something like WeChat, Alibaba account, eBay, Instagram, and so on and so forth. So there are a lot of companies using Apache Cassandra, but not only that, actually. For me, it's one of the best examples of how very different companies, sometimes competing companies, can work together to deliver a single solution. For example, Vinay, I know you was a lot you involved a lot into the development of a new version 4 of Apache Cassandra, right?
That's correct. That's correct,
Mm-hmm.
Alex.
Yes, and so you are communicating with different developers about the changes and so on and so forth. We both know what quite a lot of the companies were involved in the version 4 release, but whom you would mention first? Who did the biggest work developing Cassandra version 4?
Uh, yeah, I mean, without no doubt, it's Apple developers. put in a lot of effort in making 402 what it is today.
Yep. So Apple, Netflix, and many other companies developing this database as an open source project, and that's amazing for me. What sometimes you can meet at even quite competitive names, one to each other, but still working on Apache Cassandra improvements. That's what I like. That's how the world should work, I believe, in 21st century. Stop fighting already. So. Numbers. Do you recognize this slide, Vinay? Yeah.
Wow.
2 years ago we met at DataStax Accelerate 2019, and Vinay made a talk almost 2 years ago, or more, even 2 years ago actually, about Cassandra usage at Netflix and some upgrades in Cassandra version 4. And by those times, it was already one of the biggest Cassandra deployments in the world, with dozens of thousands of Cassandra nodes, hundreds of cluster, and like really a lot of data. Can you tell us how did it change in the last 2 years? Maybe Netflix dropped Cassandra already?
No, Cassandra did not stop its its progress in Netflix, with all the changes that are coming in the latest versions of Cassandra. It only kept going. We optimized a lot of stuff in the deployments and in the internals of Cassandra and how we use Cassandra at Netflix. So it's not going down. Every day, we see new use cases coming. We see new cluster spinning. The cloud cost is also increasing for Cassandra. So yeah, I don't see any downtrend in Cassandra usage.
Great. So what is going to be today about? There are 2 rooms and you can switch between them. Everything is recorded. So if you want to watch each and every session, if you want to watch everything, you are completely good. You can do it. But in any single moment of a time, you can choose only one room. So as long as you don't have a time traveling device, if you have, please share with me. I'm going to need that. What's going to happen in the first room? So CL room, consistency level room. Welcome. It's going on right now. When in a few minutes already, we will have Vinay Chella, from Cloud Data Architect from Netflix. With originally I call it Cassandra at Netflix scale, but Vinay found so much better name. You will see in a moment. Then 1 hour later, it will be a workshop for Cassandra beginners, for NoSQL beginners, Cassandra fundamentals, led by me. And I'm Alex Volishnev, developer advocate at DataStax. So after that, we will play a little game, Cassandra quiz. You join our quiz, give the answers, do it fast enough to overtake others, you get the prizes. Then later, Stefano Latini will introduce workshop efficient data modeling. How do you build efficient data model with Apache Cassandra? It's a very important skill, because if your data model is wrong, well, you can ruin really a lot of the Cassandra features. So highest efficiency is the shared responsibility. Cassandra gives you the tools, but you have to use them right. Good. Then finally, Ask Me Anything session, questions and answers with experts. So it's just a round table. You can jump in and ask your questions and we will answer them. We get a lot of a great expert for you. And finally, goodbye. Meanwhile, in the second room, so first room is more focused for beginners, people who only think of using Cassandra or start doing that. No prior knowledge required, except of general databases understanding is, well, quite recommended, I would say. Then in the next room, there are 5 talks. Each one is great. First one by Rahul Singh, platform architect and CEO of Anand Corporation. He will introduce Cassandra.toolkit tools you usually need to know to be successful with Cassandra, because it's not only about the database, but also about the tools you can use to work with it. Then, you maybe never heard about that, but there is a great feature. DataStax sponsors your education and certification as a Cassandra developer or Cassandra administrator. So Cassandra is great, but world needs more qualified engineers. So with our help, you can become one, paying not a single cent, because it's all sponsored by DataStax. In this talk, Stefano will explain how this certification program works and what do you have to do to prepare and pass the certification, and run a single demo exam, so you will see if you are ready for the certification. Maybe already you are experienced user, or not ready and you have to learn. If you have to learn, he will explain how do you learn, so where exactly do you get information. Then Payal Kumari, a database consultant from Python, will explain things about the Tombstones. Tombstones is a very misunderstood concept in Cassandra. So again, to be successful with Cassandra, you need to know what are the Tombstones and how do you treat them and how do you handle them and why it's important. Then Anil Kumar, database consultant, will share his knowledge in performance tuning. He has a lot of knowledge working with Cassandra clusters. And how do you try to get maximum output from a performance point of view? And finally, Sarma Paidipali from Verizon developed a Grafana dashboard for monitoring Apache Cassandra. So he will help you to start monitoring your clusters right way, because without monitoring, you cannot control anything and you just put too much luck. The skills would be a better replacement. So, what most important actions for you today? First, try to get as much knowledge as possible, because we are happy people. We work in information technologies and software development, and that's the field that knowledge is really valuable and easy to monetize. Don't get me wrong. Then I want you to try to get maximum from also the swag and prizes point of view. So first, participate in the quiz, answer our questions, and win the prizes. Second, ask questions to our experts using link dts6.io/Cassandra Day India questions. Using this link, you will see a form. You can ask questions and authors, and you can ask your questions and upvote questions you like. Users who get the most upvote will get a prize, and users selected by our experts by the best questions will also get a prize. And finally, don't miss your certification voucher, because, well, this voucher gives you a free attempt to pass the Cassandra certification first. And if you are certified already, following the same link, you can grab credits to use our database Astra for free, Cassandra as a service by DataStax. But today we focused completely on Apache Cassandra, and it's Cassandra Day India, and we are about to start. At this moment, I am going to switch to you, and we will see how many changes we have had in with Cassandra at Netflix in the last 2 years. I can't wait. I'm very curious. It's a very fresh new talk. And by the way, thank you then especially for joining us during your parental leave. And thank you so much. It's like a rare chance to see you again after all those lockdowns finally. So if you are ready,
thank you, Alex.
then I'm ready to switch to your screen. Give me a second. Good. So, ladies and gentlemen, we start the first talk of Cassandra Day India, and I'm happy to see you all here. And yes, you can proceed.
All right, thank you, Alex. Good morning, everyone. I'm sure this is we are almost in the noon in the India time. Good afternoon, everyone. It's going to be a really blast of a day today with all the lineup of talks we have. Um, Without further ado, let's jump into our talk today. Um, Netflix's mission to entertain the world with the power of Apache Cassandra. On a high level today, we'll cover evolution of Cassandra at Netflix, Cassandra scale in numbers, a few case studies that will go through within the Netflix usage of Cassandra, life cycle of Cassandra within Netflix, and a few operating principles that you can walk away today after this talk. Why should you believe me? I've been in the. My name is Vinay. I've been in the distributed systems ecosystem and distributed databases ecosystem for my entire life. Focusing heavily on Apache Cassandra and data abstraction recently for the last 6+ years. I'm part of cloud data engineering team at Netflix. We provide databases as services to rest of the Netflix developers. Netflix is something which doesn't need a lot of introduction, but I'll take a brief moment to introduce Netflix. Netflix is a video streaming service currently serving in 190 countries, leading the way for digital content since 1997, entertaining over 200 million members right from their couches. Why Apache Cassandra at Netflix? Well, Apache Cassandra is a database which supports millions of operations per second with a global data replication and failure isolation at a data center rack level. It is a database which is chaos ready from day one, which exactly works with chaos engineering of Netflix. And it provides a tunable consistency which supports variety of use cases, a variety of needs of developers of Netflix teams, and the internal structure of log structured storage engine enables us to do many things on top of Cassandra, which we'll walk you through in remaining slides. Apache Cassandra at Netflix. If you think about your interaction with Netflix, right from the customer sign up, landing on a homepage, watching a trailer, getting clicking on a play button, getting a CDN URL from your nearest location, and as soon as you start watching a movie, the health of the playback and all the metrics that are being pushed from your device to the Netflix. When you pause a movie, when you resume a movie, when you renew a subscription, when you rate a movie, all of this data is being stored in Apache Cassandra. Not just that, but also notifying when the new content comes, when your credit card expires and invoice gets generated, when all the notifications that you get on your mobile devices, on emails, all of that push notifications are also being powered by Apache Cassandra. And all of these features that we're talking about generate huge amount of data that demands aggressive latencies, high availability, which is essentially powered by Apache Cassandra. All in all, 98+% of streaming data is stored in Apache Cassandra. Data ranges from customer details to viewing history to billing and payments. All of this is stored in Apache Cassandra. And it is a foundational data store for serving millions of operations per second, to provide seamless experience to our customers. Let's take a quick look at evolution of Cassandra at Netflix from the day it started. Netflix's Cassandra story started back in Cassandra 0.7 days. It started as a simple key value storage where all of the data is being stored as a simple key value, but soon enough, it demanded recipes on top of simple key value structure, and then evolved into using rich data structures that came with Cassandra SQL data model. With all the payments, billing, all of these use cases coming onto Apache Cassandra, auditing and compliance requirements were the topmost requirements, and we had to rely on that on those features of Cassandra. Soon enough, it demanded building abstractions on top of Cassandra to make and to interact with the data Cassandra much easier. And recently we started ingesting the data out of Cassandra using CDC and pushing the data through the data mesh ecosystem. And we started using distributed data. We started building distributed data structures like queues, logs, state machines on top of Apache Cassandra in today's world at Cassandra. Data discovery and relationship between the data is an interesting use case that is also being being served from Apache Cassandra. We're building a kind of a graph systems, and relations between the data within your data stores is also being served from Cassandra. So a long story short, started with a simple key value storage, and to an extent where we can enrich the data using CDC backup, build the complex relations between the data using Apache Cassandra. And it is not stopping here. It is finding new avenues. It is finding new use cases, and it is finding its way to help Netflix on its mission. Specifically, in terms of numbers, Cassandra scale at Netflix, there are hundreds of clusters with tens of thousands of instances, providing tens of millions of replications per second across the globe, with hundreds of millions of operations happening per second as we are speaking, with petabytes of data that is being stored in Cassandra and served from Cassandra. To be specific with some of the fun facts of our Cassandra usage, our most active single cluster is operating with 30 million operations per second at any given moment. Our single most dense cluster is holding 500 petabytes of data in Apache Cassandra. And our biggest Cassandra cluster is consuming 9,216 CPUs to serve the traffic on top of Cassandra. Looking at the evolution of Cassandra and talking about scale, let's get into some of the case studies that will give you a picture of different areas where Cassandra is helping in Netflix. The first one I would like to walk you through is membership. Membership, as name reflects, it is a service which takes care of your signups. When a customer signs up with Netflix, it takes care of login, it takes care of all the data related to Netflix members. And the data store requirements from a service like that is highly available data store with durable guarantees and global, as Netflix is serving global customers, and should be able to take part in region failures because AWS regions fail, and Netflix should be up and running regardless of the backend cloud provided is up or not. But as I said, it's a membership service which is involved in your logins, signups, and all of the interactions that a customer does. It demands low millisecond latencies. When I say low milliseconds, we're not talking about hundreds of milliseconds. We're talking about single-digit millisecond latencies. And the batch processing, because a lot of analytics happen on like how many subscribers we have, how is the subscriber behavior, and a lot of that analysis on the customer data happens on top of this data set, on the membership data set. So batch processing and low millisecond latencies are one of the main requirements for a data store that serves membership. So that is when the Cassandra helped this particular service with a Cassandra configuration of a local quorum and with a replication factor of 3 in each data center, with a serial consistency to compare with the comparison set operations, like if not existent, stuff like that. Each quorum for customer data cleanup, when a customer leaves the service, we should ensure that the data gets cleaned up. So having a high consistency on that is also something that Apache Cassandra provides with the configurations. A simple data model, but with rich data structures provided out of the box from Apache Cassandra. Here, as you can see, the Cassandra table definition for our customer data. It has a lot of different types of SQL data types that you can see: maps, collections, static fields, and frozen columns, and you name it, we have it in this particular data model. The data model is simple because the account ID, the data is partitioned by the account ID, which is customer ID, and clustered by the profile ID. As one account can have multiple profiles. All of that are clustered by the profile ID, and ensuring the partition size less than 64 kilobyte for all the profiles provides a better performance. And on top of all the data types that you see here, it also has few user-defined types for the schema flexibility for flexible interactions for the developers. The next use case that I would like to explore here is a playback. Playback is a service that provides an experience when you click on a movie or a series, a play button, start right from the start of the play button until you complete that movie. All of that experience is driven by the playback service, which includes bookmarking when you're watching the movie, tracking the history of what you're watching, and providing all the logs and metrics as the movie is being streamed. The stream experience, the device experience, all of this is being tracked by the playback services. And the data store characteristics for a service like that are highly available. This service the data store cannot go down, which is powering the playback service. It has to be durable because all the viewing history is important for us to customize the homepage for our customers based on their viewing patterns. And it has to be global because our customers travel all the time. It is important for us to have their data store, which is global, to provide the seamless experience when our customers travel from one country to other. And it should be able to take part in region failover. As I said again, even if the backend cloud provider goes down, our Netflix service should be up and running, so it should take part in region failures. But by the name of it, playback is something that demands aggressive write latencies, because there is not a lot of reads happen from this service. When you're watching, all the logs that are being generated from your device are being pushed out to the Netflix service. And all of the viewing history, logs, bookmarks, everything is just pumping out to the Netflix service. So it doesn't need a lot of read requirements, but the write, it has to be super fast in accepting the write. And there's a lot of data that is being pushed out. When you think about, resuming your movie, when you watch a movie on one device and resume it on another device, it resumes exactly from where you paused, because that location where you paused is being pushed out to the playback service, which is persisting in the data store. And when you resume that movie in another device, it's being resumed from where you left off. So the consistency, the high throughput is also important. The reason the consistency is lower in this case is because even if some of the write events are dropped, let's say you're watching a movie and it stopped at 15th minute, 25th second, but the previous bookmark, let's say it's at 15th minute and 10th second, there's a 10 seconds delay, it's okay, that can be resumed. It doesn't demand high consistency. And also persistence guarantee is also not so high. It's okay to lose, some of this event, some of this data. And the Cassandra configuration to satisfy such requirements are, reads and write with CL local 1, which achieves higher write latencies, higher throughput. But again, they are lower consistency, lower data persistence, with a replication factor 2, because the data persistence is lower data persistence. Even if you lose a rack, some of the data will be lost, but that's okay. With those configurations, we were able to satisfy the requirements of playback service. If you look at the playback systems and its Cassandra usage, it's humongous. Playback is one of the biggest users of Cassandra within Netflix. Right from your device logs, event data, the session summary. Like session is something when you start watching a movie, all of that events, and where are you at watching a movie? How is your viewing experience? Is your streaming experience good? Is your battery impacting your streaming experience? Is your network impacting streaming experience? All of the data is being pushed out. All of that is persisted in Apache Cassandra. Active sessions with a Netflix membership, you can watch either 2 screens, 4 screens at a time. All of that is also being restricted through the use of Apache Cassandra. And what you're watching, how much are you watching, are you binging? All of the data in terms of playback history is also being persisted in Apache Cassandra. So if you look at playback systems, they use Apache Cassandra in and out for all of their needs. And then the billing, this is a common and very frequent question I keep getting. Does Cassandra use, does Netflix use Apache Cassandra for transactional needs like billing and payments? Yes, we do use billing Apache Cassandra for our billing and payments use cases. The data store requirements here are a little different from playback use cases, where it is looking at highly available, durable, and global data store, low millisecond latencies, because when you're signing up and you're creating an account, it shouldn't take forever to store your credit card information or so. Throughput and batch processing are also important requirements from a data store, which is supporting billing and payments use cases, because throughput, when we are charging customers on monthly basis, we process millions of customers' data, and it cannot take forever to charge a customer. So the throughput is important. That's why we use the batch processing, because all of the analytics that run on this data, how much we charge customer, how much is the revenue for this month, all of that is coming from the batch processing. Statement level consistency is required, because there are cases where data is written and read with a higher consistency. Because when we are charging a customer, we should do the transaction with a higher consistency. But when we are reading that, it's okay, because it's for analytic purposes. Even if it misses by 1 to 2%, that's fine. That's where tunable statement level consistency is something that this team was demanding. And one most important thing that this team was looking for is the data loss is not acceptable, and it has to comply with all the compliance, litigation and regulations that this team has. And that is where Apache Cassandra helped them. The data model is not so complex, but Apache Cassandra with its tunable consistency at a statement level and audit logging, auth N, auth Z that Apache Cassandra provides out of the box, enabled us to use Apache Cassandra for billing and payments. Distributed tracing, so it is a little different from the previous use cases we talked about. There are so many tools and enterprise softwares that are out there to track the distributed tracing system of distributed systems, but those are expensive to be used in Netflix scale. And that's where we used our in-house distributed tracing software called Edgar. And the data store requirements for a system like that are aggressive write latencies, because when we are talking about millions of operations per second, everything has to be traced. So really, really aggressive write latencies. consistency is totally fine. Even if you lose a couple of traces here and there, it is not going to be the deal breaker. So it's a tunable consistency. And that's why we took the advantage of Apache Cassandra's configurable consistency levels in terms of we can, disable the, durable writes in Apache Cassandra configuration, make it fast. We can make it local one. All of the reads and writes are happening at CL local one, which makes it faster with the writes. With the replication factor 1, there's no need to replicate the data, so much lesser load on Cassandra. And they're not global clusters, so island clusters, not a lot of work to do. And we don't put a lot, it takes a lot of disk space because there's a lot of data. So we don't provision extra, so we just provision with 2 to 3 days of extra IOPS and storage as a buffer, especially for region failovers. So in the story of history of distributed tracing, it started in 2017 with Elasticsearch. But soon enough, they realized the cost of Elasticsearch wasn't helping the team, and they couldn't get a lot of tweakings and configurations from Elasticsearch. That is when they moved to Cassandra. Cassandra on SSDs, was the first solution in 2018, and then as it was demanding high disk, it was costing us more, so we moved on to EBS in 2019. But the data requirements and the disk space requirements were increasing every day as the distributed tracing systems adoption was growing within the Netflix. So in 2020, we had to come up with a better data compression and filtering algorithms within Cassandra so that we can store more. In 2021, we implemented a tiered storage where cold storage is provisioned on a low IOPS and low EBS Cassandra clusters, and the hot storage is on a better performing disk and better performing EBS cluster, just to optimize on the cost. And then the next use case that I want to talk about is the ratings. It seems very simple to start with, but it is one of the important information that needs to be stored, which means it has to be highly available database. We cannot not show the advisories and rating information countrywide when we are showing our movies or TV series. So that is why it has to be highly available. This service cannot go down. And it has to support full sweep of advisories and ratings countrywide. Getting advisories and rating for a given movie and country is different. Very simple data model. And we were able to satisfy this with Apache Cassandra because they were demanding high availability. So we talked about different use cases and how Apache Cassandra helped. We started with membership, what membership demands from its data store, and billing and payments. Their demands are different. Distributed tracing, different demands, rating, playback. These are all different categories of applications and services in our Netflix ecosystem. But what I would like to show you here is Apache Cassandra is the one database which satisfied huge spectrum of use cases with its configuration and tunability at every place. In provisioning the cluster, in accessing the cluster, and using the cluster, everything is configured and tweaked and tuned to a particular use case. And that's where Apache Cassandra really helped us. Instead of investing in 10 different databases, we believed in one database and which served all of our needs in a really efficient way. But I'll also want to take you through a journey of Apache Cassandra within Netflix. We talked about use cases, but what is the life of a team which operates these databases? Is it a ops model? Is it a DBA model? Is it a developer model? how do we survive this demand and scale? So that's where I would like to literally walk you through what happens when we get a new requirement for Apache Cassandra. So I divided this section of the talk into 4 different models. One, inception. How does it start? How do we provision? How do we keep it running? And when time comes, when it is a time to move on, migrate, how do we do that? And at the end of it, Murphy's law. How does Murphy's law applies to even even Netflix teams? Inception. Where does it start? It all starts from our business use cases. What our business is asking. And consulting with our customers, identifying the right data store at the right time is the key for any success of our services. But how do we do that? That's why we employ the service philosophy. Our service philosophy is simple. We provide context instead of control. We invest in education, tooling. And the reason we provide context instead of controlling is restricting our users, our developers, by having the ops mentality or SRE deployment methodologies. We provide context. Everyone in Netflix has a similar view and responsibility as the database developers team is. So every party must be equally responsible. For that, SLOs are key. SLOs could be the size at which the data is being coming and the rate at which the data is being pushed to the data stores, latency, what data store teams have agreed upon, and availability. All of this have to be, these SLOs are to be abided by both service teams as well as the database teams. At the inception, as I said, we invest in education, to provide more context instead of controlling. We provide enough and detailed context in terms of scalability, performance, durability, consistency, and Netflix ecosystem. This gives enough detail for them to choose the right database and take the right choice when they're building a new system. Alex, I'm getting a echo from you. Do you mind muting? Yeah, Alex. I hear a lot of echo. I hear my voice back. Okay, it's clear now. And apart from the developer education, we also invest in a lot of tooling. Better tooling in a way that our customers get enough and detailed visibility into what is happening with the data store. We don't provide data store as a black box offering to our customers. We give enough details on what their cluster performance is, what are the latencies, what are the SLOs, what is the cost, and what maintenance is happening. Enough context in terms of cost so that they can optimize on their side as well whenever needed. And enough details into the maintenance of, is it backing up, is it repairing, so that they understand when there are issues on either sides of the system. And even in systems like when the Cassandra is repairing, what range it is repairing, if there is any impact to the customers, they can correlate this data with the impact that they have. In terms of backups, how often the data is backing up, where is it backing up, the duration of the backups, and how reliable their entire cluster is in terms of providing insights at a node level so that when they see some message in their logs, they can correlate with the health of the Cassandra cluster with what is happening in their system, so that it doesn't put a lot of burden in the database maintenance team. But to have all of this, SLOs are key, service level objectives. That is where
Hey all, wait a second, looks like we have a problem with connection. Give me a moment. Hey, hello, Vinay. I'm sorry, I'm not sure if we can hear you. Hey, 1, 2, 3, we can't hear you. So, ladies and gentlemen, sorry, a little pause. We have to recover sound connection.
Can you hear me okay now?
Yes, now it's good. Now it's good. So, your sound
Can you hear me
is...
okay now?
Yes, good. Now we can hear you. You
Okay.
can hear me, right?
Yes, I can.
Good. So,
Yes.
your sound disappeared like 30 seconds ago, so we saw the slides, but didn't hear you. Could you please repeat just last couple of slides? Sorry. Yeah, maybe
Okay.
even the previous one. Yes, this one was the sound disappeared.
Perfect. Cool. Must be the Comcast. Can you hear me okay now, Alex? Okay, perfect. Yeah. So as I was mentioning, SLOs, service level objectives, are the key for any of these services to be, to be healthy. And these SLOs could be at a disk, at a read latency, number of read operations, a write latency, number of number of writes that are happening. And these SLAs are promised and are abide by both the service teams, which is customers, and the database teams. And when any of these SLOs are broken, the person who is appropriate for that broken SLO gets the page. It could be the team that is owning the database. It could be the team which is using the database. And all of that is integrated into our tooling to make both of these teams' life easier. And at the end, we learned that good contracts make good partners, which makes better service for both customers and the teams which are operating this. Then the story of Cassandra doesn't stop there. Let's say we started really good Cassandra use case, and we agreed upon SLOs, and we said, okay, this is the best product to be used going forward. How do we provision? How do we get it up and running fast, really fast? Is through the self-service automation. So everything, right from creating a Cassandra cluster for provisioning and for collecting all of that SLOs, is automated and self-served to customers. So there is no human involvement. When a customer needs a Cassandra cluster, all of this is automated for them. But we need to prove it before serving it to the customers. That's where we invested in robust AMI build process and things like pre-flight check, which I'll walk you through what it is. When we are building AMI is a AWS terminology, Amazon Machine Image. We use AMIs, Cassandra AMIs, to provision Cassandra clusters and to serve it to our customers. And it goes through rigorous testing in terms of performance testing, functional testing, and performance testing goes through NDB, which is Netflix data benchmarking, which runs performance profiles majority of our use cases which are running in production. So whenever we change Cassandra, push it out to production, it goes through this rigorous build process, which ensures that the new Cassandra that we are deploying is battle tested and ready to be served. This is where we ensure the new code, the new feature that we are in adding Cassandra is, is not going to introduce any regression. But that doesn't stop there. Let's say you have a really well-tested Cassandra, but the deployment environment where you're pushing Cassandra might not be healthy all the time. That's where we use our system. We use the EC2 instance hardware health check system, which is a pre-flight check. If you look at AWS instance lifecycle, it follows a bathtub curve, where at the early stages of any of these instances, there are high probability of failure, and also at the later stages of last stages of instance, there is a high probability of failure. We ensure when a new instance is coming up, before we deploy our database, is that instance ready to be served for traffic. That's why we benchmark the system. We remove the bad lemons in the instances. When any of these instances do not pass our benchmarking, we do not use that instance. We terminate that instance, bring up a new instance, use it in Cassandra cluster. It might delay the process to launch your database, but it is better than suffering tail latencies in the database. Once we provision with robust AMI process and robust deployment procedures, there is a lot of stuff that happens throughout the lifecycle of Cassandra. Or not just Cassandra, but any of our data stores. That's where we invest in better tooling. Having a control plane which automates a lot of this stuff in a distributed environment is important. That's where we started with building imperative control planes, but eventually we landed upon declarative control planes. Excuse me. Imperative control planes are such where you have a single machine or a single control plane, which is looking at the state of the world and acting on the distributed systems to work according to your plan. Whereas declarative control planes operate with the help of agents. Your control planes puts an intent in a desired store, and all of your systems work towards reaching the desired. Excuse me. And until they reach the desired, they continue to focus on bringing the instances to the state where your desired store is looking for. Imperative control planes are easy to implement. They are easy to understand because it's a simple flow for you to digest. Excuse me for that. Declarative control planes have a lower total cost of ownership. They are parallel out of the box, but they're hard to implement, and because they have to stop parallelism from not happening, and it requires a different engineering mindset for you to build declarative control plane. But you don't need to build everything from the scratch. There's so many tools out there. Examples of imperative control planes, imperative tools are the orchestrators like Jenkins, Fabric, Ansible, and declarative tools are distributed databases like Console, Apache Cassandra, Apache Zookeeper, and Puppet. These are similar to the actor model. If you were to take the references of actor. Imperative tools are as simple as SSH in a for loop written in a Bash or Python. Intent tools or declarative tools have a highly available distributed systems in the back to work on the intent and to continuously work towards the intent. Digging more on declarative control planes, I'm not going into details on why imperative tools did not work. There's a different talk that I can reference you all to watch on why we chose declarative control plane. But gist of it is a declarative control plane, have a desired state and a state of the world, and it relies on the agent mechanism to continuously work towards bringing the state of the world towards the desire that you're looking for. And examples of declarative solutions could be link health. If you're looking at a Cassandra health, you would start looking at each and every node in Cassandra and see if it is healthy or not. If it is a 1,000-node cluster, it takes forever for you to call whether Cassandra is healthy or not. That's why the declarative solution, like every Cassandra node sends a heartbeat of its health to a central streaming system, which collects it, and on a moving window basis, it can tell you whether your cluster is healthy or not. JVM Quake, which Netflix open sourced, is also an declarative solution that we implemented. Bathtub curve model EC2 instance and how detecting the bad lemons in EC2 instance is also a declarative solution. If you look at Netflix open sourced Preem, which is a software running, which is a sidecar running Apache Cassandra for backup, it also uses declarative solutions. Cassandra repaired that Netflix open source. The repair service is also a declarative solution. I can reference all of these detailed talk later in the description so that you can all get into more details of what each of these individual systems have been built with. Cassandra ecosystem overall, if I were to summarize what we have been talking about so far, each Cassandra node has a main process itself, and all of these agents, like a sidecar, maintenance agent, failure detection, metrics, all of these agents make your Cassandra work well with the rest of the ecosystem. And that's where you have alerts and insights systems, which produces enough information to automate a self-heal, or when it is out of the system, you call, you page the customer, you page either the customer or the database owner. In terms of getting into the life of Cassandra, sometimes you have to move away from one system to other. That's where you invest in a better tooling, even in migrations. Our migration philosophy is simple: rely on immutable infrastructure and provide a seamless and transport migrations to our customers. I'm not going to getting into details of this in the interest of time here, but I would like to mention that when you are operating Cassandra or any of these data stores at scale, it is important for you to invest in immutable infrastructure, fully baked and tested infrastructure before you push anything into the production ecosystem. This is one of the toughest migration we had to do, moving the hardware from one type of instance to another type of instance, where we used declarative solutions like desires, where we mention we want this instance, let's say in AWS terminology, from I to XL to I2 to XL. And these agents continuously work towards moving the data from the instance to the S3, terminating the instance, and when the new instance comes up, downloading the data from S3 and starting up Cassandra and coordinating all of this in a distributed system in a fashion where it doesn't bring down Cassandra, it doesn't bring down the database to the customer is important, and that's where you invest in a better tooling in providing this data, providing the data stores. So as I took an example of, this is a 64, this is a 198 node Cassandra cluster where we are moving from one instance type to another instance type, and it is all happening seamlessly with the, with the power that Apache Cassandra provides, and with the help of tooling that we all built in-house to move from one instance to another seamlessly to our customers. And sometimes you might end up doing the data migration as well. All of your Cassandra, implementing the shadow writes and forklifting in your Cassandra drivers in your application makes the life easier for your customers to move from one system to another with the help of forklifter and dual writes. Like I said, I've been talking about really good things all the time, but I do want to talk about where things go wrong. I mean, anything can go wrong, will go wrong, however you plan, and how it has bitten us. And one thing that really impacted us is our lately done automation. We had an auto remediation to clean up stale backups and repair snapshot, which triggers only above a certain fatal disk threshold. Our assumptions mismatched. As a result, our automation ended up deleting really old backup data. And I think that's where I want to put a question to yourself. How many of you who are operating databases restore your backups constantly? Any code which is intended to run in a RAID scenario is often error prone. So it is lack of functional testing with ever-changing ecosystem, because that's the ecosystem that we are in all the time. And the semantics could mean different on a longer time horizon. So if you're not restoring your backups, if you're not exercising the code that you implemented, if you're not exercising your system, which is implemented to run in a rarest of rare scenarios, high probable that when you really need it, it won't help you because you're not exercising it on a regular basis. And that applies to backups as well. So all in all, the takeaway is invest in context sharing, tooling, and declarative infrastructure to run Apache Cassandra at a petabyte scale. And few operational principles that we have learned by operating Apache Cassandra, at a massive scale for over a decade is never write a runbook to operate your Cassandra. Automate it. Never have a Word document which is listing out steps to heal from an incident. Just automate that. Having a separate ops team to run your Apache Cassandra will not work. The developers of Apache Cassandra, the experts of Apache Cassandra should be operating what they built. Education and tooling are the two important things that really helped us. And SLOs are key. SLOs for both customers and for the database owners are key. Anyone who is not abiding by that should be getting paid, should take that responsibility. And building the mental models of the systems that you're operating is always helpful for effective debugging. With that, thank you everyone for joining today. Thank you, Alex, for this, for your time, for giving this window for me to talk about Apache Cassandra.
Big pleasure, big pleasure, and we are always happy to see you again. It's been a while since we seen each other last time, and always very interesting talks. And of course, for all of us, it's very, very interesting and useful to know how Cassandra is used at the biggest scale. So thank you so much for breaking your vacation, if I can say so, and joining us. It's very late already, so I wish you a good night. You know what,
Thank you.
dear attendees, I can say what we said. We suggest our speakers to have a recording if it's not their time zone, but Vinay wants to be here live with you, and that's incredible. Actually, let me do one thing as we have a couple of more minutes. I want to
Sure.
check if there are any questions we will be able to answer while we have. First question I see from Shashir Kumar. Why Netflix store billing information in Cassandra, as there will be consistency costs like local quorum for read-write? Is it since Netflix do not use relational databases or due to scaling bottleneck or analytical needs?
It is purely scaling bottlenecks, not just for analytical needs, but also for throughput for live systems that we are operating. So if you remember, our scale, we are talking about millions of operations per second. It was initially on Oracle. Our billing systems were on Oracle. There was a black day where our Oracle system went down due to the disk corruption, and Netflix site was down for a number of hours, and we never wanted to see that again. We wanted something which is highly available and highly scalable, which can provide strong, high consistency requirements. At the same time, never goes down, never brings that dissatisfaction to our customers.
Yep. Great, thank you. There are a couple of more questions. First one, what are the data store characteristics of billing and payment systems? Characteristics like replication factor, consistency level, use it.
Yeah. So billing and payment system demand one, any of our services demand high availability. So that goes without saying. Two, billing and payment systems specifically ask for high durability and consistency of the data, which means, in each data center, we replicate 3 times. Every byte, every write that we get is getting replicated 3 times. And, the consistency requirements are such that they need to, when they get an acknowledgement, when a customer gets an acknowledgement that the write happen, it has to really happen. We cannot miss that. And they should be able to read the write that they just did. So, yeah, those are the, replication factor 3, local quorum, consistency, all the stuff that these systems use.
And by the way, that's a good answer to people who is trying to raise replication factor to 5 to 10 and so on. You actually don't need it in nearly never. Okay, there is a question personally I really like by Syed Babar. Why Netflix went for Cassandra over MongoDB?
Alex, I lost.
One, two,
I
three.
lost you for a second.
Can you hear me?
Yeah, I can hear you now.
Good. So, why Netflix went for Cassandra over Mongo?
So, well, when Netflix benchmarked several data stores that are out there, which are meeting the needs of multi-region replication, high availability, where it is not a master-slave replication, tunable consistency, and petabyte scale, literally petabyte scale, with the tweaks and tunes that you can do either to lose the entire data or to keep the entire data. It's all in your hands. And that's where Apache Cassandra is the only one database that is out there which can check all the boxes that we have.
Yeah.
And MongoDB was never, not even coming any close, back then. And I haven't checked MongoDB lately, at least in the last 2 to 3 years. But I never needed to check one. So.
Yep. I would add a point here. Now, please don't get it wrong like MongoDB is bad. MongoDB is not bad. It's great for its specific use cases. And but for at Netflix scale again, when you not only read a lot but also write a lot of data. MongoDB is scalable from the read point of view, but when we talk of write scaling, then it's already a bottleneck as a primary or write nodes or master nodes. So it's a bigger problem for this also point of view. Yes, so at this scale, at such numbers, Mongo can't compete with Cassandra. Answer is very simple. And we are almost done. So last question, maybe last two questions. Question
Sure.
from Timothy. Do you use reactive manifesto and DDD principles during implementing new features with Cassandra?
Okay, so this is a new terminology, reactive manifesto and DDD principle. I joke about DDD. It's a demo-driven development. So do we demo first before developing? I don't know what DDD principles are, but when it comes to implementing new features in Cassandra, it comes from the customer demand. When we were implementing audit logging, the billing and payment systems demanded us to have audit logging because of complaints requirements that the legal team was pushing on them. There was a case where there was a need for us to have auth and auth Z. All of these features were driven by customers, so it's a customer-driven development for us.
Great. Did you run or deployed Cassandra in containers, maybe with Kubernetes?
The answer is not yet.
Okay. Yep. And final question. There is a lot of question. So I think maybe later, if you will have time, we can run a dedicated Netflix meetup for Cassandra.
Sure, yeah.
Maybe some of your colleagues also would like to have a talk, and then we will be able to ask, or people will be able to ask questions, because now we have to change to the next one. But I really want to end with this question. I really like quite an open one. Question from Aditya Mukherjee. I'm sorry, maybe I'm pronounced it wrong. So, good one. What is the future of Cassandra?
The future of Cassandra
Yes.
at Netflix. I'm assuming the future of Cassandra at Netflix.
No, I believe it's more open, but well, maybe Netflix.
Okay.
Maybe, I don't know.
Let me start with Netflix. The future of Cassandra at Netflix is bright and green and high velocity. We are hiring actively, crazily for Cassandra developers within Netflix. The demand is spiking day by day. Our teams are growing. From the time when I joined Netflix over 7 years ago, we were 2 engineers. Now we are 32 engineers in the team, helping operate data stores in Netflix, not just Cassandra, but few other. I do not see it is taking any step back in Cassandra, in Netflix. And when it comes to open source Cassandra 4.0 is coming up with full speed, with a lot of features, super high performance, and I'm super excited for it. And I can't wait for 4.1, 4.2, and 5.0 with all the features that are coming. I see the CEP is already coming in with amazing new features. So, I think it is bright, it is green.
Yep. Great. So, thank you so much. There are really a lot of questions. There is really a lot of questions in the chat. I just copy pasted the link to questions, a special list of questions. We collect questions. We will answer at Ask Me Anything questions and answers session. If your questions about Cassandra in general, write them there. If your questions about specific Netflix things, then stay tuned, thumbs up and subscribe to our YouTube channel. We will announce special Netflix meetup, hopefully, sometime later. At this time, we have to stop, and you know what? Our guest is very tired. It's like deep night at his place, and so let's let him go. But next time, we will catch you for a longer time and torture you with our questions for longer.
Sure. Thank you, Alex.
Thank you.
Probably next time.
Yeah.
I'll be I'll be in India and I can host a longer session. But yeah, this
Yeah,
time
it
of the
would be
year.
great.
All right.
So,
Thank you.
thank you
Thanks,
so
Alex.
much. Thank you. Ciao, and thank you for coming. Okay. So, ladies and gentlemen, what's happening next? You have now two options. Cassandra Fundamentals Workshop with me right now. Stay in this room. It's recommended for those who has no prior Cassandra experience. You will learn the fundamentals and put your hands and push the buttons and make your Cassandra cluster running. Second option, if you already attended this workshop or you have understanding of the Cassandra fundamentals, when in the second room, link is in the description, you have the option to attend a talk of Rahul Singh from Anand Corporation, platform architect and CEO, to watch his talk about Cassandra Toolkit. So what are the tools you need to know using Cassandra? And we are starting in a moment. So give me 1 minute and we start. Hey, everyone. Hi, Stefano. Ciao.
Hi, Alex. Ciao. How are you doing?
Yeah, good. That's Cassandra Day, and I'm
Yeah.
always double happy at those days.
Yeah. Hi, everyone. Welcome. It's nice to see you.
Yep. So let me check. I believe you can hear us. I believe you can see us, and that's amazing. So yeah. Yes, Cedric, double happy. That's Cassandra Day, my favorite project. And of course, I'm double happy at such a day. Today I have to wake up a little bit earlier because of the time zones. But okay, it was just 8:30 a.m. For Vinay, it was much worse because he is located in the United States. But whatever, we have many people watching us right now. And we have to start because we have a lot of very important things to cover right now. So, I believe you watched the talk by Vinay Marcella on Cassandra at Netflix scale. How do they use Cassandra? And take a look. Cassandra is a great database. It's much more powerful than most of the other databases, but it all comes with a price. There are some fundamentals you have to learn, and there are some limitations you need to understand, and some specifics you have to learn. Second workshop of the day will be Cassandra data modeling. And Stefano will lead that. That's very important for you if you are a beginner with Cassandra. If you want not to fail, but to succeed, you must attend data modeling workshop. But first things first, we start with Cassandra fundamentals. So, let's go. What is a Cassandra? You already know. It's NoSQL, distributed, decentralized database. People love it, and many of the huge companies are using Cassandra for the main 5 features. Big data ready to work at any scale. Highest possible availability, and I don't mean only boring fault tolerance. I also mean full-fledged disaster tolerance because of multi-data center deployments, which is a third feature. Geographical distribution. You can have your Cassandra data centers all across the world on every continent working as a single cluster, and all of those are active. When finally read and write performance. You know what? It's not hard to scale your database for reads having those read-only slave replicas. That's boring. Everyone can do that. Try to scale your database for write performance so you can write billions and billions and billions of operations within some seconds. It's way much harder. Cassandra can do it. And finally, Apache Cassandra stands for Apache Software Foundation Cassandra. It's a non-profit, non-commercial organization responsible for a lot of the open source projects. And Cassandra, as you can see from the name, belongs to Apache Software Foundation. So it's backed by many companies like Netflix, Apple, DataStax, and so on. But it's still controlled by the open source community. I love it. So, what are the Nigel Props says ask it a good question. I want to voice it before we proceed. How do we ask questions? There are 2 options. You can write them in the YouTube chat and get your answer right now, hopefully, or you can ask your question for questions room session questions. Ask me anything, questions and answers session later. And when you participate in a little competition, the one who asks best prizes, or some people who ask the best prizes, will get the prizes from DataStax. Who ask the best questions will get the prizes for DataStax. Yeah, it's still a little bit too early at my place, sorry. So, what are the main Cassandra features? It's distributed, replicated, and masterless. So, decentralized. That means distributed stands for scalability and responsiveness. We can have a lot of servers close to your clients, so they get answer very quickly. Then it's replicated. It means disaster tolerant. So if you lost your server rack or wall data center, or maybe availability zone in your cloud, you still can get your answers and even write data. And finally, it's masterless. So there is no single point of failure. It cannot happen because of a single server outage you cannot write your data to a cluster anymore. It's not a single point of failure, so a lot of servers answering your questions. There are 2 kinds of scalability for the databases, vertical and horizontal. Vertical scaling is a traditional for the databases. Vertical scaling means you replace your old machine, which is not enough, and then you just put a bigger server on that place and you are running again. Vertical scalability is easier to get, that's understandable. You put a new machine, migrate your data, decommission old machine, launch a new machine, you are up and running. But it has some downsides. It's more expensive. If you took a look at the higher rate production database servers, they are extremely expensive. And there is a still single point of failure for this node. Okay, this node is more powerful, but it's still a single node. There is a second kind of a scaling, which is a horizontal scaling. Horizontal scaling requires multiple less expensive commodity hardware. So instead of replacing old node with a bigger one, you just add more nodes of the same size. First of all, it's cheaper. Second of all, it removes single point of failure. Logistically, it's harder, but it's not your job because it's Cassandra cluster job to take care of that. Well, most of the time. So, Cassandra scales horizontally, and it's a linear growth of workload and linear growth of capabilities. If the single cluster of 3 servers you can handle, like, let's say 100,000 transactions per second, what do you need to do to handle 200,000 transactions per second? If your data model is right, you just have to add 3 more servers and you are good to go. You want to double your performance again, you know what to do? Double performance, double the amount of servers in your cluster. Question here, it works only if your data model is right. So stay tuned, there is a talk by Stefano later on how do you do it.
Yeah, very important.
Yeah. Cassandra scales linearly, and it's confirmed by many different companies. There is zero overhead on adding new nodes, again, as long as your data model is good. But the best reading from that point of view was done by Netflix guys. They benchmarked Cassandra scalability on AWS from, I believe, 45 to 300 servers. And take a look at this nice smooth line. That's a straight line, ladies and gentlemen, and that is amazing because for all the other databases, you have it not like that straight, but you're going to have it like boom, boom. Not straight enough. So Cassandra scales linearly, and that's a really powerful feature. Today you're working with 1 terabyte of data, tomorrow you work with 500 terabytes of data. Cassandra scales linearly. So, how it works. Cassandra is very powerful, but how it works internally, first feature, you need to understand what data is distributed. Then you work with traditional relational database. We use it to think what we have, all the data, the full tables on the server, main server you have, and then you launch read replicas. A full copy of this table will be stored on this read replica. Sounds good, doesn't work on big numbers, because at some point your data is so big it doesn't fit into a single machine. And if we want to be able to handle petabytes, we need to spread it to multiple servers. So, how do we do it? We split data into partitions. If you have heard of sharding on the relational databases, we can say it's a similar idea to split data to multiple servers, but in relational databases, sharding is a natural, painful process which happens way too late, and there is a lot of complications. If you ever did sharding on MySQL, for example, you know my pain and you know why I'm crying with bloody tears. Because it's really complex story, and that's not nice when you have sharding in relational database. With Cassandra, it's completely different because it's ready for big data from the very beginning. It's designed to scale to any scale, and as a result, data is split into the partitions. So while your single table, in this case population per city per country, is split to multiple servers in those partitions from the very beginning. What's the how that distribution works? Idea is very simple. Every table needs to have so-called partition key. Partition key is a column, in this case country, but it may consist of multiple fields. Those define partitions. In this case, rows sharing these, having the same country, in this case USA, for example, or Canada, they will be stored together within a single partition, and we see them here. New York and Los Angeles in a single partition, Berlin and Nuremberg on the second partition, and so on and so forth. Every server stores a lot of partitions. So, for example, here we have 2 different partitions on a single server. Of course, usually you have hundreds, thousands of them, or much more. It's completely fine. Then, how exactly partition works? Story is very simple. Take a look. Every row in our column, population per city per country, has a value in the country, designated partition key. And this country is the country, this field is a country name, right? So how do we define these partitions? First of all, value of this partitioned field, partitioned column, will be hashed by murmur-free hashing algorithm by our partitioner, by Cassandra partitioner, and as a result you get integer out of string. So, well, not necessarily string, it can be also integer, it can be different value, but as a result you will always have integer. This integer, call it a token, and each partition has its token. As a result, instead of Canada, we have 12, and instead of Deutschland, we have 45. Now there is a trick. Usually those numbers doesn't look like 12, 45, or 59, of course. Usually those numbers are like this size, and they are very, very long. But doesn't matter for now. That's good enough for the example. Now take a look. Imagine you have a cluster of 4 Cassandra nodes, like first, 1, third, fourth. And each node is responsible for a token range, so range of tokens. Let's say 1 to 25, 26 to 50, 51 to 75, 76 to 100. Again, numbers are much bigger, but I'm simplifying that a bit. Then take a look. Which server will be responsible for Canada? We see Canada, we partition it with murmur tree, we see 12, and we see what 12 gets to this token range. So this partition will be stored on the first server. Then Germany partition will be stored on this server, and Sydney will be stored on this server, and this server will be without any partitions. Well, it's fine because we don't have too much data at this moment. Now take a look. If you want to decommission a server, if you want to scale down, like your Black Friday is over and you want to scale down to save some money, makes sense when you announce what you are going to decommission this server. Cassandra cluster is smart. Cassandra cluster will recalculate token ranges, and it will see what, okay, now I need to store on the first server not 1 to 25, but 1 to 33, and here will be from 34 to 66 and so on. So, and data will be automatically migrated and this server will be decommissioned. Quite opposite, if you want to add more server, if your Black Friday is coming or Christmas sales, I don't know, whatever, if you want to scale up and you add one more server, what will happen? Basically exactly the same situation. First, cluster has to recalculate token ranges and the numbers will decrease in this point. 1 to 20, 21 to 40, 41 to 60 and so on. The ranges will be recalculated, new server will get its own token ranges and data will be migrated to a new server. You are good. And that's again absolutely automated, so that's a cluster job to do, so that's operations. You just tell, okay, that's your new server and Cassandra will take care of it. I love it. As a lazy engineer, I love that Cassandra does my job for me. But that is not enough. Data is distributed, but even when we have it distributed to multiple servers, it's not yet highly available. Because we have no redundancy. Only redundancy helps you to be highly available. So data is replicated, data is duplicated to keep you on the safe side. Take a look. For example, replication factor is amount of how many times partition will be duplicated in your data center, because replication factor is defined per data center. You will see it soon. So replication factor 3 means what every partition is stored on 3 different servers. And we see what it's the same partition for Canada, Toronto, Montreal, Toronto, Montreal, Toronto, Montreal, stored on 3 different servers. Okay. That means what, for example, if we are going to store some data, Note what got the data. Don't forget Cassandra is decentralized, so every server is able to answer to every query. Is it a write request or read request? Select, read, select, update, delete, insert. They all are dispatched by any of the servers. But in this case, this server is not responsible for the data what came, but it still has to store it somehow. So how do we do that? Again, Cassandra cluster is smart. So it sees what this data, I'm not responsible for this token range, but I know who is responsible because Cassandra cluster, every server knows token ranges of every server. And as a result, our server what got the request, this server is called at this moment query coordinator because it coordinates current query. Knows which servers are responsible for this, and then you just add more, and then it sends this query to the servers responsible for the replica servers responsible for this partition. And all goes good, but what if one of the servers is on fire? Power outage, network outage, system reboot, whatever, data cannot be delivered. Again, Cassandra is very smart and able to defend itself from inconsistency. Query coordinator sees what there is no confirmation what one of the replica nodes got all the data. Okay, what happens next? Query coordinator will store this data as so-called hinted handoff, and then this server recovers. It will this node will see what this server recovered. It will be like, okay, hello everyone, looks like I was down for some time. Did I miss anything? And all the query coordinators, because every server is a query coordinator, at the moment it gets query, it will dispatch this hinted handoff to the server what disappeared for some time, and data will be fully recovered. And again, what's the best here, it's fully automated mechanism. You can sleep well, wake up in the morning, check your monitoring, and found out what you had a server outage during the night, but there is no alert because there is no reason to alert. Cassandra cluster is self-healing, and then I love it. Good. So, and final important thing for us to understand is the distribution of the data centers. So you can run Cassandra cluster on a single server. Doesn't make much sense, but you can. But usually we speak about the data center of cluster of single data center of multiple servers, or in some cases like Netflix use case, Uber, Apple, and many others who uses Cassandra. Usually it's multiple data centers of multiple servers building the single cluster. On the left side, we see an example of a cluster located a single data center in the United States, one in the Europe, and one in Asia. So that's how it works, and they all are active. So that's not like active passive data centers in some other databases. They all are active. You can store data in any of them, and it will be automatically replicated in all the other data centers. And final point I want to mention is cloud native and ready to support hybrid cloud and multi-cloud deployments. You can have a single cluster of multiple data centers, but deployed in different clouds simultaneously, and it perfectly works. For example, this one may be Azure, Microsoft Azure. This one may be Amazon Web Services, and this one may be your own on-premises data center, still perfectly working together. And that's amazing how Cassandra is platform agnostic, so you can have cluster across multiple cloud providers, basically being able to survive outage of any of them, and that's amazing. So how data replication works when you have multiple data centers. Considering we have 2 data centers and replication factor is free for each data center, it works this way. First, your data comes to the data center west, just for example. one node becomes a query coordinator, right? We know that already. Query coordinator knows token ranges. So query coordinator knows which particular servers to ask to store the data or to retrieve the data if they are reading. It executes two operations simultaneously. First, it sends the data, if we consider a write operation, to all the servers within the same data center. Like, let's say these, and these are replica nodes for this partition we are updating. And it also makes a query to so-called remote query coordinator, which is located in data center east. And then data is already replicated in data center west. And for data center east, remote query coordinator will do its job and spread the data exactly like it happened to be at data center west. And boom, we have data replicated in multiple data centers simultaneously and very, very, very quickly. So, speaking of use cases, understanding use cases for Cassandra is very important. Cassandra is very powerful, but it's also quite demanding. So it gives you a lot, but also asks quite a lot for you, and you need to understand when to use it or when better to stick to your old good MySQL. What are the main use cases for Cassandra? Scalability and everything what belongs to scalability demandings. High throughput, high volume, or both. You can scale up to nearly any amounts of operations per second and very high volumes for heavy writes and heavy reads. Heavy reads, no surprise, heavy writes is a very powerful feature because a lot of databases not so good in scaling for writes. And basically everything what requires high volume or high throughput will be a good use case for Cassandra. Event streaming with billions of IoT sensors across the earth, log analytics, any other time series, and so on. Basically everything what involves a lot of operations. Availability. If you want your database to be 100% uptime, basically you have no other choice if you want to stick to open source solutions, definitely. And for any kind of a mission critical database with no data loss and always on and full 100% uptime, you have to go with Cassandra and multiple data centers, proper data model and proper architecture. It's not easy, but you can do it. So we speak of banking data, market data, well, basically every data you want to be available all the time. Next thing is distributed. We speak of global presence and workload mobility. First of all, global presence means what if you have your clients in the United States, Australia, Russia, I don't know, India, and so on and so forth, South America, you want to keep your database close to them, and Cassandra is the best choice on the global presence. You can have multiple data centers and keep your data close to your clients, therefore decreasing the latency to answer to them. But also workload mobility and ability to move your workloads from one continent to another, for example. Compliance and GDPR. There are very strict rules for compliance and GDPR in Europe. For example, you have to keep data of your German clients in Germany. With Cassandra, it's very easy because you can specify where you want to store your data in which particular data center. And well, there are some options when you need global presence and distributed data. And finally, cloud native. For modern cloud applications deployed in cloud, you can have it deployed everywhere. You can run it on Kubernetes. There is a great project called Cassandra. Basically hybrid cloud, multi-cloud, enterprise data layer, everything what belongs to modern clouds, multi-cloud deployment, hybrid cloud deployment, and so on. That's all easily supported. Good. So, Stefano, are there any questions we have to answer by voice?
So there are many interesting questions. Yes. Many of them we are trying to answer in the chat, and also thanks to Jeremy, who is doing a wonderful job and helping us a lot.
And Cedric, hi, Jeremy. I see also Cedric.
And Cedric, yes. Well, there was there were a few questions on an interesting point, but well, you will probably speak on that a bit more later, namely the fact that any node can be coordinator for any query, but this will come later if I remember well. So there were questions, how can a query reach the data in the proper way? Or well, we've been answering to those questions in the chat, but basically most application driver are speak to the cluster and get informed, get updated on what is the status of the cluster. So if nodes go up, go down, if the token changes, usually drivers are on the application side are smart enough to go straight to the node who has the data, which saves an extra network hop.
Yep. Yes. And I want again to clarify that. I see you've answered that 2 times already. Can any node be a query coordinator? How is query coordinator chosen? Every node, so you see Cassandra is decentralized. There are no designated for these task nodes. Every node can do the same job as others. It just can be responsible for that, for this token range, but not for that token range when it will be reroute your query to a proper server. Node what got the request will be a query coordinator. It's not really chosen, but just if it get the query, it will be query coordinator. If it didn't get the query, it won't be query coordinator because there is no query to answer, right? So idea is very simple. There is no chosen one who gets the query will answer. If you call to a huge call center, how do you choose which one will answer? You don't choose, you will just reach the first agent you want, and he or she will answer your questions or route your questions to one who is able to answer them at least. Good. So there is a great question, not a question, but ping message from Naya Props. Consistency is a big issue. So consistency is a very important thing, and consistency per se is not an issue, but lack of consistency definitely can be. So working with distributed systems, and by distributed system I mean every of them. It's not about Cassandra, it's not even about databases. If you develop a distributed system, that's also about your system. So you need to know this idea very well. There is a problem. Describe it in CAP theorem or Eric Brewer's theorem. In the distributed environment, you can have only 2 guaranteed qualities out of 3 in case of outage, in case of failure. What's the story? Take a look. There are 3 important qualities of a distributed system you need to understand: consistency, availability, and partition tolerance. What does that all mean? Let's start with the availability. It's the simplest one. Availability means what you always get the answer. So as long as you are able to reach a server, you will get the answer. There is always a server to answer. This is quality means what you just get some response in case you ask something, or you get your data stored if you are trying to write something, right? Now, consistency. Consistency means what then you ask for data, you get most up-to-date value, not outdated one. For example, if I change my username from Alex to, I don't know, Alex2, whatever, Alex new value, new Alex, and then request for this data, if system is consistent, I will get my Alex2 value because it's the most up-to-date. If I get the old one, it means what system is inconsistent and gives outdated values. And finally, there is a partition tolerance, which this one is the hardest one, so I have to explain what is it in a bit more details. It's very often misunderstood. Partition tolerance means ability of your system to survive network split, network partitioning. It means what you have a cluster of 6 servers, for example, and there is a network issue, and servers, first 3 servers cannot reach second 3 servers. It's a network partitioning. they cannot communicate anymore. It called it network partitioning, and in many of the databases or distributed systems, it leads so-called split brain problem, and it's a huge problem. So we want to have all of them. We want our system to be available, consistent, and partition tolerant, able to survive network split. But it's only feasible when we have, when everything works fine, and there are rainbows, and there are ponies, and everyone is laughing, and the grass is green, and all good. Then yes, you can have consistency, availability, and partition tolerance. But we live in the real world, and that means you have problems. What kind of problems? Each and every kind of problem. Network outage, power outage, whatever outage, system reboot, and so on and so forth. Altogether, it means what in case of failure, you can have only 2 qualities out of 3. And you have to decide which one you are going to have. And there is the first thing. You cannot drop partition tolerance. If your system is not able to survive network partitioning, then after first network partitioning, it will be not recoverable or very hard to recover. So we never, and it's just a question of time when it will happen. So we cannot drop partition tolerance. So every system is basically a trade-off between consistency and partition tolerance, so-called CP, and availability and partition tolerance, AP. And you have to decide, I want more to stick to the CP side, consistent and partition tolerant, but not highly available anymore, or you want to be available and partition tolerant, but not highly consistent anymore, so have eventual consistency. Again, don't forget, that's not about the Cassandra, it's not about database, it's about every distributed system you use. That's always this fight for things of consistency and availability. Good. So what comes next? Is Cassandra AP or CP? Is Cassandra available and partition tolerant or consistent and partition tolerant? A lot of people say Cassandra is AP, available and partition tolerance. That's not perfectly correct, and I prefer another definition. I consider Cassandra as configurably consistent. Why? Because, well, lack of consistency may be a big trouble, and Cassandra has a very powerful tool to handle this issue. Call it consistency level. What's the trick? In any moment, for each and every particular query you execute, select, insert, update, delete, you can specify exact consistency level you require to have. And changing this consistency level, you can bring Cassandra from AP to CP side, specifying some particular consistency levels. You can get to consistency and partition tolerance field. So I call Cassandra configurably consistent, and I find it more correct than eventually consistent. You can be on CP side if you want. So what are the consistency levels? When you execute a query, you can specify, I want my consistency level to be, for example, any, 1, 2, 3, quorum, and all. Let's take a look how it works. Idea is very simple. Then you have consistency level 1. It means what? With replication factor 3, you have 3 replica servers in your data center. Here we consider data center of 6 servers. Your client writes data. Query coordinator will send the data to the replica servers together simultaneously, asynchronously, at the same moment of the time. But it will wait for one and only one confirmation. So as soon as the fastest server gets the data and returns confirmation, okay, I got you, immediately query coordinator, without waiting for the confirmation from our servers, will return answer to the client. Yes, man, I got you. You are good, we stored your data. Then with consistency level quorum, it will wait for the majority of the replica servers to respond. So if you have replication factor 3, then quorum will be majority 2. It's like half plus 1. Or count to the closest integer value. So for free, it will be half 1.5, but we cannot ask 1.5 servers, so we round up to 2, right? What goes here? We are waiting for 2 confirmations out of 3. And as soon as the 2 fastest server answer, we will return answer to the client. And basically consistency level all requires to wait for confirmation for all servers what they got the update. And now there is a trick. Take a look. When we use consistency level all, we will wait for confirmations for all replica servers. And now we have a problem. You know what? CAP theorem is still here. What happens when we go for consistency level all? Try to think. When we go for consistency level all, we move from availability and partition tolerance to full consistency and partition tolerance, because we will wait for all confirmations from all the replica servers. There is 0 chance to go for inconsistency, right? But there is a problem. You cannot be consistent and available at the same moment of the time in the distributed system, and as a result you move to CP. And yes, your data is always consistent, but as long as one single server cannot answer, for example, this server is on fire, this server doesn't work, what happens next? You get an exception, cannot store your data, desired consistency level cannot be reached. So your 2 servers are working, 1 server is not available, you cannot store the data because you know what? No, we cannot reach consistency level all. You just moved the system from availability and partition tolerance AP to consistency and partition tolerance CP. And now you may question me, okay, but I want my data to be consistent, man, like I'm kind of financial institutions. I cannot store my data in eventual consistency way because you know what? There are auditors and clients who will be very angry if I store the data and those are eventually consistent. Yeah, I can understand that. So, is there a way to trick the CAP theorem and get to the middle somehow? Answer is yes. You see, it's a great workshop. I teach you how to break basically the physics law. Not to break, because you cannot break them, but kind of to bend and still get to the middle. Immediate consistency is what are you looking for? Immediate consistency is not the full consistency, but it's better because you can be consistent and meanwhile still be highly available. First way, let's take a look at the first way. If we write with a consistency level all, so we wait for confirmations for all 3 clients, then we can read with a consistency level 1, because all 3 servers were updated guaranteed, and now my client will always get most up-to-date information. Doesn't matter if it asks first, second, or third server. Does it work? Yes, it works. Is it the best way? No. There is a second way. If you write with a consistency level 1, so you wait for only 1 confirmation, then your client can read with a consistency level all, get data for all 3 servers, then it will always get most up-to-date information. Does it work? Yes, it works. Is it optimal? Is it the best way? Still no. Okay, so what's the best way then? Take a look. The right way to reach immediate consistency is write quorum, read quorum. That's a simple mathematics. If you write guaranteed to at least 2 servers of 3, so usually it's 3, sometimes 1 server can be down when you write to 2 at least. And if it fails, you know what not enough servers were up in your cluster. So client knows what operation didn't succeed. If you write with consistency level quorum, always there are two servers who store your up-to-date information. And if then you read with consistency level quorum, simple mathematics. There are two options. First, you read information from the updated servers. Then you immediately get the most up-to-date value. You are consistent, right? But there is a chance what your query will go first, will be answered first by one updated server and one not updated. What happens then? Query coordinator will see what one of the node returns outdated information, and it will do two things. First thing, it will return to your client the most up-to-date value, consistent result. And meanwhile, in it, it will initiate so-called repair on read. So if coordinator notices what one of the servers was outdated, it initiates the repair for data, and Cassandra cluster in background will execute self-healing, recovering from inconsistent state fully automatically. And again, if you don't monitor it, you won't even notice that, but cluster is recovered already fully automatically. Isn't that amazing? And now what's the trick? If you have two servers, at least two servers of three always having up-to-date value, there is no chance to get into inconsistent state, because you can ask two updated servers, you are good. You can ask one updated and one not updated, when you will get updated information and cluster will recover, but there is no mathematical chance to get into two inconsistent servers, because there is only one inconsistent server. That's example done for replication factor 3, but if your replication factor is 5, then quorum will be equal 3 and result still will be the same. So write quorum plus read quorum brings you to immediate consistency, right? There is a question from George Angelino, but repair on read is deprecated in 4. No? Yes and no. So there are two repair on read. One repair on read, then coordinator notices inconsistency. This one executed always in version 3 and version 4 in any version. In Cassandra version 3 also was repair on read, which tries to execute repair randomly in like a little percent of queries, of read queries. It will execute repair randomly. Doesn't matter if it's really required or not. This repair on read with no real reason is indeed deprecated and switched off in Cassandra version 4. Yeah, that's exactly what makes sense. And last question before I proceed. Purv Gupta asks, I can't go back. Yes, for this room in conference, you cannot put it on hold and you can't go back during the live stream, because I want everyone to be able to participate in the quiz. And if you are too late, if your stream is delayed, you will be too late on quiz and you cannot win the prizes. So pausa and getting back on time is switched off for the stream, so you can participate in the quiz and in the questions and answers. But when stream is done, you can get back in time and watch it again from scratch. Good. Okay. So, and final secret of immediate consistency, the right way. There is a little tiny formula you need to understand, is consistency level of write plus consistency level read is higher than replication factor, then you have immediate consistency. Let's calculate it for replication factor 3. What's the quorum for replication factor 3? It will be 2. So majority of the nodes. Then consistency level quorum 2 plus consistency level read 2. 4 makes 4. 2 plus 2 makes 4. 4 higher than 3. We have immediate consistency. If we go with consistency level write all, which is 3, we can therefore decrease consistency level for read up to 1 or down to 1, and it still will be consistency level write all 3 plus consistency level read 1. 3 plus 1, 4, 4 more than 3 via immediate consistency. Good. So consistency trade-offs. Higher the consistency, less chance you can get stale data. Price for that is possible latency. For example, if you have replication factor 3, consistency level quorum, you wait for some data. If your network works perfect, your servers aren't overloaded, all of them respond in exactly the same time, and you get 3 confirmations in the very same millisecond. Well, good for you. Then it doesn't matter which consistency level you use. But in real life, it doesn't work like that. Some servers may be overloaded, some network may be lagging and slow. As a result, you usually get confirmations not all together, but next by next by next by next by next with some time difference within. And as a result, the more servers you expect, the more servers you wait for, higher chance of possible latency. By the way, that's one of the reasons we don't recommend to have too high replication factors, because just you will wait. If you have a replication factor 90, you will have to wait for 60 servers, right? And no, it's we better say it like if we have replication factor 99, we will have to wait for 66 answers. More servers you wait, higher the chance what some of them will be in a bad state and won't answer as fast as you want. And you want your Cassandra cluster to be quick. It depends on your situational needs, and you indeed may choose the consistency per query. So if your application works with different kind of data, for some kind of data you want to have consistency level 1, and for some of them you want to have consistency level quorum, that's perfectly fine. For example, IoT and sensor systems with very write-heavy workloads, like when you have billions of sensors in the world dispatching their state every few seconds, and there are a lot of them, so amount of writes is tremendous. In this case, you can go for consistency level 1 for writes if data isn't required immediately. So if you only store data, but not going to query for it for very same millisecond, you dispatch it. If you usually query for this data a little bit later, then you may benefit from consistency level 1. It means what? At least one replica server will get your data and therefore will replicate it immediately during the query with a normal replication, or will replicate it later with a repair if anything goes wrong. Then it's good and it helps you to be faster on writes. But that's not a general use case, so usually we recommend to stick to consistency level quorum or local quorum. Speaking of which, there is one more slide I want to show you is for multi-DC consistency levels. There are 3 more consistency levels you need to know: local 1, local quorum, and each quorum. Why should you care? Then you have multiple data centers in very different places. You want your application instance in the United States work with the United States database instance, right? You don't want your application server in the United States go to European database. If you have a database in the United States, it will shorten the latency. Correct. So every Cassandra driver you use is aware of the so-called local data center. Local data center is the one what's considered closest to the center, to the server you run your application. And then you specify local 1 or local quorum. It means what your application will wait for 1 confirmation of quorum or quorum of confirmations from the closest database data center, not from the remote one. And second option you have to consider is each quorum. It means what you want your data to be guaranteed delivered to each and every data center you have right now, and you need to know if it was delivered already. With each quorum and replication factor 3 per data center, we will wait for 3 confirmations here, 3 confirmations here, and 3 confirmations here. This one guarantees what data is delivered to each and every data center right now not later during the repair, but right now, but there is obvious price. Your client will have to wait for each data center to get. As we discussed it recently with VNA, they are usually using local quorum to guarantee what your application works with the closest data center and doesn't work for the, your queries to be a globetrotters and go to Australia, for example.
Alex?
Yeah.
Sorry. I have to interrupt you because I think the time has come for me to say goodbye to you and hop to the other room. Because,
yes.
So I've actually collected a few interesting questions, but I'm not sure if we make it in time. Maybe they will be touched again on the Q&A session, I guess.
Yes. Take a look. Don't forget to send your questions to Q&A session. The best of your questions will get prizes, and not only send but also upvote the questions you like and questions you would answer. You would ask. So we will see what you are voting for. Good.
Yeah, and for that, don't forget to put your name when you ask the question. Otherwise, you will not be able to get a prize.
Yeah, right. Put your name in the question. Otherwise, we cannot identify you, right? Good. Okay, so it's time for you to jump away.
See you in the other room. And goodbye, Alex.
Goodbye.
Thank you.
Thank you. Good. So Stefano moves to the second room to run his talk about Cassandra certification program. The trick is DataStax sponsors your education for Cassandra. There are free courses at the Academy and free certification with a voucher you are going to get because you attended Cassandra Day India. What matters for us is right now, if you are a complete beginner, you better stay with me. If you are already knowledgeable in Cassandra, you may switch to Stefano's talk in the second room. Link is in the description of this video. And watch this talk. There will be a training. He will explain how do you learn, how to pass the exam, and he will run a small demonstration exam. So with very similar questions to the real questions, but not the exam questions, sorry. And if you answer them, surely then you feel like, okay, it's all good, I am ready to pass the exam. But if you're a beginner, stick to me and we will proceed with the next steps. And one final notice on the consistency level questions. Consistency level has doesn't affect anyhow how data will be distributed in the end, because anyway every replica server, every replica will get this information. It's a question of only for waiting for confirmation what it got it. That's very important to understand. So still every replica on every data center will get your update. So and there is a good question. I will even make a stop and answer. So Apurv Gupta, how Apache Cassandra database deals with a split brain? Very good question. So first of all, it's a really good question to ask for questions and answer session. I will send you the link again because you can win a prize with this question because it's a really good one. I like it, and if other experts will like it too, you may get a prize. No guarantees, but try. And use your name sending the question so we may identify you. In short, answer is, in case of a split brain, so network partitioning, we discussed it recently. In case of a split brain, those two servers, for example, those two data centers will be not able to reach this data center. There is a network spleen between them, network split. So we kind of have one cluster and second cluster, or one single cluster is split into two parts. How it works? What's the problem of a split brain in general? What people start to write data into both of them, like it may happen with a relational database when you have multiple masters. People start to write data into first part, into second part, there are two master services on MySQL, for example, and as a result, you have some changes stored in the first one, some changes stored in the second one, and you now have kind of two different clusters, and you cannot bring them together. It's called a split brain problem. Very good question indeed, Apurv. So how does Cassandra handle that? Very easy. Take a look. Here we have a network split, and we write, for example, with local quorum. That means, or we write with, we write with local quorum. No, we better go for the normal quorum. It's easier to explain here. When we write for a quorum, we see what 1, 2, 3 servers will answer. Those servers won't, if you write to this site, this server won't answer because we can't reach them, but we get our data stored here, and data is data insert mutation is executed for the first two data centers. But if we try to execute an insert into this data center with the same consistency level quorum, when we got into trouble because our query cannot be executed, and this data center cannot reach those two. Don't forget there is a network split between them. What will happen? Very simple. This data center will answer you, I cannot reach desired consistency level, I cannot store your data, sorry. And you may say like, okay, it's how come you cannot store my data? You have enough servers? No, I don't, because for consistency level quorum, we need more servers from other data centers, we cannot reach them, so it won't store your data. You may think it's bad, but no, it's not bad. Bad if it would store your data, and then you have an issue with you have two different mutations in two different parts of your cluster. That's what bad. And split brain is a real problem, not that one of your data centers doesn't work, right? So that's something we can survive. Don't forget about the CAP theorem. We always want to stay partition tolerant. So, okay, we are a little bit out of time, so I have to move on. Good. So, all about data and how data is stored internally. Next important Cassandra thing you need to understand. But meanwhile, let me check the second room if they started successfully. It's my event, so I'm really worried for them. Okay, Stefano is live in the second room. We can proceed. Good. So, data. How Cassandra stores data. What is the data structure for it? On our workshop Introduction to NoSQL, I like to ask people a question: is NoSQL schemaless? And a lot of attendees always answer, yes, NoSQL is schemaless. And it's complete wrong if you think what you want to if you think what NoSQL is schemaless, you are wrong, because there are more than 200 different databases in NoSQL group, and they are very different. Cassandra is NoSQL, but it's schema full. So, okay, sorry. There is one more question I do want to answer right now. Where is it? Taduri asks, how quickly we can switch to AP to CP and vice versa. Basically, it requires no time because you specify consistency level on each and every particular query you execute. And of course, there is a default, so you can set a default value. But if you want first insert to be executed on consistency level 1 and second insert to be executed on consistency level all, there is no time to switch. You just specify different value for the second query. So let's get to data. It all starts with a cell. What is a cell? Cell is an intersection of row and column. It stores data. Like in this case, there is a cell. It stores name. Let's go higher. A bunch of cells build a row. Row is a single structured data item in a table. So we have some ID, we have some first name, last name, department. That's a row. So far, so good. Then comes a new thing, partition. Working with relational database, I bet most of you have experience with a relational database. You use it to have cells, rows, columns, tables consisting of them. It's not like that in Cassandra, and that's very important for you to understand. There is one more thing you need to remember: a partition. Partition is the base unit of access in Cassandra, not the row. If you will forget about that, your cluster performance will remind you with some downgrades. So, data structure partition is a group of rows having the same partition token. It's a base unit of access in Cassandra. For example, in this table, we split our employees by department, and all the employees from the wizardry department will go to the same partition, and all our employees from the dark magic department will go to another partition. Oops, it looks like I exposed some of the personal data. Let's move on. Then, what is a table? Table is a groups of columns and rows storing partitions, and partitions is the most important thing in a table. Well, but in general, you know idea of a table. Rows, columns, partitions inside. How do we create a table in Cassandra query language? Very easy. So by the way, welcome to SQL. SQL stands for Cassandra query language, and it's indeed, as you see, very similar to SQL. And you know what? It's very good, and it's also very, very, very bad. Why bad? You may ask. Answer is simple. You know what? SQL is designed to be very similar to SQL. It's good because you can really easily learn it and start to use that, because concepts are the same. Create table, execute insert, read some data from table, It's the same. But there is a second issue. Why it's so close, it looks so similar to SQL, what many people make a mistake. And that's a huge mistake what leads to a huge problems. They know SQL, they see SQL first time, and they like, oh, SQL is so similar to SQL. I already know SQL. I can use Cassandra. No, they are not. Don't be like that. You are the best. You are attending our free educational event, so you are not like that. I know. Please watch that. SQL is indeed similar to SQL, but Cassandra is not similar to relational databases. It's a trap. And if you try to use Cassandra like MySQL without joins, you will run into troubles, I guarantee you. So watch thoroughly this workshop, watch data modeling workshop by Stefano. But besides that, yes, indeed, table creation in Cassandra is very similar to creation table in MySQL, for example. By the text we see, create table, key space, group of tables. A table, users by city. Some columns, city, last name, first name, address, email, text, 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 text. We have more data types than just text. It's just maybe not the best example, and we have to adjust it. Then let's go with a primary key, and primary key is different. Primary key is a very important concept. I will explain in the next slides. But in general, what you need to know at this moment, in primary key, we identify partition and clustering columns. What it all means, don't ask questions in the chat, just listen to me, I will explain. First of all, key space. Key space is the highest idea of the table. Key space unites multiple groups of tables. In this case, we create key space users, and when you create key space, there are many options to specify. but there is only one option you must specify. It is the replication. In replication, you have to specify class and replication factor per data center. So, well, first about replication strategy. There are currently only 2 replication strategies, and you may have or simple strategy or network topology strategy. Simple strategy is good for your laptop and bad for everything else. Don't use simple strategy as anything close to production environment. And network topology strategy is the cool thing. It's aware of your network topology. It means it understands what you have: servers, racks, and data centers. And that's very important because it will try to keep your replica servers as far away from each other as it possible. How come? For example, take a look. Here I specify replication factor by data center. For my data center, United States West 1, replication factor will be 3. And for Europe Central 1, replication factor will be 5. Now let's play a little game. I will ask and you will answer. Please answer in the YouTube chat how many data centers I have in this cluster. I'm waiting for your answer in the YouTube chat. 2, 3. Any more options? 2, 8, 2. Okay. No. You all are wrong. You all are wrong. Okay, enough. There are a few dozens of answers, but it's wrong. All of them are wrong. So, no, really, I need at least... Okay, Abhishek was possibly right. Unknown, yes, that's the right answer. Shashank was the closest one, but the real answer was, a real question was, now focus. Question was how many data centers I have. And the right answer, there are 2 possibly right answers. First of all, unknown. This statement may be not valid at all. I may have 0 data centers and this statement will fail. But considering this statement is correct, right answer is 2 or more. 2 plus. 2 plus. So, notice, question like 8, it's about replica servers. How much replica servers I will have. If you've answered 8, that's not about data centers. Your answer was about replica servers, not data centers. This answer is wrong. And most of you answered 2, which is also wrong because real answer is 2 plus. I may have 5 data centers. I may have 20 data centers within this cluster. I just don't want my data to be stored in all of them, but I want my users' data to be stored only in 2 of them. So overall, my cluster may have as much data centers as I want, but this data will be stored only in 2 data centers of the cluster. Overall count of data centers within cluster may be significantly higher, so the correct answer is 2 or more. Good. Right. So let's move on. I wanted to say one more thing on network topology strategy. Why it's important to use network topology strategy. Take a look. If you have your own on-premises data center, how it usually looks like. There is a server. A group of servers is in the server rack. So you have server rack and multiple servers in it. And then finally you have multiple server racks with multiple servers. Now take a look. What happens if all of the replicas for some token range are located within the same rack? The problem of the rack is servers within this rack tend to fail together because they have shared power supply. And as a result, the server rack tend to fail together. Also possible network outages and so on. So in the best case scenario, you want to keep your replica servers for multiple different token ranges as far away from each other as possible. Then you have on-premises data center with real servers and real racks. Cassandra will try to put replicas into different racks, so they will be not all in the same rack. And if you use not hardware on-premises data center, but you use cloud, like Amazon Web Services, for example, then you may have, obviously, availability. When within a region, you will have multiple availability zones. And in this case, network topology strategy is also aware of network topology for your cloud, and then it will put your replicas into the different availability zones. Why? For the same reason, availability zones tend to fail together. So if you have availability zones 1, 2, and 3, your replicas will be spread into the availability zones 1, 2, and 3. And if one availability zone is not available, there is an outage, then therefore AZ2 and 3 still will be available, and you can maintain quorum consistency even when the whole availability zone is down. I don't know about another cloud providers, but for Amazon Web Services, actually availability zone is a real data center isolated from all the others by some distance, has independent power supply, and so on. Good. So, game was quite interesting, but let's proceed. So, finally, example data, how it looks like. We have a key space, which is a group of tables. We have some tables, one of them is users by city. And we have two partitions, because we have users in Phoenix and Seattle. City will be partition key column. Last name, first name will be clustering columns, and there are some data columns. What is that? What is a partition, clustering, and data columns? Let's take a look at that. Yes, I will explain what the clustering columns. Don't worry, we are good. Don't rush, I will. So, first of all, what is the primary key? Primary key is an identifier for a row. It consists of at least one partition key and 0 or more clustering columns. So primary key is this all long line, city, last name, first name, email, and it consists of a partition key, which is a city, and clustering columns. A primary key has one main duty. It must ensure uniqueness of your data, must ensure uniqueness of your row. For example, compare this good example and this bad example. What's the difference? Same table, but keys are different. One key is good, second key is bad. Try to guess and answer, please, in the YouTube chat what's wrong with the second key. What's wrong with a second key? People in the same city can have same first name and last name. Right. It was easy. Indeed, last name and first name is not unique within a city. Especially, no, it has partition key. Scratch Games city will be partition key in both of them. So it's completely fine, partition key is present. But indeed, first one is good because we have uniqueness. In this case, I did a little check once. There are like a dozen of John Smith in New York. And can you imagine? Because Cassandra is a NoSQL database, it uses so-called upsert approach. So insert and update are essentially the same. And if you have your primary key like that, city, last name, first name, every next John Smith will overwrite data of a previous John Smith from the same city. And I bet previous one will be quite angry on you. I would be, at least. And Ravi says partition per record, too many partitions, which is not required. No, it's completely fine. You can have as much partitions as you want. It's completely fine to have partition per row. It's completely fine. Good. So, well then, what's next? Next is the partition key. Partition key is an identifier. Okay, and the last question from Nagesh. Why cannot we have in this example primary key as city email? Why first and last name needed? You are right. From the uniqueness point of view, last name and first name are not needed here at all, and our primary key indeed can be city and email, but we still may need last name and first name. I will explain it on the next slide when we will discuss clustering columns, because clustering columns use it not only for uniqueness, but for some more options we can use. So, partition key. You know already what partition key is: an identifier for a partition. Rows with the same partition key will go to the same partition. Partition key consists of at least one column, may have more if needed. Good examples: when we just have a table by users, only users, without a city, without anything. In this case, primary key user, and this will be a partition too. So primary key will match partition key, or better to say, primary key will consist only of partition key without any clustering columns. It's acceptable. In this case, we will have as much partitions as users we have, and again, it's completely fine, it's safe, you can have a lot of the partitions. And we can have, for example, you know what, we are on YouTube watching video. And imagine a table comments by video. We have comment and video ID, and we are good. They are split by video. It's fine for us because we can retrieve them together. They are stored on a single partition. But in some cases, it may be not the best scenario because, okay, for this one, I have a special slide. So I will explain to you later on a special slide. Finally, clustering columns, they have two duties. First duty is to ensure uniqueness as a part of a primary key. We discussed it with example already, right? City, last name, first name, brr, not unique. City, last name, first name, email, unique, great, works. So it's organized with a clustering key of email, but it's not the only job of clustering columns. There is a second job. So that's getting to Nagesh question before. Primary key, in this case, we use last name and first name. Clustering columns establish sorting order. So in this case, we will have our users sorted by last name and then sorted by first name on insert time very quickly. And that's fun fact: when you retrieve data from Cassandra, and if you want to retrieve it sorted already, Cassandra doesn't execute sort on select statement because data is pre-sorted on insert time. That's a very cool optimization. Hope I will have time to show it to you later. So, clustering columns are used to establish sorting order. For example, in this case, comment for a video. Video has multiple comments. You are writing comments right now. If we go like that, video ID, comment ID, they won't be sorted by time, and that's bad. But if we go video ID is a partition key, created, and comment ID, we have created that as a timestamp, and therefore all our comments will be sorted by time. And as a result, when we retrieve comments, we can show them most recent first very easily, and we don't have to change anything. They're sorted already. So now take a look. Those slides have slide of the year award, and that's of joke, of course, but still I believe those are the most important slide what you will see, at least during this presentation, that's for sure, and maybe all across the year. With them, you can build an efficient, scalable Cassandra database. Without them, I'm afraid you can fail, so please pay attention to what's going on right now. That's important to understand. Only 3 rules, but it's very important to follow them. Store together what you retrieve together. Avoid big partitions. Avoid hot partitions. So, first, what does that mean, store together what you retrieve together? Example, you open a video on YouTube. We, as a YouTube, want to show you all the comments for this video, most recent first, for this exact video, right? All the rows within the same partition are stored together. As a result, when we retrieve rows, we are going to get all of them. We better to get them, all of them, in a single query, asking one single server, or at least 3 servers, but not a dozen of them. So we want to fetch one partition. In general, try to fetch as less partition, try to make as less separations as possible. If all your data in a single partition, we need to try to fetch on a single partition. It decreases load on cluster and decreases amount of network operations. Database works faster. So this example is good. We partition our comments by video ID. We also have created it and comment ID for a primary key, so we will store comments sorted by time, and we will have them unique, so next comment will not overwrite a previous one. But what matters, they partition it by video ID. As a result, I can retrieve all of them knowing video ID. Second point, this example may be not so good. If we don't partition our comments by video, we partition them based on something else. Will it work? Yeah, yes and no. Take a look. Imagine you are ordering pizza. When you order a pizza, do you specify a full address of your apartment or your house? I don't know about you, but personally I do. I do specify the full address. If it happens what I wouldn't specify the full address, how that would work? Delivery boy will have to knock to every door on my street and ask everyone, hello sir, did you order pizza? Hello ma'am, did you order pizza? As long as it won't reach my house. Does that sound stupid to you? For me, it does sound stupid. That's why when you order pizza, you give the full address. Now take a look. What is a partition token in Cassandra cluster? Partition token is the full address, is your apartment number or your house number. And then you give the full query like select comments with video ID 3555333355555555. Your driver will calculate particular values, particular token for this partition. And as your driver knows which server is responsible for this token range, it will go directly to the server responsible for this token range, grab your grab your data and give it back to you. But if you won't specify the full partition key, it cannot calculate the right server, and it doesn't know where to go. What will happen then? It will tell you, are you sane? Like, are you fine? There are 1,000 of servers. Should I ask all of them? No way, I won't doing that. And you get an exception. I'm not going to make, I'm going to ask them every server in my cluster. It's called full cluster scan. I won't do that. And then there is an option in Cassandra. You can force your database to go and knock to every door on the street or every server in your cluster to ask, is you may be responsible for this data? As you may be responsible for this data. As long as you have 3 servers, it may work. Then you have more than 1 server, more than 3 server, or maybe 3,000 servers. It's as stupid as it sounds. Then you order pizza, you specify the full address. Same rule applies to Cassandra. You specify, you will work with data, you need to understand the partition. That's why this example, when you are going to retrieve all comments by video, is bad. You don't specify the video, and therefore you cannot reach the comments without forcing your database to do a full cluster scan, which is a very bad practice. There is a Great question on time from Apurv Gupta. Can partition key be composite? Wait a second, you will see. So, store together what you retrieve together. That's quite clear. Second, avoid big partitions. So, what does that mean? Take a look. There is only one hard limit. You cannot have more than 2 billion cells per partition. How to calculate amount of cells? Very easy. Multiply rows by columns and you have amount of cells in your partition. But there are some recommendations, those are much more strict. We recommend you to have up to 100,000 rows in a partition and up to 100 megabyte in a row partition. Those are best practices. You can go above, but try to still keep your partitions fit, because it's not good when you have too big partitions. Your system doesn't going to work too well. And we at DataStax work a lot with different Cassandra deployments. Worst partition we've seen so far was 1.2 terabytes of data. It's disgusting. Don't do things like that, or I will come to you in your nightmares and ask you again not to do it in person. Avoid big partitions. How does that work? Take a look at the first example. We have again video, comment by video. Video ID is a partition, created that, and comment ID as clustering columns. Our comments clustered, partitioned by video. That makes sense because store together what you retrieve together. And then when I'm going to retrieve all the comments by the video, I have a single partition, I can get it, that's all good. But you can tell me, hey Alex, you just told us up to 100,000 rows in a partition. And there are some videos in YouTube what have more than 100,000 comments. You are right. But take a look. What's the problem of, what problem we can face in this case? First of all, will we have a too big partition from the size point of view? No, we don't, because although we can have more than 100,000 comments per video, they are still very, very small. What is a comment? Timestamp, author name, author ID, comment text, video ID, comment ID. 6 fields, maybe a little bit more, but all of them are text fields, small fields. So, okay, even if we have 200, 300,000 comments per video, they're still very small. So from the size point of view, they will be fine. Second point, it won't lead to problems from the deletion data point of view, because deletion is a separate story. Payal from Python will tell us about Tombstones today. Also recommend to attend. But in general, as you wrote the comment, you usually don't edit it too often or don't delete it. Many systems don't support deletion or editing of your comments, like Twitter, for example. And as a well, at least not after some time. And as a result, we will not have the system overloaded with these kind of operations. So it's fine to have it like that. But what's wrong with this example then? Country and user ID. Imagine we all together work in the e-commerce company selling our goods in Europe. Europe has a lot of countries, usually not so big, and we decided to partition our customers by country. And we sell in Belgium, and we sell in France, and we sell in Italy, and so on and so forth. And we are doing well, and everything goes good, till one day we go with our goods to India or to China, for example. And somehow our goods were very in high demand then, and they are extremely popular. Like everyone wants to buy something from us. First of all, colleagues, congratulations, it's amazing. Now we have a lot of money, that's all good. But now there is a problem. In comparison with Europe, Asia tends to have smaller count of countries, but much bigger, at least some of them, not all of them, of course, but some countries are much bigger from the population point of view. Let's imagine we got huge success in China. Literally everyone from the small babies to the elders buying something from us. What happens in the result? We have we have partition from France, one partition from Italy, one partition for Monaco, which is a tiny country, and we have like 100 clients there and like 1 billion clients in China. What happens as a result? Our partition by country will be too big. And you can tell, okay, Alex, don't worry, we have money, we will buy more servers, we will expand our cluster, it will be all set. No, it won't. Why? Because with a replication factor 3 per data center, we have 3 replica servers for the partition. And if we had 10 servers in the beginning, now we have money, we buy 10 more servers, our cluster now is 20 servers. What will change it for the partition? Nothing. Because there are still replica servers, 3 replica servers responsible for this partition. That's like try to extinguish fire, throwing paper into that. You can add 1000 servers, it won't help. Still have one big partition, one overloaded partition, which is blocking everything and all on this server. So, second trick of the partition size you have to remember, avoid big and constantly growing partitions. That's a real situation, real use case happened with one of our clients. I will give you no names because, well, of the client secrets, but it's a real use case I've seen in my life. Imagine huge telecommunication company, huge Internet of Things infrastructure, hardware all across the world, different sensors reporting their state every few seconds. Every sensor makes a simple report. Sensor ID, timestamp, value. So sensor ID is basically the unique identifier of the sensor. Timestamp is when it happened, and value is what happened. A value is like temperature or humidity or network output at this moment, and so on and so forth. So whatever sensors can report can be here. And we need to store this data. So original design for the table is sensor ID and reported at. Is it a good design? Let's take a look. We partition data by sensor. Does it make sense? Well, watch the first rule. Store together what you retrieve together. I tend to retrieve the data for the same sensor together, so it quite makes sense. If I want to understand the temperature fluctuations in my server room in a data center, well, then I can get the historical data from the sensor very easy. And we use reported at, so the report time, first for uniqueness and second for sorting order. So far, so good. So this design definitely makes sense. And everything went well, everything works, but when something bad happened. Now, please answer in the YouTube chat what happened and when. Hey, Partha, that was a very fast and very good answer. I actually it actually was very fast indeed. Did you attend one of our previous workshops? So, indeed, in the beginning it will work, but as every sensor reports its status over time, partitions will grow and grow and grow and only grow. And as a result, after a few months, considering they report their state every 10 seconds, you will have huge partitions. How do we solve this problem? There are two options. First one is put TTL, time to leave. Cassandra is a really cool database, I told you already. Cassandra can have TTL, time to leave, per row and even per value per row, which is cool. So when you store a data, when you insert a row in Cassandra, you can set a time to leave and you can specify, I want you die in 2 months. As a result, in 2 months, this row will disappear. And therefore, partition will be growing only till they reach TTL, and then old rows will disappear. That works, and some clients are using this feature. It's quite cool, but for some cases it's not enough. But in this particular example, our client wanted to store data for many years, and they didn't want to delete it after a couple of months. Okay, how do we solve that then? Composite or compound partition keys. That's the answer to a previous question. I don't remember who asked that, but doesn't matter, someone asked that. What is a compound or what is a composite partition key? Take a look. In the new better design, we suggested our partition to consist of sensor ID and month year, and then reported that as a clustering column. So this part is good. Basically, we introduced only month year as a new part of a report, or new part of the data we insert into Cassandra. So sensor ID, timestamp, and value are still the same. But month year, it can be integer or a string, but it's a new value we add to the table, new synthetical value. How does that look like? Very easy. Today is July of year 2021. Therefore, month year will be 072021. And next month, August, will be, my God, next month is August. That's awful. Where is my summer? So next month will be 082021. What it makes then? Imagine we have sensor ID 1 and our month 072021. So we go to we are getting these reports, and sensor writes. We have a single first partition for this sensor. Then month is over and we have August. This value will change, and as a result, hashed value, so token, will change as well. And we create a new partition and we write to a new partition, or better to say, Cassandra creates a new partition for us. So as a result, we have new data stored there, and it is available always, and we have multiple partitions. So we don't have constantly growing partition. As soon as month is over, data will be moved. The data will be stored to a new partition. And basically, a lot of people usually ask at this point, what's the why can't we use just timestamp, or why can't we use date? Why can't we use hour for this field? Answer is, while we are using month, is very simple. Idea is, don't forget, when you query for data, you have to specify full address for your pizza delivery or full partition key for your Cassandra. And as a result, if I'm going to query data from a sensor 1 for 3 last months, how my query will look like? Select all from sensor data where sensor ID equals 1 and month year in May, June, July, right? As a result, I have simple where sensor ID equals something and month year in a list of 3 possible values. So my select query is simple, sane, and reasonable. But if I specify something smaller than month, if I specify day, if I specify hour, if I specify second approve, how my query will look like if I'm going to retrieve data for the last 3 months for the same sensor, if I'm using hours, for example. Still the same, select all from sensor data where sensor ID equals 1 and timestamp or hour is equal first hour of May, second hour of May, third hour of May, fourth hour of May. You get the idea? Basically, my select statement will be huge, unsupportable, and I will have to query for very many different partitions. So store together what you retrieve together, Shashank, that's right, and avoid big and growing partitions, right? But also don't make them too small if you don't really need that. So you need to keep the balance and understand when to stop. That's how we do it with bucketing. That's how we do it with compound partition keys. And finally, Next part is rules of a good partition, avoid hot partition. Basically, I explained it to you already on the example of a country. When you have multiple countries with a small amount of clients and one huge country with a lot of clients, this partition will be hot. Everyone will be doing operations with this partition all the time. And as a result, it's overloaded whilst others are idling. And the worst thing, you cannot scale because you can add as much servers as you want. That won't help as long as all the load goes to a single partition. That won't help. So avoid hot partitions by spreading workloads. Then adding more workload will grow amount of partitions, because when you have multiple partitions and I have 3 servers, everyone is responsible for 5 partitions, and it's getting hot. I have a lot of clients, all of my partitions are overloaded. What I can do, I can add more servers. Cluster will recalculate token ranges and spread data over new servers, and as a result I will have less pressure on each server, workload decreased on each one of them. So that works very well. So this one we've seen already, and you know what, we have few minutes left. I will show it to you on the next one. Right now I'm not interested in that. I want us to go to lab directly. So that won't be a workshop if you don't push the buttons. Now I want you to run Cassandra cluster and put some data into that, and you can tell me, hey Alex, we have 10 minutes left. I will download now Cassandra, I will install Cassandra, I will run multiple nodes of Cassandra, build them together in cluster, set all the things up, and it will take approximately next hour. How the hell it's going to happen? Answer is Astra. So Astra is a Cassandra as a service offered by DataStax. You don't have to deploy your Cassandra because we already did that for you. And oops, so let me switch to it. Yes, you have a link on this page, github.com DataStax devs workshop intro to Cassandra. I will throw this link to you in a moment. DataStax dev workshop intro to Cassandra. So you don't have to deploy Cassandra because we did that already for you, and you can use it for free. What do you mean by free, Alex? Alex means free. So as long as you don't run production workloads on your Astra cluster, so Astra is a Cassandra as a service, you don't pay us at all. You got monthly credit of $25. That's like 40 millions of read operations, some millions of write operations, like 40 gigabytes of data. So if you earn money with Astra, then well, we will bill you. If you don't earn money with Astra, we won't bill you, and you can use it for educational purposes as long as you want. So I send you the link, and for the Astra step, now I will show you how it works. So it's going to be github.com DataStax devs workshop intro to Cassandra. And that's the place you will get intro to Cassandra for developers. We will do a lab part from this one. It consists of 3 simple steps. Create your Astra DB instance, or better, get your Astra DB instance because it's created already by us. Create a table and execute simple CQL operations, Cassandra Query Language operations. And we can do it together, or you can do it after the workshop. So first I go to AstraDataStax.com. Oops, I want to do it in a new tab. You're right. I already have my Astra account, so I will simply sign up with Google. And in your case, you may also sign up with Google or GitHub or whatever you prefer. Next one, you will have no databases, so you will be asked to create one. You will get to this page like I do already, and you see this current plan is free tier up to $25 per month, then pay as you go. Then I'm creating a database. I have to specify database name and key space name. So obviously I will use values as it recommended from these DataStax devs workshop intro to Cassandra. And database name for me will be Killer Video Cluster. You can put yours, but in general I recommend to follow the instructions. And key space will be Killer Video. Now, answering question by Apurv, select provider and region. Currently, Astra supports free provider, Google Cloud, Amazon Web Services, and Microsoft Azure. You can pick any of them, it doesn't matter. I will choose Google Cloud because I'm a certified Google Cloud architect, so it's kind of native for me. And from a region point of view, pick any which is closer for you. So I will specify Europe and I will choose Belgium, Europe West 1, because it's the closest to me. And here on the right side, you can see the current plan, free tier up to 25 per month. And you can see what 1 million of read requests cost less than 40 cents. And write request, 1 million of write request costs less than $1.15. And storage is like 27 cents per gigabyte. So basically using this free tier up to 25 per month, you can have a lot. So sounds good, and I push the create database button. Good. Now your list will be less complete and a bit smaller than mine. But you see I have this Killer Video Cluster and the status pending. So to make me not wait, I will actually use the previous Killer Video Cluster to proceed with the steps. It's also Europe 1 in GCP. You don't have to follow this, but if you want to get an attendance badge, participation badge, then you will have to complete it in your pace and then submit this work as explained in this workshop intro to Cassandra. By the way, if you want to get a nice badge for this intro to Cassandra, let me show it to you. This one, I believe. No, it's a Cassandra. I want to get back. DataStax developers. If you want to get a nice shiny badge intro to Cassandra workshop like this one, we have already more than 200 people awarded, and you can be the next. Then you can, and that's all verifiable, so you can view it. You will be able to verify your own badge. It will look like that. Nice. You can put on your LinkedIn, but you will have to submit your homework. Okay, but we have then how do we connect and how do we start working with that? Idea is very simple. Every database has here a connect button and SQL console button. Now we will stick to SQL console, and it will take a moment to start for Cassandra query language shell, and we are good. So I can now work with my Cassandra cluster directly, and it's all in cloud. I don't have to install anything. And I can say describe key spaces. And that's all my key spaces I have here. Then I can say use killer video. I'm using key space killer video. I can create a table as explained here. Right, I can create table if not exist user by city. Good. So I simply copy paste, execute that, and I have my table created. I can ask for describe table users by city, and I have my table here, describe it, and then I can start inserting and updating data. We are almost out of time. So I will just show you how do we execute insert, and then you will proceed without me, because everything is explained in the link GitHub repo I sent to you. Good. So finally, final step of this exercise is create, insert, update data. So basically we can just throw away data like that. I copy it from that and paste it to my cluster, and data is here. So I can now execute a select statement and get my data from here. Okay, looks like I have successfully inserted some data. So this part is over. What is next then? DataStax.io India. Yeah, I was a little bit in a rush in the end, sorry, but it's all explained by the link I sent to you, so you can start using Cassandra with this part. Now, next one going to be a quiz. And quiz means a game. We will start quiz in 2 minutes. So I will get back to you in a moment. Stay here, answer questions, and win the prizes. You don't have to be a Cassandra expert, because if you listen thoroughly enough, if you get what I say to you, then you will be good. So I'm launching, I'm executing a little hold on pause. And I will get back to you in 2 minutes and we start the quiz.
Okay.
Okay, so welcome back. Hello,
Welcome back.
everyone.
Hi.
So
Nice to see you again.
nice to see you all. That's Stefano Latini and Alex Voloshev, developer advocates at DataStax, and we are happy to greet you here today. And let's play a game. Let's win some prizes, and let's go to Menti. Menti is the tool we use to ask you questions, and if you give the right answer, if you answer fast enough, you get the prizes. That's how it works. So, how do you join? First of all, I paste the link to this quiz on YouTube chat. Second option, you can just open menti.com and use the code 78705295. And we will start with the simple questions before quiz, so you will be used to Menti. My personal suggestion, use your mobile phone to go to Menti. It's the easiest way, so you can watch and meanwhile answer questions with your mobile. It's the best way. And let's start with the first preparational question. No rush, it's just a training yet. It's a drill, not a real competition. Let's start simple. What's your experience with the relational databases? MySQL, Postgre, whatever you prefer. Oh, black belt in joins. That is cool.
Wow.
A lot of experienced developers, and looks like only one person with zero experience with relational databases, mostly probably a student, I would guess. So you get to the right place to improve your knowledge on NoSQL databases. Although this ride may be a little bit rough for you, stay strong, you will be good.
Yeah.
But most of the attendees definitely have good experience, black belt in joins, use relational databases all the time, or at least a little. That's already something.
Well, I would say to all those who have knowledge of relational databases, you come to the right place if you want to learn something new.
Right.
So
next then, what's your experience with NoSQL databases? Zero, a little, a lot, NoSQL guru. And it's a little bit weird question because there are very many different databases in NoSQL, and it would be a mistake to put them all together, but
we do in this question.
But we do. In this question we do, and it's completely fine. So I see. Oh, we are getting more and more attendees, more and more people jump in.
Nice.
That is good. So we will have some competition in the end.
Yeah, it will be tough to win the swag.
Yeah, this time we have a lot of attendees. And last question. What's your experience with Apache Cassandra or DataStax Enterprise or DataStax Astra? Okay, we have a lot of newcomers. We have some more experienced people. But most of you are beginners, and that's completely fine. That's well expected distribution of votes, because, well, that's a good place to start. But you know what? We have a second room with talks. What a better fit for people with experience with Cassandra. So far, so good. Then we can start and let the battle commence. Now, focus, warm up your fingers, warm up your brain. You will have to answer as quick as possible. And now notice, YouTube stream has a little delay. 1 second of delay by YouTube. I cannot change that anyhow. That's on YouTube side. So personally, I recommend you to watch your Menti first and then YouTube, because questions will appear a little bit earlier on your mobile phones than on YouTube.
Yes, so look at your phones. And this time, answer fast and answer correct.
Yeah, now we have right answers and wrong answers. You know, that's not wrong answer to say, I don't know NoSQL. That's a great answer. You're here to learn. But now that's a quiz competition and we have right answers and wrong answers. So ladies and gentlemen, start your engines because we start the quiz. And that's going to be question number 1. So answer fast to get more points. How many master nodes does Cassandra need? At least 3 per cluster, 3 per data center, not a single one, Cassandra is decentralized, enough to maintain consistency. And time is up. I want to see your answer. Oh, such a shame. Such a shame. Only 42 people gave the right answer. Cassandra is decentralized. So there is 0 master nodes, no master nodes. They don't exist in Cassandra. An answer 3 per cluster or 3 per data center is obviously wrong. This concept doesn't exist.
Yeah, that's a typical mistake of people used to other NoSQL databases.
Yep.
Every node is created equal in Cassandra.
Yeah, that's true democracy, you know.
Yeah.
Well. So let me see leaderboard. Who is on the first place and who went not so fast? Skids went fast enough with 927 points, getting to the fastest place. Then Boati on the second and Zlatan on the third. But everything will change because we have more questions. So, ladies and gentlemen, answer fast to get more points. How data is being distributed? By partitions, all data is replicated to each server with address locators using postmail. How data is distributed? Okay, and your time is up, and this time that was better. Looks like you paid attention to the previous talk. Data is being distributed by partitions. Answer, all data is replicated to each server is obviously wrong. Were you at the first talk done by a cloud data architect of Netflix, Vinay Kumarchella? They have a lot of data, like really a lot. If they would copy all data to each server, they will went bankrupt to the very next day because data storage is not so cheap at this scale.
Yeah.
So, who was the fast and who is not so fast and who made the mistakes? Saurabh was fastest, and with 1,881 points, he gets to the first place. Great job. Keep fighting.
Well done.
Sarkar keeps his position in the top 3, and Skids went to the third place, which is still enough because first 3 places will get the prizes. And what I really vote for is all the coffee to Alex on the 9th place. Thank you. That's exactly what I need. And actually, that's what I just got 1 second ago. So, let's move on then. That's going to be question number 3. And answer fast to get more points. How to scale Cassandra cluster?
That's a nice
How
question.
to scale Cassandra cluster? Vertically, upgrading servers. Or maybe increasing scaling factor. Horizontally, by adding more servers. Or just you don't need to scale, Cassandra performance is always enough. What do you think? What do you think? Time is up. And most of you gave the right answer. You scale Cassandra cluster horizontally, adding more servers. Not vertically, not increasing scaling factor. There is not such a thing. It's a joke. There is no scaling factor in Cassandra. You may mean replication factor, but it doesn't help you to scale the overall cluster performance. And fourth option, Cassandra performance is always enough. Oh man, that would be great.
Yeah.
But let's move on. And let's see on the leaderboard. Who made a mistake? None of the leaders made a mistake. And Saurabh gave the fastest. That's such a performance. 2 fastest answers in a row. Amazing. Skids holds his second place. Very well, but Metha got to the third place. That's a good. And take a look. All the coffee to Alex climbed to the 8th place. Keep fighting. Keep fighting. I need more coffee.
If he wins, you will get your coffee.
Yeah. No, you know what? I'm going to get my coffee in anyway.
Yeah.
Good. But,
so there's quite some competition here.
Indeed.
Very good.
We are only starting.
Yeah.
So that's question number 4. Answer fast to get more points. which replication factor is recommended? 1.5, 3, 15, 42. Which replication factor is recommended? 1.5, 3, 15, 42. Time is up, and I want to see your answers. Okay, it was easy. Most of you, 86 people answered replication factor 3 is recommended, and that's right. Some of you said replication factor 15. And, well, ladies and gentlemen, that's frankly speaking too much.
Too much.
Yeah, maybe if you have 5 data centers and you have replication factor 3 per each, it's fine, but not replication factor 15 per se.
Yeah.
And 1.5, I have to ask those 7 people, how do you imagine half of a server? Like, should I use a chainsaw to make some Cassandra cluster? You're able to use 1.5? I tried that, doesn't work. I don't know why. Half of a server just don't work. Sorry.
Not even gluing it together.
Yeah. Laser may work as well.
Stopped working.
You know, I approve. I'm an old school guy. I prefer chainsaw.
Yeah.
So, Gaurav Gupta was fastest this time, getting to the 8th place, and that's a great result. All the coffee to Alex keeps growing. Now it's a 6th place, but the top 3 looks like that. Saurabh, Dinesh, and Mukesh Garg. Great job, people. Let's move on.
Also, Rahul is climbing up.
Yeah, that's
slowly gaining the podium.
Question number 5. Answer fast to get more points. Cassandra cluster can be deployed on AWS only, any combination of cloud providers on-premises data centers, only one cloud provider of your choice, Sega Mega Drive. I would love to take a look at that. Well, you can deploy Cassandra on Arduino. It isn't going to work very well, but... Okay, so it was easy. Any combination of cloud providers and on-DC premises simultaneously. Cassandra is platform agnostic, and data and cluster consists of multiple data centers. And to answer questions, please use menti.com, not the YouTube chat. This way you have more chances to win prizes. So, how it goes on the leaderboard? No mistakes by the leaders. Maybe we need to add more complex questions. So, Saurabh was the fastest again. Dinesh holds the 2nd place and Mukesh the 3rd.
And the coffee. Coffee.
4th place.
Is almost there. Also Rahul.
Rahul is keep fighting, and take a look. There is only 3 points difference between Mukesh and all the Alex. 3 points, it's like 1 millisecond. So Mukesh, stay strong and keep fighting. You have to keep your 3rd place. Okay. So, question 6, we are in the middle. Answer fast to get more points. Cassandra cluster can have multiple data centers. Wrong. Single cluster can have only a single data center. Correct, but not more than 2 data centers. Correct, some data centers are passive, only for read. Correct, all data centers are available for read and write. Okay, try to surprise me. Okay. You know what? What I can tell about that? You see, there are a lot of people, I would say 4, 19 plus 9, what still thinking these relational databases thinking. You see, it's really very relational. Single cluster can have only 1 data center. Such a shame. No. Correct, but not more than 2 data centers. No. Correct, but some data centers are passive, only for read. No! Yes, all data centers are available for read or write, and you can have a lot of them within a single cluster.
Yeah,
Isn't
I wonder
that amazing?
Sometimes the word replica might trigger false associations, because in other databases, speaking of replica databases, implies that they are only read-only, actually. And Jeremy in the chat makes a nice remark. What's nice is that you can add data centers without downtime to your application. Absolutely true. Very good observation.
Yes, thank you,
Very
Jeremy.
powerful.
That's indeed very important information. You can add more nodes, you can decommission nodes, you can add data centers, you can decommission data centers. Cassandra is designed to have zero downtime deployments. It's not easy. It's a shared responsibility. Cassandra gives you tools. You have to use them properly. But together, Cassandra and you will build a perfect, successful zero downtime team.
Yeah.
So, leaderboard. Are there any changes? No mistakes for leaders. And what are the changes? Gaurav Gupta was the fastest again, getting to the third place. That's incredible.
Well
Dinesh
done.
lost his position, getting to the fourth place.
Yeah, but by 1 point.
But 1 point difference.
1 point.
Oh man, that's so close. So like, the battle is not over yet for Dinesh. Dinesh, keep fighting. Saurabh holds his first place. Mukesh hunts him like very, very close. And Gaurav made it to the top 3, to the prizers list. So that is interesting.
But that's not yet the end of the story.
Exactly.
There are more questions. Everything can happen.
So, that's a question number 7. You know what to do. Answer fast to get more points. CAP theorem claims what in case of failure, C, A, and P are all guaranteed. Only A availability is guaranteed. Only 2 of 3 capabilities are guaranteed. Or maybe we are going to need a new cap. Few seconds left. You have to decide quickly. Did you pay attention? Right! CAP theorem claims what in case of a failed state, only 2 of 3 capabilities are guaranteed. And there are 17 people answered what CAP are all guaranteed. And you know what? Stefano, I think we have to ask them where do they live, because I'm going to move. I will move.
Yeah, I would like to live in such a world.
Yeah, that would be amazing. Guys, you mostly probably have rainbows and unicorns and dragons, because, well, that's the only
It is a
way.
mathematical impossibility in this world, unfortunately.
Yep. So,
like square in the circle.
yeah. You have to pick only 2 out of 3.
Yeah.
Okay, so what about the changes? Still no mistakes by the leaders. Leaders are doing very well. And Saurabh was fastest, and Gaurav take over Mukesh. Okay, but Dinesh is very close, still there. And Albert is crawling smoothly to the top. So we will see how it goes, and we will see what we will have in the result, because the battle is not over. And that's going to be question number 8. So, to get more points, answer fast. Recommended way to reach immediate consistency is read-write 1-1, read-write 1-all, read-write quorum with a video chat. Well, when I have to reach a consistency with Stefano, we work together. We usually use a video chat.
Yeah.
So
that
maybe
works pretty well.
Yeah, maybe it works for Cassandra. And most of you gave the right answer. Recommended way to reach immediate consistency is read quorum, write quorum. Answer read, write 1-all. Second answer also will give you immediate consistency, but it's not the recommended one.
Yeah.
And read-write 1-1 is quite a bad way to reach immediate consistency, because do you remember the formula? 1 + 1 = 2. If your replication factor more than 2, so mostly probably it's 3, then boom, you don't have immediate consistency at all. So, show me the leaderboard. Okay, so like all the leaders are giving the right answers all the time. And Saurabh was fastest. You know what? There are no changes on the leaderboard after this question. It was too simple. It was too simple. Harshvardhan, please try to reload the page with Menti. Sometimes it happens, we are sorry. So, you know what? That's going to be question number 9. So, answer fast to get more points. What is a key space? What is a key space? It's organized into rows and columns. It contains tables and defines replication. It defines it with partition key and contain rows. It's the place to store keys. 5 seconds to go. And your time is up. And the right answer is key space contains tables and defines replication. It's not organized into rows and columns. It's not defined with a partition key. Key space contains tables and defines replication for the tables within. So someone was too much in a rush.
Yeah, let's see the effect on the leaderboard of this.
Okay.
It will have changed a lot.
Yes, I think so.
Well.
So Gaurav was the take a look. Albert made it to the top 3.
Oh yeah.
Yeah, that's cool. So Saurabh holds the first place. Gaurav made it to the
it's
second.
A close call.
Yeah, fastest answer. Good, Gaurav. But Albert made it like very smoothly. Faster.
Yeah.
And he's in the top 3. And well, all the coffee to Alex is on the 5th place. That's still good result. And let's take a look. We are getting to the end, and that's question number 10. So answer fast to get more points. What is required in a Cassandra table? Data columns, clustering columns, partition keys. Nothing is required. Everything is allowed. Your time is almost over.
Yeah, the last one sounds like a philosophical position in a sense.
Yeah. Time is up. And we see what most of you gave the right answer. Partition keys are required. Clustering columns and data columns are optional indeed. So, what about the points? Who was the fastest this time? Mukesh made a mistake. Oh. He lost his chance to fight for the top 3.
Yeah.
And Gaurav was the fastest again. Like, we have a very strong competition here. And all the coffee is 40 points
position.
difference. 4 position with 40 points difference. That's a good. But let's take a look. Hey, Apurv, I see you in top 10. Top 10, then you have almost 100 people competing. That's already a great result, by the way.
Yeah.
So, question 11 of 13. Answer fast to get more points. Cassandra tables contain multiple partitions, only rows and columns, replication factors, endless seas of dreams and fears. You are answering fast. And your time is over and the question is done. So, most of you gave the right answer. You see, 65 people already have this right Cassandra mindset. Multiple partitions, table contain partitions, not only rows and columns. That's important. And replication factors are defined by key spaces. And we are getting closer and closer to the end. And I can't believe it. Albert, you did so great. Now it's time to say goodbye. Hello, 6th place.
Yeah, but the coffee to Alex
made it to the third.
The third position.
Okay, that sounds good. So Saurabh on the first place. Gaurav Gupta is very close to him with 200 points difference. That's not a lot. All the coffee to Alex on the 3rd place, and Rahul is ready to fight for the 3rd place, staying on the 4th. Let's take a look on the next question. It's question number 12 out of 13, so focus. Answer fast to get more points. How Cassandra executes joins. Joins require dedicated join table. Like in SQL, it doesn't. It does, but kinda lazy. This one's going to be interesting. So, how Cassandra execute joins? Right answer, it doesn't. Cassandra is a NoSQL database. It doesn't have foreign keys. It doesn't have relations. It does not have any joins. There is nothing to join. And by the way, how you imagine joins on a distributed system with thousands of servers and petabytes of data? That
Slow.
won't work.
I imagine them very slow.
Yeah, very, 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 very slow, exactly. So, right answer, it doesn't.
No joins.
And then you may ask, okay, how I'm working with data at all after all? And you know what? There is a gentleman next to me. Well, how next to me? For 1,000 kilometers next to me.
But here
still,
in the screen anyway.
Yeah, but here in the screen anyway. He will answer this question in the next workshop, which is going to be data modeling workshop.
Yeah, it's a 2 hours answer, so be prepared.
Right. Yeah, but you know what? We want you to be the best engineers and get the best salaries.
Oh, yeah.
And to get that, you need to pay some time and attention. So, leaderboard, one question. Oh my god. It was frozen for a half second, and I decided what Saurabh made a mistake, but he didn't. Very well. So, first place is still by Saurabh. Second place by Gaurav Gupta with the fastest answer. And all the coffee to Alex is on the third, and Rahul is there following all the coffee, trying to fight for the third place in the very end. So, you know what? It's going to be last question. So, free your mind, warm up your fingers,
concentrate,
prepare. Focus. Breathe out, breathe in. We are starting the last question. Answer fast to get more points. Single data center cluster of 8 servers. How many servers we have to add to double performance? 4, 8, 12. It's not possible to double the performance within a single data center. A little bit nervous you are, right? And the right answer was 8 servers. Cassandra has 0 overhead on adding new nodes. So if you want to double your performance of your cluster of 8 servers, you have to double amount of the servers. So some of you asked for it. It's not possible to double the performance in a single DC. It's wrong. It's possible. 12 servers, usually you don't need. Usually double the amount of servers under normal circumstances is enough to double the performance. And some of you answered 4 servers. Again, I believe, you know what? These 14 people who answered 4 servers to double the performance of 8 server cluster, I believe those are still the same people from this miracle land where you have C, A, and P simultaneously. Like, people really send me the key to your magic world. You cannot double cluster performance with less than the size of the current size of the cluster. So sorry, that won't work. Right answer is 34. People gave it's 8.
And let's see.
Oh my god, I'm so nervous. I'm so nervous. I just cannot open the leaderboard key. Alex, stay strong. You can do it. The leaderboard is no mistakes between leaders. Saurabh and Gaurav Gupta gave the answer in exactly the same millisecond.
Wow.
With Saurabh get the first place, Gaurav Gupta made it to the second place, and all the coffee to Alex made it to the third place. And we can first, please, winners, top 3 places. Make, please, screenshots of your phone or whatever you use. Make a screenshot to fix your winning position. You will need it in a moment.
Congratulations, everyone.
Congratulations, everyone. And I know I want to congratulate.
But Cedric is claiming he's all the coffee to Alex.
Ah, okay. Hey, Rahul, nice surprise to you. Rahul P, you are getting the prize because Cedric was all the coffee to Alex, but he is an employee of DataStax. He cannot get the prize. So Rahul...
He tried to, but we spotted him.
So Rahul gets to the third place because all the coffee to Alex is a DataStax employee disappearing from the list, and therefore Saurabh, Gaurav Gupta, and Rahul made it to the top 3. That's such a story. That's a plot twist.
So Rahul, take a screenshot. We will tell that you deserve your prize.
Thank you, Rahul. Thank you, Rahul. I really
That's
appreciate.
crazy.
Yeah, that's such a game. Great. So I have to congratulate 3 groups of people. First, our winners, Saurabh, Gaurav, and Rahul. You are great. You made it to the top 3 in a very rough competition. And that's incredible result. You are the best. You will get your prizes. Make a screenshot and send it to jack.pryor@datastax.com. Stefano, could you please put Jack's email?
I wrote it already.
Already? Oh, thank you.
I will repeat it, but I have to change. So Saurabh and Rahul P. I have to change the message because this was a absolute surprise to everyone.
Yeah.
So okay, so here you will see there is an email address. Please take a screenshot of you winning and send a screenshot.
Yes, send a screenshot to Jack. Say hello to Jack. Then I have to congratulate those who made it on the leaderboard. So all the people, Saurabh, Gaurav, Rahul, Bushan, Shishir, Harsh, Srinivas, Medha, Subba, you made it to the top 10 out of almost 100 people competition. That's a very good result. You don't get the prizes if you are not in the top 3, but still it's a great result. And I can only say we run workshops related to Cassandra every week, so better luck next main team. And those who made it to a quiz but didn't made it to a leaderboard, do not be too disappointed about that. Yes, we send the prizes to the winners, but you know what? That's not houses, that's not Ferraris, nothing so big. Sorry, winners. We have limited budget. Yeah.
Alex, sorry, important information. They tell me that in the other room the screen is not being shared, so you could maybe make sure. There's a technical problem in the other room. Sorry.
There is a problem in another room.
Oh. They are not sharing. The presenter is not sharing the screen, and
okay.
Sorry, guys, but that's the only way to reach immediately and fix this technical thing.
But second room should be empty now.
No, it started. Payal Kumari started already.
Okay.
Now about Tombstones.
Okay, so. Say hello to everyone, and I will check what's going on in the second room. And congratulations to the winners. We have a pause for a few more minutes, okay?
Sorry, Alex. Sorry, guys. That was a bit of a technical urgency. Okay. So we are about to have a break in this room until 16:15 IST. So 35 minutes break. And if you go to the other room, if you don't want to take a break, you can go to the other room and there is an interesting talk about Tombstones. So yeah, thank you, Cedric, because there was a question I was about to answer. Yes, maybe this is of interest to somebody else. So Tarum Sharma writes that I'm preparing for DataStax certification and I am using Astra for practicing. Can I SSH into the system where Astra DB is running? No, you cannot SSH into Astra because this is exposed as a service. You do not have access to the Cassandra software itself. So for most of what is about the certification, you probably do not need to access this layer of the system, except, and that's important, for the administrator part, because obviously if you want to prepare for the administrator certification, it will be important to operate at the level of the system, set up the cluster, configure, restart, do these things, and this you can't do with Astra. But don't worry, because there are other options. For example, well, you might want to install a single node Cassandra in your computer, because that's absolutely feasible. You can do that with Docker. You can do that in many ways, or you can use our hands-on scenarios. There are also scenarios where you can. There are interactive scenarios where you can access the layer of the Cassandra system and restart it and stop it and do your operation things. So this is unfortunately not what Astra offers, because Astra is a service that offers you the ready-made database. You will never have to take care about what's behind, what's below. Okay, that's okay. Anyone has some resource for using Docker for single node to try things? Yes, we have documentation on Docker. Let me fetch it, because if you are familiar with Docker, it's a matter of a single line, basically. But there are specific. I have to find them here. Okay. Yeah. So. Let me drop you a link to the Docker hub of DataStax, where you find, if I'm not mistaken, here you find not only, so you find also, maybe this is DataStax only. Yeah, you should also be, okay, this was for DataStax, so it's that flavor of a, it's that flavor of Cassandra that is packaged as DataStax, but you can also go and look, let me find it. You can go and look for the Cassandra, Apache Cassandra Docker Hub here. So if you're familiar with Docker, I think that's very simple. That's a good starting point. You can download your, you can grab your Docker images and start running Cassandra. Single node is very simple. It's a one-line Docker command. If you want to set up a multi-node Docker, maybe all in your machine, if you have enough power and RAM, you can also do that with Docker Compose. And I will retrieve a very nice resource to do that. You have to give me a second. There is, let me find it here. No, I can't find it now, sorry. We use, okay, I'll write it later if I find a bookmark in my bookmarks. But okay, there is documentation and there are interactive scenarios to play with Docker within. Maybe it's here within here. I think that's it. Yes, exactly. So this is what I was looking for. So give me time. Yes, this is a very simple. This is a very simple exercise that will give you some, okay. It's a hands-on Docker exercise that you can run in your browser thanks to this Catacode environment, and you can simply do the exercise within the Catacode scenario online in your browser. You will learn to use Docker to set up a single machine, a single node cluster within Docker, within the scenario, and then you can also reproduce it on your machine once you are comfortable with that. Okay, so that's... Okay, so there is a question, how to submit the homework? Well, the homework is... Hi, Alex. Welcome back. Did you solve the issue?
There is an issue on the speaker side, and
okay, I see.
I cannot solve it. We just starting from a second laptop, second speaker.
I
laptop.
See. Okay.
So you're answering questions, I see.
Well, there were a few questions on how to start Cassandra from Docker.
Oh, so, okay.
So we drop a few links. Also, the very nice scenario by David Chung, which is a good way to flex your muscles in Docker with Cassandra. And yeah, that's more or less it. Then there were how to submit the homework. Alex, did you do the the interactive scenario about CRUD during the
only a little demo because we were out of time.
So that is the homework.
Yeah, that is the homework. Your homework is to go to this link we sent in slide a few times already. I will do it again. GitHub.com. DataStax Devs Workshop Intro to Cassandra, and it's all explained there. So I'm sending it to chat. Let me see. 1, 2, 3. And besides that, I believe we are having a pause right now.
Yeah. Well, 15 minutes more or less.
Yep. First room goes to a little vacation, let's say, for 15 minutes or about that. And second room will start with a little delay because of this speakers issue on the second room. We are working to recover, and we will proceed with some little bit shift for now Tombstones, simply explain it, and performance tuning on Cassandra later, and Grafana dashboard for Apache Cassandra. In the first room, we meet again at 4 p.m. 15 minutes Indian Standard Time for data modeling workshop with Stefano, and I hope I will be able to join you and maybe add some comments if you don't mind.
Yeah, that would be very welcome.
Great. So we go to the pause. I'm switching for that. Have fun.
I do the...
Okay, ladies and gentlemen. So, ready or not, we are coming.
Here we are.
Yes, we are here and we are ready. That's Stefano Latini, DataStax developer advocate. His job is make you better developers, and he's your best friend. Remember his name. And well, me as well, but maybe we are friends already. I hope so. That's going to be data modeling for Apache Cassandra, building efficient applications. And Stefano, now it's you by microphone, so please start.
Okay, thank you, Alex. Hi, everybody. Welcome back. Yes, so we have had fun with the quiz. Now it's time to get serious, and we will speak about data modeling. Data modeling, as a subtitle, building efficient applications. Actually, another subtitle is how not to shoot yourself in the foot with Apache Cassandra. So how to start in the right way when it's time to build an application and design the database around it with Cassandra. So let me quickly tell you a few practical things. Many of you ask for this. So this content is recorded and it will remain available on YouTube. Then it's good to repeat. If you have questions, you can write them in the chat, because we have a look at the chat, Alex and I. There are other people from DataStax who monitor the chat and help you with the questions. But most important, keep the questions for this DTSX.io CD India -questions address, because there we collect the most relevant, the nicest, the best, the most voted questions, and some of them will win prizes. And we will discuss them at length. So please, if you ask questions there, add your name if you want a chance to win some prizes. Or you can join us in our Discord channel, where we can go on with the discussion even after the stream ends. So please remember those ways. Let's keep in contact. Okay, so this workshop will last slightly lesser than 2 hours, and it will cover the very important topic of data modeling. You see here some other links. So we have a forum, academy. We have spoken a bit about them already, so I will go further. Okay, so for this workshop, we assume you know something of the fundamentals of Cassandra. At least you should know what a database is. And well, if you know what a relational database is, then good, but also careful, because part of this workshop is teaching you how to unlearn something of relational databases. So when we say Cassandra here, we mean any Cassandra, which might be Apache Cassandra itself, or the DataStax Enterprise packaging of Cassandra, enriched packaging of Cassandra, or we can also mean the Astra DB, which is Cassandra as a service offered by DataStax. Anyway, the logic is the same, the architecture is the same, so everything applies to all Cassandras. So who am I? I am Stefano. I'm a developer advocate at DataStax, and yeah, here are my contacts. So feel free to contact me, and that would be appreciated. Okay, so let me start. What are we seeing today? What we will speak about? There will be some introduction to Cassandra, just to level things up. Then we will touch the important topic of denormalization, which is one of the most important concepts that makes Cassandra stand apart from relational databases. We will then see how, through the usage of keys and partitions, how the data is stored and grouped and arranged in Cassandra, which will be the basis for examining what kind of queries one can do on the database. Then finally, armed with all of this knowledge, we will have a look at the data modeling process in itself. After that, we will briefly touch on a few other topics that are important, and they are part of the data modeling process, but they are not the basic parts. Okay, so we have a nice number of attendees. We can start, I think, Alex.
Yes, definitely. Let's go.
Okay, so let's go. Introduction. So what is data modeling? Well, when you are creating an application backed by a database, at some point you have to create your database. So you start with a general idea of what your application should do, and you end up with the database created, designed in all its details. This process is the data modeling. And when you do data modeling with Cassandra, there's a particular way to work. And this is what I will illustrate. So what is Cassandra? Well, you have probably seen and heard Alex speak at length about Cassandra. Let me just summarize it in basically one slide. It's a NoSQL database, very high performant in terms of size and speed, both. And it's a database that can give you so much, but it has its particular features, so you have to learn how to use it. So when I say size, we mean the so-called web scale, so something like hundreds of petabytes of database. When we mean speed, in particular, Cassandra is optimized to be very, very fast in writing, but also reads are fast because of the way data is stored. And when you mean, sorry. Cassandra is able to support tens of thousands of operations per second per node in, for example, writes. What do I mean by per node? Well, Cassandra is made to be distributed. It's made to be, a database in Cassandra is made to be spread over many, many different nodes, whereby nodes, I mean single servers, machines, virtual or physical, no matter. And in Cassandra, a database is distributed not only meaning over various nodes, but also it might be geographically spread, for example, all over the world. No problem. Cassandra can deal with that. That Cassandra is NoSQL. It means not only SQL. That's the meaning of the NoSQL tag. It is a very general label given to many different databases, but in particular, Cassandra is a database that is non-relational and it's not transactional. So there are no joins, there are no foreign keys, there are no transactions when you do writes in the data. Well, that's basically because a join would not scale very well if you have hundreds of thousands of nodes. So there is no hope to coordinate on such a scale. So they have to invent a very different paradigm. And well, this is one of the reasons why you will need a very different way of thinking about how you model your data. Okay, so what do I mean by learn how to use it? Well, again, it's easy to get your data model wrong. And especially for those of you who come from a relational background. In a sense, most of the data modeling consists of learning to think in a non-relational way all the way from the start. Especially if you get the data model wrong, then your database will behave in a suboptimal way. So the performance will be bad, or maybe it will it will not even work. So that means that you will need to know something about how Cassandra works internally. Okay, so another important observation about Cassandra is that Cassandra sits in a very precise place in the axis that you see here in this slide, the OLTP, OLAP axis. What do I mean by that? OLTP, that is online transaction processing, is the kind of workload you do with a database when you need very fast operations that are very simple, let me say. Fast and simple on single pieces of data. So you need to update a single row very fast. You need that it is absolutely real time or almost real time. And the queries usually are always the same. Think of a warehouse management system, for example. On the other hand, on the other end of the spectrum, you have OLAP workload. That means online analytical processing. And that is a kind of usage of a database that is very different. It involves very complicated analysis that can run for hours, or anyway, they do not need to be real time. They can take their time in a sense, and they involve very complicated juggling with the data. The queries are complex and the queries are maybe experimental because every night the big analytics have to run in a slightly different way and so on. And that is a very different thing. So the point is that a relational database, with all its limitations, for example, scale limitations, somehow sits in the middle and is able to more or less handle all kinds of workloads. Cassandra takes a very precise stand in that. And it is designed to optimize scale and speed. And it is made to work best in the OLTP side of things. So Cassandra sits on one particular side. That is not equivalent to say that Cassandra, you will never be able to do all up with Cassandra, because you can plug additional solutions on top of Cassandra using that as a storage engine. You probably know Spark, for example, or Hadoop, maybe still relevant, who knows. You can use such and other tools on top of Cassandra using that as a storage. But Cassandra in itself is made for very fast, very simple in a sense. It's more fast than smart, let's say, in this sense.
Yep.
Okay,
I want to say a word
please.
about that. A lot of people misunderstood or underestimate this shift, and they try to, first of all, Syed Babar says almost every OLTP system is normalized. No, not almost every OLTP system is normalized. If OLTP system wants to be quick, it has to denormalize. Sorry.
We will come to that.
Yeah, we will come to that. And second point, what I wanted to say on small to medium projects, we use it to have single database. Can you please switch to a previous slide?
Sure.
Yep. So with traditional relational databases, they are a little bit of everything, and we use it to have single database for all the purposes, a bit of OLTP or a little bit of OLAP. But then working on the big workloads, working with Netflix scale, now working with Facebook scale, and so on, that doesn't work well because you need to have more of that. And you use it to use multi-purpose or general purpose databases like PostgreSQL, for example. For the big project, simple, a single database is just not enough. That's why most of the big projects using multiple databases at once. Thank you, Stefano. Your turn.
Okay. Yeah, thank you for the remarks. Okay, so let's summarize very quickly a few features of Cassandra. So Cassandra is big data ready. It is able to deal with very huge amounts of data. It is very highly available. It has no master node. It has no. It is a democratic architecture. So it has no single point of failure. It is able to offer no downtime, basically zero downtime. It can be geographically distributed. Anyway, it is distributed, and that involves the CAP theorem you might have seen with Alex earlier. It is optimized for a very fast performance in reading and in particular in writing, which is usually the bottleneck for many databases. And it is open source. It is vendor independent. There will never be lock-in if you use Cassandra, which is a point that is very much important. There are also some other observations, some other maybe cons one can spot looking at Cassandra. In particular, it requires qualified engineers. You learn to use Cassandra after doing it for some time, after studying it, after learning it. But that's actually a good point, because you might become the next person to get a very well-paid job because you know Cassandra, which is in high demand. Cassandra might be a bit complicated to manage in some cases. So doing operations and setting up configuring might be not so easy. That might be true. But there are managed solutions that abstract from you all of these needs, and you just have a database that you can use in the cloud. Another point is that Cassandra, as we said, is focused on OLTP workloads. But as I said already, you can plug Spark, Hadoop, other OLAP solutions on top of it, no problem. And then it is not extremely elastic in terms of search capabilities. But then again, you can plug Lucene-based solutions on top of Cassandra again. So Solar or Elasticsearch, they can work on top of Cassandra, no problem. So yeah. So let me just give you a glance on what we are going to see next. When you do data modeling, there are two completely different ways to approach it, and that is relational databases versus Cassandra. And this one table tries to summarize it all. So what in relational databases is accomplished by making heavy use of joins and building indexes, in Cassandra is done in a completely opposite way by using a lot the concept of denormalization, which I will touch in detail in a second. A traditional relational database is based on the idea of referential integrity that is built in the database. Cassandra cannot afford that because that would not scale at the size Cassandra is able to reach. In a relational database, the role of the primary key of a table is that to guarantee uniqueness, and that's it. In Cassandra, the primary key defines uniqueness, but also gives the table instructions on how to partition data and how to group data and store it, and also has consequences in how fast you can access those data. Data modeling in a relational database starts with the data. Usually you describe the data, then you make them into a model, and then you think of your application. So it's driven by the entities that are part of the application, that are part of the flow. In Cassandra, we take a completely upside down approach, and we start with the application. We start examining how the application works, and then we model, and then we write the tables. So it's based on the flow of the application, which is the same as saying it is driven by which queries will be part of your application. You will see more on all these points shortly. Okay, so this is the introduction, and we start going into much more in detail. So let's speak about denormalization. What is it? Well, I will start with normalization. So normalization is a concept that was invented more than 50 years ago, and that it was a pillar on which relational databases were invented. The idea is to embed data integrity in the database by imposing constraints and relations between tables. In particular, the point is you will never want to duplicate information in many places of your database so that you will never have mismatches. So you don't duplicate information, and whatever is the query you want to do on the database, whatever is the information you want to do on the database, there is always a single source of truth for every single individual piece of information. So look at this example. We have recipes like cake or pizza, and we have ingredients like mozzarella or champignons. In the real world, every recipe contains many ingredients. And this relation is realized by, so the word pizza appears only once, and the word champignons appears only once. The fact that pizza contains champignons is in a third table that only contains the code, the ID of pizza and the ID of champignons. It is not like I repeat pizza in many places because there are many ingredients. That's the main point of the normalization, of normalization. Sorry, let's make myself clear. This is very nice in theory and very good, and it works nice. It might have a cost. The cost is that sometimes to retrieve the information you need, you have to make a round through various tables, and you have to mix and re-edit the information that as you retrieve it from the database, which is called basically a join. So let me make this example a bit more SQL. So the same relation between recipes and ingredients is now made into tables as you would write them in SQL. So we create a table recipes, we create a table ingredients. You see recipes have an ID, ingredients have an ID, all nice and perfect. And then we need a third table that just describes every relation between a single recipe and a single ingredient. So we have 3 tables, and every time we want to know something about pizza, we need to look at all 3 tables. So the point is that we have designed the tables in a way that they describe the word. There are ingredients on one side and recipes on the other side. But then, when it's time to know what are the ingredients I need for a pizza, I have to look at all three tables. And I have to do what the joins. So I have to start matching IDs and coming up with the final answer you see here. Pizza mozzarella, pizza champignon, perfect. That is what I need. I just want to know what is to be put in my pizza. But that needs looking up several tables. And if you think of that on a scale of many, many, many rows, that starts to be unbearable in terms of performance. A good thing of the relational model is that usually once you have your tables done, you can ask various things. You can have various kind of information from the same table. So I want to know the idea of cake. I use the same table and I do just a different query. That's super nice. But usually you are more concerned about performance in these cases, which leads me to this slide. Denormalization. What does it mean? It means we might want to sacrifice this very nice and elegant and formally, mathematically beautiful idea of normalization, and we sacrifice it for performance. Because you see, even with relational databases, the typical story many of you probably have lived is that, yes, normalization is nice, but my queries start to be very slow. I can optimize them all I want, but at some point they will just be slow because they are too complex. So even in our relational databases, from time to time, people start thinking, okay, I can do this small duplication of data just a bit to make my query go faster. I duplicate the name pizza in many rows so that I have a simple query and my query goes faster. My application is well performant and my customer do not turn to the competitors because my site works fast, which is the point after all. So this was already there in relational databases, but there was a bit of a clandestine solution. What Cassandra does is say, okay, let's embrace this approach from the start as a first-class citizen in our database. Let's forget about normal forms and let's just apply the normalization completely. So my queries will be fast. That's more or less the point of the normalization. So that in this case, if I want to know the ingredients for a pizza, I just look at a single table. You see, there are many rows with pizza and many rows with cake. So what? It is fast. I can do my query. That's the big point. So the denormalization is based on this idea. Let's make the data redundant. No problem. That's okay. As long as every query needs to look at a single table, that's super nice because it is fast. It is fast not only because there are no joins, but also because, so it is fast for two reasons in a sense. One is that I don't need to do joins. I just browse a table and that's my answer. Not only that, but also you basically are moving the burden of making the join to write time instead of read time. And the write, which is ultimately responsibility of your application that writes the data. So it's not anymore in the database, the join. It's in the logic of your application, but the writes can go in parallel while a join can't. So even not only you move the problem to write time, where you probably can afford it a bit more latency in most cases, but you also make it faster because the writes can work in parallel, because every table never speaks to another table in a sense in such a database, because there are no joins, there are no foreign keys, there are nothing. That's, by the way, the only solution that is able to scale to very big distributed systems. So you see this small sketch on the left is a relational database. Every query can have a look at many tables and has to do their thing, and then combines data, and then you get your solution, your answer. In Cassandra, you design tables so that every query just straight goes to a single table, reads the data, and there you are. Okay, so the point is exactly that. You combine all columns that you need for your query in a single table. You do not do joins, and the queries are very simple because the queries always go to that table, retrieve the data, and browse it. That's it. So one table per query, no more than one table. But that means one thing. In your design of the database, you start with the queries and then create the tables, which is a point that we will develop much more later. Another point, which might be hard in some cases for relational people, is that there's no problem in duplicating data as long as you know what you do. So redundancy is your friend. So that does not only mean that I might have many rows with pizza, but it might also mean that I can have two separate tables with more or less the same information arranged in a different way because they have to support different queries. Again, yeah, it's strange sometimes to think, okay, I want to duplicate my data. But think of performance. What costs more? Having more storage or having more milliseconds in your queries and your customers switching to competitors? That's a big, I mean, that's at the end, that's the practical consideration, right? Okay, so this is how it generally works with the denormalization. With that in mind, let's have a closer look at what happens when Cassandra stores data in its tables. Okay, so we are about to go to a section that is a bit more concerned about how is data stored in Cassandra, which is, in a sense, architectural detail, if you want, but it is far from that. It is very important to have a clear idea on how the data is stored in Cassandra and how it is distributed between nodes, because that is the secret for a successful data model. Am I right, Alex?
Yes, definitely.
Okay. So have you seen some interesting questions or something, or can we proceed?
Actually, I was out helping with the second room.
Okay.
So I was not here for the last few minutes. Sorry. I see what Jeremy
No problem.
is answering questions.
Ah, okay. Yes, I see.
Yeah.
Thank you, Jeremy. Okay. So let's proceed in this case. Anyway, feel free to put the questions in the address that you have been given. Maybe Alex, you can paste it again, so we might collect the best questions for the Q&A session later.
Yeah, and by the way, yeah, there are some good questions. Don't forget them. Don't forget to put them in the Q&A part. I will paste the link again soon. I wanted to add, I wanted to say a word exactly when I had to go about joins, about this competition normalization to denormalization. There are two things I want to say. Can you please switch a couple of slides back to the normalization?
Yeah.
Denormalization
one,
story. Yeah, maybe
I think
this
it was
one.
this one.
Yeah. But that doesn't matter. So take a look. First of all, we use it to be, we were taught in the universities, at the database courses, and so on and so forth, what normalization is great and denormalization is bad. How to say it in English? Only Sid put everything in the absolute. I'm trying to quote Star Wars. It's not like that in real life.
It's all relative.
Yeah, it's all relative, and we use it to think what the normalization is good, the normalization is bad. No, it was a lie. People lied to you all your life. Since your very first day, they told you what normalization is good, denormalization is bad. It's false, it's wrong, it's not like that. Denormalization is great, then you keep it under control. Then you understand what you are doing, then you know how to normalize, when you know how to denormalize, when you are in control of normalization versus denormalization, then you can use both. It's not a Star Wars realm, then you can have like the dark side of a force, good side of a force, and you can have only one of them, let's say. That's in real life, you can have all of them and be pretty successful with that using when normalization when you need it, denormalization when you need it, thinking about that and keeping it under control. When denormalization is bad, denormalization is bad, then you do it because you don't know normalization or denormalization. Then it's bad. Then not you control denormalization, but denormalization controls you. Then, of course, it's very bad.
Yeah,
sure.
But that's true also for relational databases, because you might end up slave to the relational logic and you might have queries that are too complicated to even understand. So that's really, any complex tools might end up owning you. That's a general lesson, I would say.
And second, sorry, where is the second point?
Sorry.
Where is the second point? Again, people often don't understand the huge difference between this normalization to denormalization competition. If you go to normalization, you don't duplicate your data, but you pay with joins. And joins, ladies and gentlemen, are way much worse when you can think of them. And then you go with denormalization, you pay for it for a higher amount of writes because you have to change data into multiple tables. But now think about the trick. Multiple writes. First, Cassandra's writes are very fast. Second, Cassandra writes are executed in parallel. And third, you can execute multiple writes at once in a single asynchronous way. If you are going to update 3 different tables, you run those update statements in parallel and you are good. You can parallelize them. As a result, you will have not 3 updates executed one by one. So it will be a duration of time of 3 queries, but it will be duration of 1 query because you executed those 3 updates simultaneously, right? So by the time consumption, it's more or less the same. But let's take a look at the joins. When you see a long select statement, for example, with join and join and join and join and join, one time in my life I've seen a select statement with 61 join in it. 61 join in single select statement.
It was good luck maintaining that.
Yeah, good luck maintaining that. But that's not the worst problem. Worst problem is joins can be executed only synchronously, one by one by one by one. You cannot execute joins in parallel. They're always being executed next to next to next to next to next. And by itself, joins looks like a simple operation. But first of all, you are going to have chains of joins. And second, you are going to have your data growing and growing and growing and growing. Now, every company is a data company. That's 21st century. Welcome, ladies and gentlemen. As a result, considering those 2 facts, denormalization is not bad as long as you control it, not it controls you. And we can parallelize writes, but we cannot parallelize joins. Situation looks a little bit different. Thank you, Stefan. I'm done.
Yeah, I see people in the chat who are sympathetic with your situation. So very complex join that will explode in your face. Okay. Yeah, so Tarun Sharma asks a question that about how data moves when you add or delete nodes. I have to skip that because that is a bit off topic. We might come back to that, and make sure to write that in the Q&A if you didn't already. Now let's go on with the data model, or more specifically, let's see how is data stored in Cassandra. So as I said, you have to know how your table is designed, because that defines not only uniqueness of your rows, but also defines how are the rows distributed and grouped, and which implies what kind of queries can you do and you can't when you read data. Or when I say can't, I usually say they are unbearably slow in production, but it's the same as saying they just can't be run, right? We want our customers to be happy to use our application and whatnot. Okay, so this is not a technical concept. This is important to know how to model your data and make your application successful. So let's go in detail. Okay, first point, which is very much similar to relational databases. A table in Cassandra is rows by columns. Nice. So far, so good. And much like in a relational database, a table in Cassandra has a primary key, which is a selection of columns that defines uniqueness. So you cannot have 2 rows with the same values in the primary key, because that is a single row by definition. So let's look at this table. We are now using an example in which there are recipes like pizza or cake. And these recipes are rated by reviewers. So Anita gives an 8 to the pizza, Carl gives a 9 to the pizza, Zoe gives a 2 to the pizza, and Poldo gives a 3 to the cake. So this is a site that collects this kind of information. And we have such a table. By the way, pizza, pizza, pizza. This table is absolutely denormalized because we are in Cassandra and we want our query to just read from this table. Okay, so what is a good choice of the primary key for this table? Obviously, different rows might refer to pizza because it's different reviews. Different persons. So we sure have to include in the primary key at least recipe name and reviewer, because otherwise, if we just have reviewer, the poor Anita will not be able to review two different things. And if we just have pizza, no two person will be able to review pizza. So absolutely, those two columns have to be part of the definition of uniqueness of rows, so the primary key. Now the question is, shall I add or not date? Well, yes or no, depends on your model. What are you trying to do with this table? Do we want an application where every reviewer is allowed to just give a single rating to a particular recipe? Okay, if so, then uniqueness will be defined by recipe and reviewer, and date will be just a data column. But if our application wants to allow reviewers to give a history of reviews, today, yesterday, and the day before that, I give different values to pizza, then I have to include date in the primary key. So you see, the primary key is partially depends on, or mostly depends on what is the particular real world situation that I want to describe in my table. Okay. One thing that probably does not make sense is to include another column such as rating. If I include rating in the primary key, then I might end up with different columns that differ only by rating. And what is that? A quantum vote? So that doesn't really make sense, right? So let's assume we want an application where Anita can vote for pizza now and also next week. So we choose that the primary key, so the set of columns defining uniqueness, is recipe name, date, and reviewer. Okay, so now you see I made them blue. So there will never be more than one row with the same three values. That's the point of uniqueness. Okay, so this is so far something that relational database people will find very familiar. Now let's move to unknown territory. Oh no, okay, that's a consequence of what we said so far. When you do an insert, when you insert data, at least you have to provide the values for the primary key. Otherwise, you are not even specifying a row to change or to create. So in the same sense, you cannot just edit or update the value of a field in the primary key, because that would mean you are creating or changing on a new row. So the other column can be changed, edited in place if you want, conceptually at least. But those are defining what is the row. So the blue ones are defining what is the row, so they cannot be edited in that sense. Okay, just a small remark. Why don't we introduce a column called recipe ID created on the fly and use that somewhere in our application? Well, indeed, we could. The choice between using surrogate keys or organic keys is, well, nuanced, I would say, and depends basically on the flow of your application. And that's also the case in a Cassandra database. So it depends on your use case. You might find the application that is, you might find cases where the application works better choosing to invent keys to guarantee uniqueness, and other cases where this does not pay off. I will not do that today, but it's absolutely a perfectly fine choice in some cases.
There is a question from Nitya Lakshmi asks, in this case, Anita can give review only once in a day, right?
Yes, because, okay, yes, I didn't, okay, that's very specific.
Good question, by the way.
Good question, because in this example, to make everything short and understandable, the column date is just a day, does not contain hour or minutes or seconds. if it were a timestamp, then there could be a review per each individual milliseconds or whatever, which would maybe hardly make sense. But anyway, yeah, good point. So I wanted to take everything very simple on screen. So yes, one day. So the resolution of the column is day. Thank you. Yes.
And there are two possible consequences. If we allow multiple writes per day, then yes, every new review from the same reviewer will overwrite the previous one for the same day, for the same recipe. Or we can use lightweight transactions and prevent multiple reviews from the same reviewer for the same recipe. That's for the use case. And indeed, I believe we can use datetime in this case, like Jocelyn suggested. If we use datetime, then we can have multiple reviews per recipe per reviewer. Right.
Yes. Yeah, good points. And both of them will be touched later in the slides. So stay tuned for more on lightweight transactions if we make it, but I think so. Okay. Okay, so let's move on. Partitioning. So you have seen what the primary key is. At the primary key has a logical role in your table, in a sense. Now, partition key. This has been touched by Alex already in the fundamentals lesson. The partition key is a subset of the fields of the primary key, and at least one column has to be there, and that defines which rows are grouped together in partitions, and also defines how are those rows, those partitions, distributed across the cluster nodes. So again, as I said, this might seem a simple technical implementation architectural detail, but it is crucial to know that to design your data model properly. So let's go to an example. Let's keep this table, recipe name, date, reviewer. I decide that the partition key is just recipe name. So what does it mean? Well, you see on a slide, you're seeing a slide that is very, very chaotic. That's for a reason, because I have a replication factor of 3. So you see this partition pizza. It is repeated in gray also in this node on the left, on the right, and also in this node below it. So let me tune replication factor magically to 1, which makes everything easier to understand. Don't do that in production, because that is a bit of a fragile architecture. But now in these slides, we can. So what is partitioning? You see, I have rows. These orange blobs are the nodes of my cluster. And I have rows stored in this table. This table is distributed across the nodes. But you see, all rows with recipe name pizza are close to each other. They live together on this node. All rows with the pasta live together on the nodes to the right, and so on. So what does it mean? Once you define the partition key columns, you are defining how are the rows kept together in partitions. And that is very important. You see, there are no rows with the same recipe on different nodes. If I want pizza, if I want everything about pizza, I can go to a single node, and I'm sure I will have everything. The opposite is not necessarily true. I might have, as is the case here for cake and rice, I might have several partitions stored on a single node, but that's not a problem, obviously. The important point is that I will not have pizza scattered through the cluster. So each row belongs to a partition, and the partitions are defined by the choice of partition key. There is an hashing algorithm. Alex mentioned the Murmur3 partitioner, which makes the partition into the values in the partition key into a big number. This number is used to decide what is the node hosting the data. My point is, if you are able to make sure that everything about pizza is on a single node, then you're golden, because you are sure that every query that needs just stuff about pizza will be fast, because it will go to a single node. It will never have to look around several nodes. So it's your responsibility to figure out what are the needs of your queries. So what are the needs of your application? What will be the queries that you will use in your application? And you will design the partition key accordingly. So I know that I want to get stuff from this table only for a given recipe, and I can decide the partitioning is like that. Alex, you want to say something?
There are multiple people asked the same question. That means what is important.
Yeah.
But we can discuss it 1 minute later. I'm not sure if I interrupted you.
Well, I don't know. Maybe a next slide will speak about that. But please.
As far as I remember, you won't. The question was same question, multiple authors. What if I have pizza node growing and reach storage size, or what if pizza data size is more than a node can hold? So what if data is grows? Take a look. There are two situations. Then data on the server grows, and then partition grows. When data on the server grows, don't forget what server holds multiple partitions. You add more servers to the cluster. Cluster recalculates token ranges. Partitions moving to the new empty server. Old servers are unloaded. And therefore, you don't have your server overloaded as a result. If your data model is good, then all good. You add more servers, you get more space. So there is no problems if the server is overloaded. Just add more servers. But there is a second scenario when not a second per se is overloaded, but partition is too big, as we discussed it on the previous session. Then it's a very different story. Adding of new servers won't help if you have one single huge partition. So basically, that leads to a very different problem. It means what your data model was wrong from the very beginning, or not perfect anymore because of the business requirements changing. Then you have to, so you cannot change partition key. It's not possible. So the only thing you can do is then in this case create a new table and migrate data to a new table. And I hope I've answered it. And there is question, can you alter the partition key of a table after it's created? No, you can't.
No, you can't.
And question, why is pie and fish in the same partition?
Yeah, these I answered in the chat, but that's the point.
They are in the different partition.
Usually you have, I don't know, millions of partitions, for example, because there might be a lot of recipes, but you have a cluster with 5 nodes. So what do? You will sure have many partitions sitting on the same node. But that's not a problem. That's something that happens, and it's okay. And as Alex said, if this is somehow a storage issue, you can add nodes and the partition will be redistributed. What is important is that a partition will never be cut in half and kept a bit here and a bit on the other node. That's the important thing. The opposite is not a problem. Okay, so the point is that when you do your query, if you want your query to be fast, you want it to be able to access a single partition, which implies to access a single node, to speak directly to a node. That's the big takeaway. Now, let me just show you what happens if I have the same table, the same primary key, but I decide that the partition key is different. So you see, instead of recipe name, now my partition key is recipe name reviewer. Now, it is the same data, the same rows, but they are grouped in a totally different way. You see, I have fish and salad here on the top. I have cake on the left. I have pasta, I should say better. I have fish Carl in a partition, salad Nina in another partition, cake Poldo in another partition. And it is important to note, where is pizza? Well, pizza is a bit here, pizza Zoe on the right, and a bit in the bottom left, Pizza Anita and Pizza Carl. But those are now different partitions, because what defines a partitions now is the combination of recipe name and reviewer. That's because I designed the table like that for my reasons. So what is important now is that, yes, I have partitions. And as you see here on the right, Salad Aldo is 2 rows. And they are together because it's a partition, the partition defined by a particular recipe name and a particular reviewer. So my point is that if you change the partitioning, which you can't do once the table is there. So if you design a table with a different partitioning, the same data will be grouped in a different way and spread on the cluster in a different way. Then what is the right choice between those two examples? Well, there is no right choice. It depends on the query you want to run. So the first case, where recipe name is the only partition key, is a way of arranging the data good to answer a question such as, tell me all reviews of pizza, because that hits a single partition, which means a single node. The table on the right is not able to answer my question, tell me all reviews for a pizza, but is able to answer a question such as, tell me all reviews of the pizza by Zui. Because that now is a partition. It's a smaller partition if you want. So there is a really tight relationship between the table shape and the queries I want to run on them. Okay, this is a very important point. One might be tempted to say, okay, let's make a super giant big partition so I can do all queries I want, but then I will have two big partitions and we would have problems of other kinds. So the problems that Alex mentioned. So too big partition is also a problem for various reasons. One is that I will have all data on a node and the other nodes sitting there idle, and I'm wasting my resources if the database is able to be up like that. Maybe that one partition is too big, and then I got partitioning very wrong. Okay, so you might start thinking, oh, damn, but I might have to support different queries. So my application will be able to give me all pizza reviews, but also all reviews by Anita, which are two different queries, two different ways of looking at the same data. So how do I do? Well, the answer is create two tables, which is nice. Two tables, each one built exactly to answer a single query. So each one will have the same rows, the same primary key, by the way, but the partitioning will be chosen differently, and each one of those two tables will be able to answer fast that one of the two queries. And this is full power of the normalization. Now, you create two tables, no problem, you use more disk. Probably it's not a problem as long as my application is fast. Now, it is up to my application to do double insertions. We already mentioned this point, but that's no problem. If I write my application in the right way, that is absolutely doable, and it's not even a performance penalty. On the contrary, it is the only way to make my application fly on very high volumes of data and traffic, write and read traffic. So you see, so far we have said that in Cassandra you need a single table for a query, but in most cases you need a single query per table. So these are two queries on the same data, and they end up requiring two different tables. But again, that's okay. You can do it. You don't have joins. Come on. Okay, let me touch on two typical problems you might encounter when designing partitions. Let's stay on my example of recipes. We have a partition key that is recipe name. So we have a partition for pizza and a partition for soup. Now, everybody knows that pizza is very good, delicious, and soup, maybe nobody likes soup, so let's say. So there is a lot of reviews coming in for pizza all the time, and nobody thinks of soup. Well, that's an imbalance because we will have a partition that is very thin and one that is super big. Not only that, but one of the two will constantly receive writes, and we have to work a lot, and the node hosting that partition will be very busy. And this is what is called a hot partition, which might call it hot pizza also in this case. Usually, if you identified such a problem, you solve it by rethinking your partitioning. So for example, in this case, we add a date in the partition key. We make the partition smaller, more evenly distributed between nodes, and also the write load is less a hotspot on a point. Again, to do that, you have to examine your application and make choices that are compatible with how your application intends to work. There is another problem that might arise after some time of your data model working. You might have a model that works. For example, look at the example below. You have recipe name and reviewer. So there are relatively small partitions because we added reviewer, everything works for some time. But then what happens? Time goes by, month after year, and the partitions will grow unlimited. So at some point, they will be too big. Okay, maybe that's probably not happening for when it's chefs reviewing recipes. But think of an Internet of Things sensor network that collects sensor every second and stores them in partitions. At some point, maybe in a few months, your partitions will be too big. They will have billions of data. Now, what is the solution in that case? The solution is the so-called bucketing. So you see what I do here on the right. I invent a new column that does not contain any new information. It is just a column that I calculate on the date. It is a string, say year underscore month, whatever. And when I insert data, I add this column. I add the value for this column. And I make this column part of the partition key. So what does it mean? That every month, my partition is, in a sense, locked, finished. It will not receive writes anymore, and I start with a fresh partition. So I keep the same amount of data, but in a more manageable way. And if you think of a recipe application or also an IoT sensor network, probably the data of 2 months ago, I can keep them, but I will maybe not even need them. Or if I need them, I can query them month by month or something. So my application might be, usually is able to cope with such a choice. Okay, so let me go forward. So much for partitioning. The important message is you have to know how your table is partitioned because your data model depends on it. Ideally, you will never have queries that look at more than one partition, which means that you have to store together what you will retrieve together. Now, a remark. You will never want to query data from different partitions, but the opposite is absolutely okay. So let's say you have a partition with all pizza recipes. It's not necessary to retrieve all the partition at once. You might want part of the data there, and that's fine with some constraints that we are about to see. But that's fine itself. So there's no need to have queries that get all data from your partition. So what we also touched is that you should not design partitions that are too big or that will become too big. And here you see the numbers. The numbers are very generous. So hundreds of thousands of rows, 100 megabytes. If you stay a bit below, it's even safer. But you can have up to 2 billion cells in a partition. So the numbers are generous, but they have to be kept into account when designing the partition and the table and its partitioning.
Yeah. As one of our architects say, we have seen partitions up to 1 terabyte. We even seen latest top score was 1.2 terabytes for a partition.
Wow.
It's a damn disaster. Don't do it. It's a very, 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 very bad idea.
Yeah, then you think, for some time it worked. Now we start having bad performance. Yeah. Or we have nodes going down and whatever. So this is not to be underestimated at this point.
By the way, a life hack: if anyone tells you Cassandra is slow, tell him what he has bad data model. 100% guarantee.
Yeah, absolutely. Yeah. So closing with this slide, be sure you are also thinking of how the load is distributed across partitions. So you try to avoid the hot pizza problem, because that would be, at least it would be a waste of your hardware resources, if not worse. Okay, so let's touch on the third part of this section, clustering. Because you see, so far we have been looking at how are data grouped and how are those grouped partitions kept, each one maybe on a different node. But how are rows arranged within your partition? We might have several pizza reviews all together. How? Well, this is a nice thing of Cassandra. Within the partition, rows are kept always sorted. Sorted by what? By the rest of the primary key. So you have a primary key. Some of the rows were the partition key, as recipe name in our example, And then there are date and reviewer. Those are called clustering columns, and they define what is the sorting order within the partition for the rows. There can be 0, 1, or more of such columns. By the way, if they are 0, what does it mean? That partition key equal primary key, and that by definition implies that your partition is always made by one row. So the problem is not even there. But if you have some clustering columns, such as date and reviewer here, they define the order within the partition. You see, in this example, we have 3 different pizza reviews. They are a single partition, and they are sorted by date. In the example below, we have 3 different salad reviews. The first 2 happen to have the same date. Well, in that case, we go to the reviewer and sort alphabetically by reviewer. So that's a very important thing, and the nice thing is that when does Cassandra maintain this order? At write time. So every time a new write comes to the database, whether in memory or later on disk, the data, the row, is put in the right position. That is what makes also read so fast. Because when you read, you read. Okay, there are complications. There are several SS tables, but that's another point. But the principle is that when you read data from Cassandra, and you do it the right way, you are reading a contiguous set of rows. So it's fast. Okay. So how to choose your clustering then? How to choose the order in which you want to put your clustering columns? So you see, there are here 2 examples. Same table, same partition key, and there are date and reviewer, or reviewer and date, in the other case, that are clustering columns. Guess what? The order is decided by looking at your queries and finding out what is the right choice to do according to your queries, because Cassandra browses the rows in order. So let's say I have a query that requires pizza reviews of a specific date. Well, then I have to keep date first after the partition key, as in the example on the left. Remember that Cassandra wants to read the rows sequentially, contiguously as they are in the partition. So if I put date first, then my query will work. On the other hand, if my query is I need pizza reviews by Anita, and then sorted by date within that selection, then I have to change my clustering. I have to put reviewer first, so my query will be able again to work on a contiguous set of rows. Then again, there might be cases where my query will work in both cases. So if I need just all pizza reviews, I need the whole partition. I'm not even maybe so worried about the ordering within. But in general, even choosing the clustering depends on which queries I want to support. So you see, there are many limitations, if you want, in how Cassandra makes you access the data. But that's all for the sake of speed. And there is a huge gain in this case. And don't forget that you can always create a second table if you have to support different query patterns. So it's everybody wins, right? Except the disk that is maybe the cheapest actor in the story. So that's not even too much of a problem. Okay, so before closing with this very important section, I want to show you some actual code. You see, Cassandra can be accessed in various ways. There are drivers. There is drivers in any language, and so on. But below all that, the native language you speak to Cassandra is CQL, and which also is offered in a nice console where you type commands, as you maybe have seen in the lecture by Alex. CQL stands for Cassandra Query Language, and it's very similar to SQL by the looks of it. Yet there is a huge architectural difference in the underlying structure, as you now maybe have understood. So just to show you, this is a command that creates the table we have used as examples so far. So it's very similar to SQL. Create table name, field type, field type, field type, and then there is this statement, primary key. You see, primary key is a selection of the columns that will make the primary key. But you see this part in red with another set of parentheses? this is the syntax to specify what part of the primary key is the partition key. And it's absolutely important to know that and to make an informed choice on the partitioning. Okay, so this is now I'm closing with this section. And it is very important that you keep in mind that you choose the primary key in a sense for logical reasons, because in your modeling of the data, you want uniqueness. Then within the primary key, you take part of it, maybe all of it if you want, and it is the partition key, and this decides how are data physically kept and stored in your cluster. How are they grouped, and how are the groups scattered around? What is left of the primary key, the blue part, is the clustering column, and that defines the ordering within the partition, which again is important because that also implies some queries that you can do and some other that you can't do. Okay, I would say for the partitioning and the keys, this is everything. Alex, do you want to add something? Have you seen some interesting questions around?
All answered by Jeremy.
Very good. Thank you, Jeremy.
Yeah, there is only one question to highlight.
Uh-huh.
We speak a lot about denormalization, but it's always needs some time to land into the brain, into the mindset. Chatterjee Tsunit asks, if I need all reviews by Anita, then should reviewer be my partition key? And answer is exactly. If you want to be able to query review by recipe, you need a table review by recipe. And if you need to query a review by a reviewer, you need a table review by reviewer. And those are two different tables. In theory, you can try to have a single table with indexing or a single table with materialized views. But the traditional denormalization approach brings you to two different tables, updating them with badges, right?
Yeah, and don't be afraid, because usually, in most cases, that's the right choice to do. So don't be scared by the idea of having many tables. That's absolutely fine. And it's the best compromise with the real world you can have if you want to scale your data in most cases. So yes, for sure, your query will for sure have to reach a single table, but most often also every table is designed for a single query, not necessarily, because there might be many queries that are served by a single table in some cases, but usually every query will make you design a specific table. And that's okay, that's fine. Think of performance and scale. Okay, so let's speak about how to query data and, well, also how to write data in Apache Cassandra. That's much a consequence of what we have seen so far. So about writing, well, writing is a fascinating topic, and many of the details are hidden in the architecture of Cassandra. What is important for us today is just one thing. Cassandra does not Cassandra wants, let's say, Cassandra wants writes to be fast. So when I say write, I mean just write. There is nothing else happening than the write. What I mean, if you try to write a row that is already in the table, nobody is going to tell you stop, the row is there already. Because that would mean having a look at the table, reading the data, making a check, coming back with an answer. You can, you can't. No, nothing on that, because we want writes to be fast. And that's a point, because in many cases, well, there is a pattern that practically is used in relational databases that amounts to this. Let's try an insert. If it fails, the row existed already, and I do the other thing. Well, that doesn't work in Cassandra, because your write will work, will succeed, and the last write wins. So you are effectively overwriting your data. What do I mean? In Cassandra, insert and update are almost the same thing. Indeed, we usually speak of upserts. I say almost because there is a one corner case that makes those two operations different, which is connected to counters. I will almost not mention counters today. So let's say we have this operation that is upsert, regardless of whether the row is there already or not. I write it. And to write it, I have at least to provide the full primary key, because I have to identify the row I want to write. And maybe I will also have to insert other values. So let's, you can have a look at the typical insert statement. Again, this is very similar to SQL. Maybe the difference is the single quotes, as far as I remember. So insert into table, column names, values, and then you put the values. That's it. But the meaning is different, because this insert, I could write an update. It's the same. Cassandra does not waste time looking back in the stored data and checking against what you are writing. That's the point. Okay. Now, having said that, let's turn to reading data. Okay, this I told you. Nobody will tell you this record exists already. Okay, reading. Now, again, CQL looks like SQL, but it's different. Look at this. Look at this insert at this select statement. Select columns from table where conditions. Nice, perfect, and it works. You see, I get my pizza reviews. Perfect. The point is that in Cassandra, this statement, and in particular the where clause, must obey several constraints to work. Well, something we already saw in the previous section about storage of data, and let's recall them. A query must go to a single partition, and then within the partition, it has to read rows in a sequential order according to the clustering order. What does that mean? It means that the where clause in your query that reads data must specify all of the partition key with equality, with equal signs, because it has to go to a single partition, bam, to a single node. That's some point. Second point, it can specify clustering columns if you want, but remember the sequential order. We want to read contiguous data. So if I specify a clustering column, I also have to specify all columns of higher importance, all those on the left of it. So I can't just specify the third clustering column, because that would imply, you know, skipping and jumping around in the partition, which does not make Cassandra happy. Another thing connected to this is that, yes, you can use inequality. You can use greater than or lesser than, but only on the last clustering column you specify. Because again, anything else would imply skipping and jumping across your partition as you read the data, which is not something you want to do. Another point is that you cannot use any other random column in your where clause. So these are strong constraints, I know, but they are the key for fast reading of data. Okay, somebody might observe, okay, we have something called allow filtering. Let me say this. Today, allow filtering does not exist. I know there are very specific cases where it is even good to use in production, plus it is something that you sure use in testing, in development, on very small tables, whatever. But today we are considering it doesn't exist, okay? For those who know what it is, let's forget a second about allow filtering. Okay, so the where clauses. Let's see a few examples. Again, here I recall the same tables as before. So we have recipe name, date, reviewer. In particular, recipe name is the partition key, and then date and reviewer in this order are the clustering columns. So here you see there are 5 different where clauses, and they are all legal. First, they all specify recipe name equals something. So they go straight to a single partition. Everything is nice. The first one is just that, and that's okay. It will retrieve the whole partition. Nice. The second one specifies a date with an equal sign. Good. It defines a particular contiguous block within the pizza partition. Perfect. The third one is a date greater than. It's also fine, because again, if you think of the storage within the pizza partition, it is, again, you start there and you browse all rows. So it's fine again. The second to last also specify date with equal sign, and then reviewer greater than Bob. That's fine. That works, because again, that implies a contiguous reading in a particular section of the partition. Nice. The last one, similar. It is two inequalities, so it will define a range from here to here in the partition, but again, everything inside. So they are all good queries. They are all good where clauses. Okay, so these are instead bad examples. All of these queries, all of these where clauses will not work. Rating equal 9. Come on, it's not even in the primary key. No. Recipe and rating, again, as long as there is a condition on rating, that will just not work. Recipe name greater than pizza, that's interesting. Yes, recipe name is the partition key, but if you put an inequality, if you want recipe name greater than pizza, and I mean alphabetically, then you are possibly looking at a lot of partitions. So absolutely no, forbidden. Recipe name equals salad, good. And reviewer equal Carl. No, that's not good, because you see, reviewer is the third column. So I'm implying that my Cassandra will have to skip through the partition in a jumping way. So that's not accepted. And the last one again, recipe name, okay, date lesser than blah blah blah. But then I set a precise choice of reviewer. So again, that implies a jumping across the partition, and they are all prohibited. So no, these are all bad examples. Let me go ahead. Well, this is just to show you the full syntax of the select statement. That's just for the record. And I just want to specify, to make you aware of the fact that most of the parts of the select statement are very constrained by partitioning, primary key. So you have limited freedom in selecting. And that's sort of the point of this section. When you read data, you have to read that in the way your table is made for. So you probably now when I say, when you model data, you start from the queries, that starts to make sense, I guess. Even better, when you model your data, you start from the flow of your application, the word that it has to describe, and then you come up with queries, and then you design the tables. So this is the flow, more or less. I hope this is starting to make sense to you. Okay, so to summarize, when you write data, you need to give the primary key. Otherwise, you are not specifying any particular column, any particular row, sorry. Not only that, but there is no distinction between updating and inserting. That would be too costly for the latencies. So you just write fast, fast, fast. And it's up to you to take care of overwriting valuable data. When you read, you are very constrained, yes, because the structure of the table wants you to be careful in reading. And the three main points are you need equal signs to the partition key completely. You need to specify it completely. You can, if you want, specify values for the clustering columns, but keeping in mind what makes you read contiguously. And you cannot put any other column in the where clause. Okay, so that is one of the most important parts that I wanted to show, which brings me to the actual data modeling operation. So you now know the idea of the normalization. You know how data are stored and grouped in Cassandra, and you know what are the read queries allowed. Let's model some data. Okay, there is a canonical, a standardized flow in Cassandra for modeling your application data. And it is there's a flow chart here, more or less. My point is, so the main point is that you start from the application and then you come up with the data model. While in a typical relational database, you can see it here below in gray, the flow is more or less the opposite, right? So how do you do in Cassandra? Well, there are two steps that more or less go in parallel and communicate to each other in a sense. And they are the conceptual data model and the workflow model. So on one side, you do something that is very much similar to what you would do in a relational approach. You do a conceptual map of the entities and the properties and the relations that make the domain you want to use in your application. Entity relationship diagram. At the same time, you start laying out a map and a flow of what is the flow within your application. Once you have those two things, you can start mapping one onto each other, which makes your queries emerge. So you end up with specific queries for each step in your application workflow model. Okay, so you start having the queries that will be needed for your application to work. Now, query by query, you design the table. So for each query, you look at what it needs and how it needs, and you lay out a first logical draft of the table. And this you do with a very handy schematic convention called the Chebotko diagram. Now you are almost done because you have your tables, and they work with your queries because you designed them to. What is still missing is, let's say, implementation details. So making this conceptual table definition into making this logical table definition into something physical. So making them into actual create table statements. That implies optimizations, checks that you are staying within all the parameters, last minute, so to speak, choices about how to arrange one-to-manys and similar things. But you are almost done. And then you end up with a physical data model, which is basically a set of create table statements. Okay, so let's see this procedure at work on this simple example of the recipes. First, entity relationships. So conceptual data model. You speak around, you get an idea of your application, you speak with non-technical people and everything, and you end up with a mapping of what is the domain of your application. So this is really an ER model. You have entities, you have relationships, and each one of them might have a number of attributes. So you see, we have in this simplified example, we have recipes and reviewers. They are in a particular relation because, yeah, it's a many-to-many. And both recipes and reviewers and also the relation itself might have some attributes. So you can have a recipe name, a recipe category, I don't know, snack or dish, side dish, whatever. You can have, so the reviewer can have a name, a photo URL, an account ID, I don't know, something. And also the relation themselves might have attributes. So a review has a rating, has a date, and so on. So this is still a very conceptual thing, but it is a mapping of every field that will maybe enter your application. At the same time, okay, so here is the point where you can start asking yourself, is it the case to introduce a recipe ID, or am I happy with recipe name for some reason? So such question might start here already and have to. On the other hand, and at the same time, I look at my application workflow. So there is a general idea of what the application has to do. I start speaking with, I don't know, technical people, but also non-technical people to have an idea what is the application, how does it work, what steps are there for the user. And that is similar in a sense to the so-called user stories approach for designing user interfaces, because we start from what do we want to make available to the user when they interact with our application. So for example, the user logs in, or let's forget about login. User enters our website and they want to be able to type pizza, hit enter, and see the recipes. And see the reviews. So that's a query. That's a particular step in the flow of our user in our application. So they hit enter and they see a list of reviews for the pizza. And that's a query. Behind this operation, there's a query, which I called Q1. Select all reviews for a recipe name, sorted recent first. Nice. Then they see this list of reviews. One is by a particular reviewer, Anita. They want to click on Anita, and they want to see all reviews by Anita. Okay, that's another step in the flow of the application. That's a different query, and that is probably a different table in general. Then once they see Anita, they want to look at the details of the reviewer, and they might go to a third query, a third step in the flow, which makes them see the details of Anita, the photo, the profile picture, whatever. So you see, every step in the interaction between user and application is mapped to a query, basically, a way to retrieve some particular kind of data from the database, which means we are starting to map the flow of the application to queries, which is the same as saying to tables in a sense. We are almost ready to start writing the tables. Indeed, the next step is let's make the queries a bit more CQL. So let's write them as tentatively as statements. So look at the first one. Select reviewer rating comment from reviews by recipe, where recipe name equal pizza. Nice. And date greater than blah, blah, whatever. So this is a query, ready-made. I want to build a table around it. So how do I do? And this is the logical data model step. You look at your query and you start thinking of what are the fields I want to retrieve from this query. Then what are the equality conditions in the where, which means what is going to become partitioning. Then I think what are the inequality conditions. So this date greater than means that date will be the first of the clustering columns, because otherwise, you remember, my query will not work, and I want it to work. Then I look at ordering. So I want date sorted decreasing. I want reviewer sorting increasing, and so on. That's not the end of the story, because okay, I know that I want some fields. So reviewer, dating, and comment I want to retrieve from the query, so they have to be in the table. But let's not forget the last step, which is let's ensure uniqueness is obeyed. So reviewer has to be part of the primary key. So I have to lift reviewer up and make it part of the primary key, but not before date. Otherwise, the query will not work. So if you apply these 5 steps systematically, that's an algorithm to come up with a logical proposal for the table. And this is summarized by this diagram. As I mentioned, this is the Chebotko diagram, and it is a list of the fields with some markers like this K for partition key and C with an arrow for clustering column and so on. And this is for the logical model. So you see, we started from the application needs. We made these needs into a flow. Every step in the flow is basically a query on a table, and we create the table looking at what are the needs of that query. And there we are. We are almost ready to create the table. There's something to be done, because you see, so far I haven't yet assigned types to the columns. Now I assign types. I decide the recipe name is a text, date is a date. I could have chosen a timestamp, but let's say it's a date. Rating is a number, so I write int, and so on. So this is when the proposal for creating the table becomes a physical create table statement. And this is where many considerations, especially about performance and optimization, enter. Because, okay, I can give those types to the column and I'm happy, but I might take my time and make sure, are there data imbalances in this design? Are there hot partitions? Are there giant partition and small partitions that might make my nodes unevenly loaded? Are my partition going to become too big? Am I comfortable with the amount of duplication that this model implies? Is there need, because sometimes there is need, is this flow, does this flow require some client-side joins? By which I mean, for example, that my client has to read a table and then use this information to read another table. Is this okay? Sometimes this is a proper way to proceed. Is this okay for me? And there is also the issue of nesting, because I've seen that in the comments, in the question and answers. There are various ways of, let's say, hiding a one-to-many relationship in Cassandra. If you think about that, even just having a partition with many rows is a one-to-many, because let's look at this table. This table encodes a one-to-many relation between recipes and reviews. And that's perfectly fine. And that is done with a particular technical device that is one partition, many rows. Nice, fine, that's a way. That's not the only way. In some cases, I might find it better to use columns of a particular data type that is set of strings, set of numbers, or list of numbers, or a map of numbers. So there are data types that somehow are used to encode nesting or one-to-many, in a sense, relationships. On these, so this last step of making the data model become a physical data model, I have a slide just to show you that there are various choices to be done when it comes to data types in the columns. So I have the typical data types: text, int, float, boolean, blob. By the way, text in Cassandra has no fixed length, so you're not bound to say varchar 12, whatever. Text is just text, whatever the size. Then you have various kind of numbers. You have double, decimal, tiny int, small int, various number of bytes allocated. You have other data types such as date, time, various kinds of IDs, unique IDs, and so on. You have counters, which behave in a different way, and they are a special kind of column that Cassandra takes care of incrementing or decrementing and reading, but you cannot just go there and write a number because of how they work. And then you have interesting types that are collections. So you have list of something, set of something, map, tuple. And you can also create your own user-defined types. So you can create a type called reviewer that contains subfields such as ID, name, photo URL, and you can define a column to be of type reviewer. So you have various ways of embedding one-to-many relationships, if you want, or nesting within Cassandra. So let's say we have done all of our considerations in this sense, and we come up with a final data model. In particular, do you remember the rating of the recipe? It's going to be a number 0 to 10. So I decide to use a smaller integer. I decide to use a small int, which just consumes a bit less bytes, just because why not? Okay, so I did all of my final optimizations, my considerations, and here is the Chebotko diagram for the final choice with data types and everything. This table on the right, this diagram on the right, corresponds to the create table statements you see here, which is the final one. This is now the statement that makes me create the table. Now, if you do this procedure for all queries in your application workflow and you end up having as many tables, your data model is done, ready to use. Ta-da! So that was more or less all of it. So let me summarize. When you model data in Cassandra, you start with the needs of your application. There's a question, why date is text? Date is, oh, sorry, my bad, yes. That's, thank you.
Apurv is very like noticing everything.
Super. Apurv, thank you. Now the slides are perfect. Thanks to you. Sorry, I think it was, see, it was date here. Then I messed up, sorry. Okay, good point, well spotted. So yeah, that is a typical error that might happen, and then your data model works weird, but probably, hopefully that is found before going to production. Okay, so jokes apart. When you model data in Cassandra, you start with the application. You identify the workflow, which becomes a set of queries, and you end up, for each query, building a physical table. That's more or less the flow. Don't forget, when you create the table, that you need to identify the partition key that determines how the rows are grouped together, the clustering columns that define how within the partition, how are the rows sorted, and then obviously there's a query, so you need some data back. So you probably need data column or even just a clustering column, but you need some data back. So those are the parts that enter the steps in creating the table. Then you complete by doing some performance considerations, table size, table hotspots, user-defined types, various kinds of one-to-many nesting. And that's more or less it. Now, a very important thing is spend time on modeling. So don't rush. This is a phase that determines if your application will work on the long run. So, and it's not so nice having to change the data model when you are already in production. So try to avoid it. Okay, so with that, the most important part of the talk.
Yep.
Sorry.
There is a nice point from Shashank Sharma. What worries me more, when we start project, things are not clear and we need to keep changing the data model. Am I being pessimistic here? Well, from my point of view, you aren't being pessimistic, but more realistic, because it's completely fine. What it's a part of actually. That's a real life. That's how it works. Yes, business requirement changes. Today you need this data model. Tomorrow you will need another data model. And yes, there is a complication because you cannot change table partitioning, neither clustering columns, because partitioning key defines the data distribution over cluster, and clustering columns define data ways to store data on the disk, on the nodes, and as a result you just can change them, because can you imagine, like, today's hero is Netflix. Can you imagine Netflix reshuffling all of their petabytes of data?
Yeah.
Of course not, but their business also lives and changes, and the story is what basically, if your data model changed, now you have to design a new model, create a new table, and migrate your data. And that's very easy to do if you can afford downtime, and if you have small amount of data, then you just set it to downtime, migrate your data, and put it back, and everything is fine. Problem is, mostly probably working with Cassandra, you are going to have a lot of data and you cannot afford any downtime. Then it's a very different story, and it's a long story. How do you migrate your data from one table to another? I believe
this is something that is done, happens, and involves quite some orchestration on various sides.
Yes. So it's not easy, but it's doable. And actually, what I think, what we need to run a special workshop on migration, on reworking a data model. What do you think, Stefano?
Yeah.
Yep.
So
you know what?
I agree.
I'm here on your screen on YouTube, and directly under me you have like and subscribe button, and we are getting close to the end of a second to our workshop. That means you likes our content, so push that subscribe and like button, and you will be notified about the upcoming workshops, including data migration.
Yeah, which is a science in itself. So when you have to give up time, so it will not fit in an answer today, probably. Okay. So let's go ahead. Okay, so let me just mention, we have 20 minutes or so. Let me mention a few other nice things just to round up your knowledge. Obviously, this is not the end of the story. Today's probably is going to be a first introduction, which will give you pointers to go on and study and learn more about data modeling. There is a whole course on DataStax Academy on that, so make sure you check it out. But a few other tools in your belt we can already at least mention. So one is upserts and lightweight transactions. So you remember, we said that in Cassandra, inserts and updates are the same thing, which are upserts. Forget about counters for a second. Now, you probably complain, but I want to write a row only if it's not there. I don't want to overwrite without even knowing that. And somebody might say, I want to update my row, a particular field in a row, only if the previous value was this and that. Okay, that's absolutely understandable and makes sense. And there are a lot of cases where this has to be like that. User creation, user changes password, stuff like that. So yes, do not. So let's say a faulty choice would be to move to application level this check, because if you read and then write, that's a very typical anti-pattern. Because you see, if you have several clients at the same time, they read, they see that the row is not there, and they all write, then you are overwriting. because there is no coordination between many clients, right? So you have race conditions. And now you will say, what do we do? Well, the answer is lightweight transactions, because there is such a thing as a lightweight transaction in Cassandra. So look at the syntax. You want to insert this row only if it is not there. So insert into blah, 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 values, column, etc. And then you add if not exists. Nice. Such a statement, since you add if not exist at the end, has two possible outcomes. If the row did not exist, I get back an applied true. Nice. If the table existed already, I get back an applied false plus the previous current value of the row. So this is effectively a way to ask Cassandra to please check, read, and then maybe write. And there is, you see, there is a way to do that. In the same spirit, I can do a lightweight transaction of an update conditional on the value of a column. So update, blah, 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 if rating equal to. Again, I can get applied true if this went successfully, or I can back applied false because the previous value of rating was 5 and not 2.
Yep, and I want to add here, I think this opportunity is very powerful. It's very important to understand. Maybe for reviews by recipe, you don't get, is it so really important? But imagine you have your client trying to buy something with his laptop and with his mobile phone simultaneously, and he's trying to buy two different things, but he has money only for one of them. If you don't use limitations like that, if you don't check the state, if those transactions, if those operations will be executed simultaneously, he will get two things and which he can't pay
for free.
For free.
Or
so
maybe for free.
Partially for free. So in this case, we can check not only if rating equals 2, but if amount of money on account more than something, or if amount of money on account equals to the previous expected one, so it didn't change during your application run. Because if I work with mobile phone application, web application, I mostly probably can, if I chance, I will work with different servers. So yeah, there are some things like that to consider.
Yeah, so very, very good example, yes. So there are cases where effectively you want, it is correct that you want to know the value of the row before doing anything with it. By the way, there is a question in the chat. The rating has to be a clustering column? No. In the lightweight transaction, you can work on any column you want. Indeed, this example on rating is one of the data column of the table, no particular role. So lightweight transaction exist. They are a thing, and they are useful for some use cases. Again, Alex's example is perfect. Also, you don't want two persons to create a user account at the same time with the same email, probably. Or you don't want them to be able to change passwords simultaneously in 2 ways, and then they don't know which is the right password to use, stuff like that. The point is that they are the so-called compare and set operations are not as fast as a simple Cassandra write, because it's unavoidable, right? Because such a transaction requires some kind of coordination between the nodes, because they have to agree on what is the previous value. So usual standard Cassandra writes go to a node or several nodes depending on consistency level, and they just write. This one has to do something more to succeed or to fail. There is a protocol to arrange this coordination between nodes. They have to speak a few times with each other. They have to agree on the value, and they have to agree on the outcome of this transaction. So yes, it is a transaction in a sense, but it is nothing like a database lock as you would imagine in a relational database. I mean, there is no rollback there. It's not a transaction in that sense. It is lightweight, not in terms of performance, but in terms of guarantees that it offers. It is just ensuring that particular partition is temporarily locked as the nodes speak to each other and agree on what is the response to your query, which means that the performance is not as super as for the standard Cassandra writes, but still, sometimes it has to be done.
Right. I wanted to add what there is a very often mistake. Even for the people who work with Cassandra for a long time, they don't realize how heavier LVT in comparison with a simple write. So, how people consider LVT? It's read before write. Normally, I just write, and if I do LVT, then I just do read before write. So it's kind of just two operations. So it will be twice slower, which is not a big price to pay if I'm going to update your financial account, right? Wrong. Don't forget, we work with replicated distributed system that requires us to make an agreement between replicas before we all agree what, yeah, we are going to change something or we aren't going to change something. So actually, as it said, performance costs by Stefano, it's actually not 2 times slow, but I would say 4 to 5 times slower than the normal write.
Yeah. So there is some overhead. Let's say there are 4 rounds of messaging. The protocol involves 4 different rounds of speaking between the nodes. That's the point. There is also a question in the chat. Why is it called lightweight? Well, lightweight does not mean performance. Lightweight means that it offers limited guarantees, limited to that partition in that table. So it's not a lock, a transactional lock on the database. That's the point. So yes, maybe compare and set is a name that would lead to less confusion, because transaction brings back so many relational memories. It is a bit to be taken carefully as a name. So the point is that yes, there are cases where you want to use this technology, but let's say if your whole data model is built on those, then please rethink your data model, because you are absolutely not extracting the performance by Cassandra in this way. Okay, so that's for lightweight transactions. Let me speak about batches. Batches are another nice feature of Cassandra and another sometimes misused feature of Cassandra. Okay, so sometimes you want to execute many statements in a sort of atomic way. There might be cases where I want to save bandwidth. I want to pack statements together, send them at once to the Cassandra node, and have it execute them. Nice. Indeed, batches offer exactly that. They allow you to pack some statements together. I think up to 100 or something. Don't remember. And they get sent all at once to the server, to one of the coordinator node. It then ensures that they are all executed because it has strong retry mechanisms and so on. Now, in this statement, you can put only DML statements, so data manipulation language, which means insert, updates, or deletes. And well, it is sort of atomic, but not a transaction. What I mean is that all statements will get executed eventually. There is no rollback as if it were a real transaction in a relational database, but you have no guarantee that all writes are visible at once. So atomic, but not consistent in a sense. So everything in the batch will be executed, but if you happen to read from that table halfway through the batch execution, you might find some of the new values and some of the old values. So take that as a caution. Not only that, okay, so this is the general idea. So when it is absolutely perfect to use batches, let's say you have 2 tables very similar with same partitioning. And they describe the same data. So they are 2 tables that reflect the same recipe data, the reviews. And my application is adding a new review. So it might group the insert on one table and the insert on the other table in a single batch and send the batch to the coordinator. Very nice. This is a super nice fitting example because you see the partitioning is exactly the same on the 2 tables. So I'm sure that my batch will go to a node and that node will execute all of it. No problem. So this is performance-wise, it's a dream. A similar case is when I'm inserting several rows on a table that end up in the same partition. So there are two new recipes of falafel in the table. Falafel is the partition key. So I'm inserting two new rows in a single partition of a single table. Very nice. I close them in batch and I send them. And those would be the golden examples for batches. Now, in real life, sometimes it's also useful to do slightly spurious batches. So the so-called multi-partition batches, or which automatically become logged batches. What happens? Do not consider batches as a way to pack together as many inserts as possible and then send all at once, because that is absolutely a performance killer. By the way, you have no guarantee that the batch, that the statement are executed in order within the batch. And there are also limitations when batches contain lightweight transactions and counters. You have a lot of limitations. So the point is that you can sometimes find yourself in the situation where you want to group together some different inserts on different partitions of different tables, and you want to group them in batches, which potentially might also have to communicate between nodes. Sometimes this is okay, but consider that implies a very, very degradation of performance for those writes. So again, know what you're doing, use them sparingly, and do not build your whole application workflow on top of batches. Alex, you want to add something on batches? Usually, that's
not
all fine.
today.
Okay.
That's not today.
Okay.
I'm answering questions.
Okay, sure.
I'm answering. Okay, maybe that's a good question, so we can answer by voice. Raul asks, what's the use of batch if it's not atomic or has rollback and not parallel? First of all, that's very important to understand what if you are going to make a change into multiple tables for the cross-table integrity, for the cross-table consistency, you do want all your records, all your mutations, all your updates to reach the tables and be stored. And if you, let's say you are going to update 3 different tables, if you don't use batch, then you at your application side has to send multiple inserts. And what happens if your application server fails because of power outage at the moment you are trying to do your inserts? 2 inserts are done, 1 insert is failed, and there is no cross-table integrity, and you are in troubles now, because how are you going to recover in this state? To avoid this situation, what you can do? Persistence. So first you persist operations you are going to do on disks, so you will be able to reply them. Then you try to execute them. If everything is done, you will remove this file with 3 operations from disk. Operation is complete. If it's not complete, if your application server failed, it recovers, it reads operation from disk, and replay the situation again, and then you can discard this file. You know what? You just invented Cassandra batch.
Yeah.
So basically, that's how batch works. You send the batch. You don't have to persist anything at the application side, because Cassandra cluster, the first node which gets your batch will be a batch coordinator. First thing it does, it persists batch safely and then play it. And if anything happens with this Cassandra node, it will replay batch as soon as it recovers, because batch is persisted. So batch is a guaranteed way to deploy mutations to your database. And you can try to emulate it on your own in your application. But you know what? I believe what lazy developers are the best. If you already have this feature, then why not just use it and don't develop it again? It's already developed by the Cassandra community, okay? So that's why I use batch.
Yeah, good point. This applies to the most interesting batches that are the logged batches. As the name implies, and Alex said, there is a log. That is, first thing, the log is stored, the batch is executed, and then once everything is done, the log is deleted. So this is a persistent thing. And every batch that works on more than one partition is automatically logged. So this is, thank you, Alex. Good remark. Okay, so I think we have a few minutes, so I will just make you aware of the existence of another couple of features. Then they are for you to investigate more. One is that you can define time to live to cells in Cassandra. So you can define a number of seconds. You can define a number of seconds the data you inserted will be there for. After which the data will evaporate away. Just be careful because this is always per cell. So if you do a certain timing to this time to live, you might end up with magical partial rows that you never inserted by yourself. So a part is expired, the other is not. But it is all in all a very useful mechanism, maybe more to keep your table clean of old stuff than to embed logic in it. So if you need logic, probably you want to have a separate column date and to check in your application against that. But in general, the time to live is a very useful addition to the Cassandra models. Another thing that we usually keep last purposefully is that Cassandra supports indices. After all, we said you can define secondary indices on tables. Yes, you can. You see, there's an example of a query that did not run, then you create an index on the table, and then the same query finally runs. Super nice. This works by creating a secondary index on an existing table, but there are all sorts of caveats to be aware of when you create indices. The column you index on must behave in the right way, and the indices follow the distribution of the base table. So the index does not magically create a new table distributed in the new way. So if you're querying with the index, if you are not careful, you will end up doing a very slow query because it will have to go to all nodes in the cluster before it finds your match. So, but in some cases, indices are very useful and very powerful. They are not a replacement for the good old denormalization. That's my point. Last point that I've seen mentioned in the chat as well is that Cassandra supports materialized views. So you can ask Cassandra to kindly take care of maintaining a new table with the same data as the other table, please, and Cassandra will do it for you. You see, from this recipe name date reviewer, here I create a new materialized view that is a table I can't even insert into. I just leave Cassandra take care of this table. And then my queries will work in a new way, basically. Just be aware that you have some constraint on how to choose the new partition and primary key. And in particular, okay, the update is asynchronous. So Cassandra has some background jobs that keep this materialized view in sync. But the important thing is that you should not just create any materialized view, because if you get the partitioning wrong for this one, it is a table for Cassandra. So you will end up having terrible giant partitions or whatever monster you can imagine. So you keep an eye on partition size also for the materialized views. So consider them as sort of an experimental feature, and before using that massively in production, take care of what you're doing, so to speak. Well, this was by design just a quick mention. I think we are right on time.
Yeah, we are right on time. There are a lot of questions about is materialized views production ready? In short, my answer will be so I know some success stories with materialized views. I know some not so success stories with materialized views as well. There are some limitations, and current implementation of materialized views has its issues. That's why currently materialized views are considered experimental. I hope that will be fixed in the end. You know what? Apache Cassandra is an open source project, so if you are not satisfied with something, go develop that. We will help you to become an Apache contributor. We will be happy to do it.
Yeah, that's a great answer.
But besides that, yeah, we have to stop at this moment, like 2 more minutes, because we have to start our Ask Me Anything session.
Yeah, very good.
So you have 1 minute to complete the last slide.
I've said everything I wanted to say. So don't forget there are ways to exercise, to investigate deeper, to do hands-on exercise in your browser, the courses. If you're interested, obviously 2 hours are not enough to know everything about data modeling. So please go deeper into the topic because it's absolutely fascinating. And I hope this has been fun and most of all informative. I hope you learned a lot and see you in a few seconds in a Q&A session. Thank you.
Definitely. Thank you so much. And we will be back in a couple of minutes with Ask Me Anything Q&A session. See you soon.
Yeah. See you.
Hey, looks like we are back. 1, 2, 3. Can you hear us? Can you see us? Hey, gentlemen. Alex, Sarma, say something.
Hello everyone.
Hello, good evening in India.
Yes, perfect. So it looks like our sound is good. And it looks like we have a lot of attendees asking questions, and we have a lot of questions. If you can, that's a question to my dear colleagues, Sarma and Alex. Can you see the translation? Can you see the screen?
Yeah, I see the screen. The YouTube channel, yeah.
Yes, great. Sarma, do you see it? Oh, I believe.
Yes, I was reading some of these questions.
Good. Yeah, there are some nice questions, by the way. Okay, we are missing the fourth guest expert, but okay, let's start. There are many people wait, and we don't want to make you wait for too long. So let us proceed. We are almost in the end of our Cassandra Day India. It was great, and actually, oh my God, I just noticed it. You submitted 130 questions. That's amazing. And we definitely have the first winner by the number of upvotes. 40 upvotes. It's the most popular question, obviously. So, SG, please contact me after the presentation. After the Cassandra Day, I will send link to my LinkedIn profile in the chat, because your question definitely deserves a prize. Give me a moment. Good. Now, so gentlemen, let us start then with this question, right? As it's so popular, we have to start with that. There are other competitors like Bigtable, Scylla, which are pretty cost-effective and highly performant. What are the Cassandra differentiators then compared? Great question. Who wants to answer first?
Alex, sit back. So
Okay, no, I can answer. Yeah, I can take it.
Okay, please.
So basically, it's really there are multiple dimensions here. So if you talk about the big table, the first thing that we need to understand is really the hosted versus self-hosted. So it's really like we are talking about like maybe the cost efficiency of the table, because it's not maintained by us to get access, etc. But as usually, it's all depends on the scale. This is similar for the all hosted solutions. If you have a traffic that you get in the hundreds of thousands requests per second, then it's most probably will be very expensive. So it's really this is the first dimension. Then we will talk about the things like DataStax Astra that's also hosted for you. Then we can maybe talk about like Cosmos DB, etc. So the first step, it's really like hosted, not hosted. So it's hard to say about that. And another thing, the big tables, it's a regional one designs. Basically, initially Cassandra was based on the big table design, but it's once with introduction of SQL, it's changed. So also the database design is makes sense to look, will it fit in your setup? Regarding Scylla, it's hard to say because they have some features and in some benchmarks they are faster, but if I remember correctly, they have they run fast only on specific hardware. If you have like PCIe disks, etc. So it's an and also they have some interesting features. But Cassandra right now, especially with upcoming things like storage attached indexes, etc., will jump ahead again. So basically, if you talk about the still like there isn't still many features that are missing, or like file formats are supported, etc. Really, but I don't want to say it's really like the difference, and you need to evaluate the options like pricing, costs, ability to scalable maintenance for your project. Yeah. Does that answer your question?
Yeah, I think so. Sama, do you want to add anything?
Yeah, that was nice summary from Alex. Like, it's not very difficult, very easy to answer this question because it's very wide. But what I would like to say from the Cassandra side of it, we have a wonderful community. So there are so many developers developing on top of it. We have nice integration with third-party tools, and obviously other products might scale to that level, but Cassandra community is just huge. And that's what I see as a positive side if you start working on Cassandra side of it. So yeah, I mean, I favor to Cassandra, but obviously I haven't worked on Bigtable, so I cannot comment on it.
Yep, I have some experience with Bigtable, not Bigthrough. First of all, for me, Bigtable is a only managed, only proprietary solution by Google. It's good database, so nothing like I'm saying it's Bigtable is bad. No, Bigtable is not bad. It's just very limited from these points of view, as already covered by Alex, for example. Well, so far still for me looks like a startup which may survive in the future or may disappear tomorrow. So far it's a project of a single company, not the big full, not a project like Cassandra, which is developed by Apple, DataStax, Netflix, Instagram, and all the others, many companies putting their efforts into the Cassandra, which belongs to Apache Software Foundation and truly open source by nature. So for me, it all brings quite a long story. These kind of questions we can answer, we can spend a year answering basically, because there are a lot of things to consider, but we have to move on. It was a good one. And next one is interesting and quite popular too, from Apurva. How okay, I started to speak about this one, so I will stick that to the top for a second. How can I find how many nodes with what hardware config course program is required for a specific number or read-write operations? Question by Gaurav Gupta.
It's a good question, really. So it's as well, it's many things that you need to consider when doing the size estimation, because performance depends on the multiple things. Things like data model itself, the replication factors that is used, the consistency levels that is used in the operations, then hardware itself. So how much memory do you have, etc. So right now in the age of the cloud, it's quite easy to do by just running the experiment and making sure that you have an environment, so for example, that like 5 nodes with replication factor 3. It's there's a main problem that I always have seen, that like users, customers were testing with 3 nodes with replication factor 3, everything ran fine. Then they were adding 2 more nodes, and then everything is much slower because of the need to have an go between the networks, etc. I usually recommend create a model for your database, and then use something like NoSQL bench to run the test against your database, you only just need to have a representative data set. And NoSQL Bench can help a lot. We have used it a lot for testing the different hardware configuration, data models, etc. But the main thing, you need to test for a long period of time, quite long, so not 5 minutes, because there are effects like repairs, there is effect like compaction, etc. It should be like taken into account. But experiment is the best way.
Yeah, as Alex said, right, each application is very different. So I would put a lot of testing in non-prod, and also make sure your non-production server is also beefed up, which looks like production, just to make sure you get the right workloads in place.
Yes. Okay, so I believe we answered that, and meanwhile there is in the chat also a discussion mostly exactly about the NoSQL bench suggested by Jeremy Hanna. Well, we know him, and others also as well. There is no simple answer. You need to try to make the testing first with NoSQL bench. Nothing for me to add. Basically, you answered this question, of course. Good. So next question. Apurv Gupta, how Apache Cassandra database deals with split brain?
I personally can't comment. So it's we need maybe somebody like Jeremy answer. So.
Now, Jan, please.
Yeah, the only thing I can think of is, watch your gossip and repairs. I have no clue how split brain can even happen.
Split brain can happen in theory when we have, for example, 3 data centers, and 2 of them can communicate and interact with each other, and the third one is not accessible. So we have group A and group B, and there is no communications possible between 2 of them because of some failed networking between 2 data centers. In general, answer is, in this case, my answer is very simple. It all depends on your consistency level, because, for example, we imagine we have a data center with 3 server racks. We have server rack A, B, C. A and B available to clients, can communicate. C is available to client, can communicate, let's say, like some network fluctuation. But A, B cannot talk to C. C cannot talk to A and B. Partitioning, network partitioning. That's a big problem. Many databases run in complete failed state in this case, and basically you get this split brain issue. My suggestion in this case, so it all depends on your consistency level. If your database expects if your client expects consistency level quorum, then in the AB group for quorum is reachable, and on the C group quorum is unreachable. Therefore, all the operations executed with AB group will be executed with consistency level quorum. All the operations routed to group C will be not completed and will be failed because you have desired consistency level set to quorum. And that basically means what database will not be available for all the clients trying to work with group C, which is bad. But believe me, if that would fulfill your operations, it would be much worse. Because, well, then you will have zero integrity between the data in group AB and group C. And what's the worst in this situation? Basically, you have no way over than manual, over than logs, basically, to try to recover your database into the consistent state. So Apache, short answer to this, Apache Cassandra database deals with split brain with the help of the consistency levels.
Yeah, okay. Really, like, I originally thought that ACDB means Astra Cloud database.
Ah!
That's why I didn't answer.
Okay.
It's interesting, but yeah, it's really Alex is correct. It really depends on your application and like, do you really need to have an strong consistency levels in your application? It's always a trade-off about the availability of database versus consistency, and in many use cases, it's okay to serve the stale data or something like. Of course, depends like if you have an payment transaction processing or something like, it may not be desirable. Also, I've worked with some clients who like favors the availability versus consistency. You may not see the like transaction immediately in your bank application, but the transaction pass through. So okay, but yeah, consistency level could be dependent on the like, you can use a quorum for normal operations and like get back to the local quorum potentially for the other operations. Mm-hmm.
All right. Good. So I believe we answered this question. Let's move on. And next question. Oh my God, you people are asking so wide questions. What is the relationship between Apache Hadoop, HBase, Hive, and Cassandra? Okay.
Let me take that. So a relationship is very difficult to say. Like, we all know that Hadoop is the beginning of all this big data stuff. I personally have not worked on Hadoop. HDFS is still very live and people use HDFS a lot. HBase and Hive, kind of very old. I don't know if I want to use it. And yeah, so the Cassandra started with these concepts of big data, and in relation, I would take Spark and Cassandra. That's much better. Run it on HDFS. That is the part of Hadoop.
I can maybe also a word. So basically, I think the relation could come from history. So basically, the Google published the big table paper, and original Cassandra design was based on it. So basically, why it's still called a wide columns stuff. The Hive or the HBase is also based on the big table design, but they stay on it. So basically, they didn't change in contrast what the Cassandra did to the table-oriented predefined schemas, etc. And then we from the Hadoop we can from the HBase we can go to the Hadoop, where because HBase is needs the HDFS to store the data. But also HDFS has become the bottleneck in this case, because in this case it's an HBase not partition tolerant. It's favors availability or traits availability versus the consistency. And Hive is because like HBase and Cassandra is an online transactional system. Hive is OLAP system. It's an analytical system. You are running the query. Hadoop is under the hood running a lot of tasks, and then you get the answer in some time. But it's not, we are not talking about like milliseconds response time like having HBase and Cassandra. I did use HBase for some time, 5-6 years ago.
Okay, so I believe we answered. Nothing for me to add basically. Next one, how gossip works. This one is quite good. Okay, so gentlemen, how gossip works?
So basically, gossip is works as following. So basically, when you when Cassandra node starts, it joins to so basically, okay, if it's joined to the cluster, it starts. It's on the start, it loads a known configuration of the cluster and start to exchange its information with other nodes. So basically, every some period of time, each node tries to communicate with some other nodes in the cluster, and sending its own view of the cluster. So the information about like its own state. For example, we can have some kind of health index inside the payload. It also sends information about the other nodes, like is the node is up or node is down. It's exchanged information with about the schema version, etc. So basically, it's not communicating to all nodes in the cluster at the same time. It's selecting some nodes and exchanges this information. There isn't like a lot of optimization there, so we don't send full snapshot of all known data. We only exchange this information when necessary. Another thing that I want to mention, basically, Cassandra selects other nodes more or less randomly, with some exception of the seed nodes. There is a higher probability to connect to the seed nodes to send the information because it's the nodes from which the other nodes are having higher probability to get the actual data and get the correct state of the cluster. So it's like basically if when the node sends the data to the seed node, the information spreads through the cluster much faster. But the idea is very simple, and this part was a comment from the, if I remember correctly, from the Dynamo paper, DynamoDB. Plus, it was extended with the things like failure detection algorithm was added to it for faster detection of the machines when they are down.
So I see gossip as like, Snapchat. So each server is sending its information to the other servers in the cluster. As Alex said, it doesn't send it to all servers, but every server is participating in that communication, and they all share that information saying, okay, I'm having, let's say, chest pain. I'm having, storage problems. So these gossip messages are very small, and they exchange the message between the servers. And whenever there is a quorum of other servers, see there is a problem with one server, they basically understand that, okay, this one node in the cluster is having issues. Now, remember that whenever a client, like say Java Cassandra driver or a Python Cassandra driver connects to the cluster, we call them just client for just better understanding. The client also listens to this gossip. It also gets the messages. Say, for example, one node is restarting, so node is going down. That client is getting that update from the cluster. So the node which is the client is communicating to, if at all that particular node, which is coordinator node in theory, which is going down, then it can communicate with the other nodes in the cluster. So remember that gossip is just short messages sent across the cluster, and not only within the server side, even the clients listen to that gossip. They participate in it.
There is a comment about the catchy name for internet communication. I just want to clarify that. The gossip is a part of the internet communication, because internet communication includes things like repairs, sending the request to other nodes, etc. It's really the thing part of internet communication, but a separate set of the messages and that are going over the wire.
Okay, so I believe this one was well explained.
Yeah, so it's there is like a question about does client interact at node level or cluster level. So basically, it's just one thing. It's I really like the Java driver documentation for a lot of explanation how things work. Usually, like client connects to so the client connects to the node that is and opens so-called control connection. Then on this control connection, it receives the pieces of the information from the gossip. But really, like client, through this control connection, see the state of the cluster as this node see it. So basically, if you connected the client to a node and you have a split brain, it will, even if the cluster is available, it will see the only part of the cluster until it's reconnected to some other node. It's just for clarification. Look into the Java driver nodes or driver documentation. It's very interesting reading how the clients and Cassandra works.
Okay, so we still have more than 100 questions, gentlemen. So let's speed up. There is also a question I really like from Kritika. How does Cassandra achieve zero overhead while adding new servers? That goes to elastic linear scaling, I believe.
Oh, it's a good question. I don't really fully understand it.
I believe, so it's based on the first workshop. That's why I can answer it and I can explain that. So take a look. Question is, do you remember maybe this very nice slide, very nice graph picture from Netflix, Tech Blog? They did an experiment on scaling cluster from 45 servers to 300 servers. Growing the workload, and it was a nice smooth line, straight line on the performance. So not a decreasing growth like most of the databases do. You can add more servers, but you have overhead of new servers adding. So the performance start to degrade at some point, and every next server add you not as much as it could. And in the end, at some point, it's a straight line already, not growing. You understand what I mean?
One thing that I wanted to mention, so it's really like adding the new server is not free. I mean, from the perspective that because you need to distribute the data to a new server, it's still you need to read this data from your disk. And if your node is at the 100% load already, the addition of new server will add like some additional overhead of reading the data from the disk. Of course, it's a bulk reads, it's there, it's maybe not so big, but it's also needs to be taken into account that like don't add the servers in the peak times, for example, if your nodes are overloaded. Usually, what we worked with companies, big companies, especially like telecommunication before the iPhone launch or something like this, it's cluster expansion then done days and weeks before. Because like you then start to get the steady load, it's there. It's not like in some rare cases you can add like if you see the need, but usually it's like please monitor. There are things like for example at Ops Center there is like thing like that can recommend to add you new cluster based on your data growth, etc. Monitor the number of requests, latencies, etc., and then decide to add the nodes.
Right, I'm trying to find the picture. I use it to explain the... Oh, got it, finally. So give me a second. I actually want to mention, I want to show it. Almost done. So, boom. Oops, not like this. How do I split you? Oh my god, sorry. Yeah, finally. So hopefully now I can see what I mean. Where is my slides? Okay, yes, you can see what I mean. What I would add, what I would mention here, what linear scale up of a cluster is all about data modeling. You can handle any amounts of a job as long as you have a good team and you share the work in a reasonable way. So it's not like one person is doing all the work and all the others are idling. As long as you are sharing work between your workers or database nodes, in this case, in the even reasonable way, so they can tolerate it, and your data model is good. So if one guy can like carry 20 kilograms, let's say, you don't give him 100, he's mostly probably going to die under this pressure. But if you need to carry 100 kilograms, you just add some more people to carry on this weight, split it into reasonable doses. So if you're those dozens of load you are going to carry, so partitions basically are of a reasonable size, and you can add more and more servers, and those partitions will be splitted over them. Cassandra Design supports it very well. As soon as your partitions are not even, some of them are too big, some of them are too small in comparison with others, then you run into the troubles, and Cassandra will not scale linearly if your data model is bad. That's why I asked you to pay attention to the data modeling workshop done by Stefano today. That's my answer to this Cassandra scales linearly story, and let me switch back to the slide on. Good. Okay, so what comes next? Shashank Sharma. You create the query, then the table. Now it will open a Pandora box for a dev. We need to find all the possible tables where that particular data is stored. So take a look. Development of, so I want to take this answer. For me, it's more about the development, and I spent hell a lot of time developing shit. So take a look. Development of the application for the highly loaded distributed environment. It's a hard job, and it requires a lot of discipline. It requires a lot of development things like code reviews. It requires like going to need quite a strong team of developers. If you just take a bunch of juniors, throw them and go develop Cassandra applications, they will do it, but you will then be very sorry about the outcome. So now we need to find all the possible tables where that particular data is stored. No. If you are trying to find all the possible tables where that particular data is stored, it means your development failed already. What does that mean? If you have to look for them, if you have to find them, then you don't know where are they. And it has to be from the very beginning of the development clear, but okay, that's part of my code, works with this data, and all the required operations done with this way, and there shouldn't be hundreds places in your table, in your application. You have to change 100s of the queries. It has to be centralized in the good meaning of this word, and process it properly with some clean code approaches, single responsibility principles, and so on and so forth. So you need to understand what you are doing, and it's not an easy job, but mostly probably if you are working with a distributed application, you have Apache Cassandra, you at least got a decent salary for that. So don't look for the possible tables where this particular data is stored. You need to know it in advance with your code, and that has to be very clear. If you got into the situation what this application has been developed in that way, what no one understands what is it and where it's stored, then you need to refactor this application. Otherwise, it will work very bad, of course. I'm sorry for a little bit of expression, but it's a painful question. I've seen it many times, people just doing some job without understanding what exactly they're doing. Yeah.
Alex, I have a small advice here for just the community, right? Regularly, it's not directed to Shashank. Generally, people coming into Cassandra, I tell them about data modeling, right? Data modeling is the key. If you don't understand how to data model, then don't use Cassandra. It's not a right fit. And also, I know Alex and Cedric, they basically run these workshops. Almost every week, there is a workshop about data modeling. I'll give you an example which happened about 5 years ago. I was pulled into a emergency call. Basically, they deployed some new code yesterday night, and what they told me is version 1 of the application was very good. Version 2 is very bad. So the only thing we identified there was a data modeling. So somebody in the developer knows how to create databases in RDBMS, not taking the name. So they just created RDBMS style tables where the ID column is a UUID. They never use the UUID for query, and that's completely wrong. Right. So we spent about a week working with them, data modeled it, and after that, application team did not talk to me for like 4 years. So do the data modeling right. And I would say attend this data modeling sessions or workshops. What Alex creates almost every week. They do this. So it's a key to learn how to use the database, not just use it as RDBMS.
Thank you. Yes, our job is to make you successful with Apache Cassandra and related technologies, and we are doing our best developing different workshops for you to learn and try to do the best. And we are done with this one. So this one is really this one has really a lot of likes, but it's a little bit out of topic. So I will ask you to stay very short on that. To improve skills in data science, what are some good Cassandra-based project ideas one can build? Gentlemen?
From my personal perspective, the Cassandra shines closer to the serving side. Cassandra is based, for example, for the project Michelangelo, that is implements a feature store. Because you can quickly fetch the data. You can load the features for your model. For example, it's a typical use case when some input data comes when you serving the model predictions, and you enrich the data with some additional information. For example, if you receive a query to predict the credit score, and you get user ID, maybe it's there, you can then pull the rest of the information from Cassandra very fast, and then you answer it very fast. It's one of the very nice features of Cassandra that I would highlight. Yeah. I think the rest, look into the Michelangelo and or implement the feature store yourself. Especially it's very nice integration together with Spark.
Yep. Sarma?
Yeah, I definitely suggest playing with Spark, Cassandra. And because that combination is deadly, we have put together some information you can look up on LinkedIn, find me, and on my GitHub I have some information, but we'll try to put more projects together. I'm sure Alex also has some projects in pipeline on this.
I will also mention what looking for data science connected to Cassandra. I would definitely take a look at the teamwork of Apache Cassandra plus Apache Spark. Together they make a great team, and running machine learning training models in Spark with Cassandra can be a really great story together, because they on the very different side of this field, and together they built this dream team. And Astra. I'm trying to answer 2 questions at the moment. So let's get back to that. Next one. How are communication latency and overhead handled in the cloud native approach? Do you guys understand what the question is?
I'm trying to understand. I think it's maybe comes more from the background. If you like trying to use cloud services from the on-prem solutions, something like. Okay. Another thing is really comes to Cassandra itself, and for example, how Cassandra can work over the slow links or something like. Then is where it comes this fee threshold. Potentially, you can tune if you have really slow links and need to that the nodes are not going up and down in this from the status perspective. It's an yeah, and it was especially at the beginning in the AWS lifetime when it was common to set this threshold to very high value because so the nodes in the different region didn't go up and down all the time. From the client perspective, I would say try to bring the client closer to Cassandra to avoid this overhead. Same data center, same availability zone or at least region. And use, there was a very nice white paper from DataStax development team about the designing fault-tolerant applications that had a lot of useful advice on correct architecture design from application side, so you have low latency answers as well. If I understood question correctly.
Mm-hmm.
So personally, I think this question is for like, when you put Cassandra on cloud, and we might be talking about multi-cloud. I personally would put, one data center in only one cloud. Don't mix up the data centers, and have your client stick to the data center to avoid latencies, basically. And one data center, I don't expect it to span across multi-regions if you're talking about AWS regions. That will keep your latencies low. Obviously, if you mix all these things like multi-cloud and multi-regions, then latencies will come in. So just during architecture phase, just make sure you design your clusters properly, so that way you don't mix up all these things.
Right. Okay. So we have few minutes left. There is a question full of pain. Is it possible to completely migrate to Cassandra from relational database management system?
Yes.
Short answer is, I will first give my short answer when you please put your point of view on that. My answer is yes, but what you can is doesn't always mean you should, because you see on the big projects, you usually need multiple different purpose databases. And Cassandra is not a general purpose or multi-purpose like some traditional relational databases. It's very strong, it's very performant, but with some solid limitations. Yes, you can to completely migrate from Cassandra from relational database, but that means you, in some cases, it may be better to consider splitting data, for example, thinking of microservices, thinking of using databases what fit purpose of your database, fit purpose, picking database what fit purpose of one particular microservice, one part of your system. For example, there are graph databases. Are they good? They are amazing. Should we drop them all because Cassandra is great? No, they serve to different purpose. And there are situations you need graph databases. There are situations you need Cassandra. There are situations what you need Mongo, and so on. And in the applications, you may have to use multiple of them. That happens quite often. So my point here is not to rush to drop everything to migrate to Cassandra. I understand what some of you may have a situation the management forces them to use Oracle or I don't know, MySQL, which is sharded for many years already because it doesn't handle your workload and you dream to migrate to something better. Yes. In this case, that they indeed may make sense. But in some scenarios, you have to rethink what you have right now and what you need to have in the end. And then you may find out what you will, for some of your workloads, better use some key-value databases like Dynamo or like, I don't know, Redis. And for some of your use cases, you will need graph databases. And for some of your cases, you need Cassandra. So think ahead and don't rush. That's what I wanted to say. Gentlemen?
Yep. So converting from RDBMS to Cassandra is possible. We did it. We migrated from IBM DB2 to Cassandra. So pain points are we had to train a lot of people internally. So, people who come from RDBMS style of thinking, they continuously do wrong things, allow filtering on every single query. And we had to fight with developers for 8 months on this. This is the live scenario. But once we started educating every single person on the team, saying, don't write allow filtering or don't do it this way, or don't use ID columns like, UUID columns for your partition keys. Things got better. But whenever a new developer joins the team, obviously that education is most important. And I keep sending them to this data modeling courses. but it is possible. Yes, we did it.
Yep.
Yeah, I had the same experience when we moved from big mobile operator from Oracle because it could not scale at all. They could not buy the bigger machine.
So they literally reached the top limit of the vertical
scalability.
Yeah. Is that a secret? What server they were using?
I don't remember. It was, I think, most probably HP or something like. I don't remember the model.
Yeah, but that definitely was such a monster.
Yeah, it was a monster, and I will say that this monster was able to handle only 20 million subscribers.
Mm-hmm.
When we moved to Cassandra, at the end of migration, the single Cassandra cluster was able to handle more than 70 million.
Mm-hmm. Not surprising.
But it was completely pain towards the data modeling, etc.
Oh, yeah.
I can say what the Sarma said about the need to teach people because ops team was coming from the RDBMS background. It's another operations, etc.
Yes. There is a side question on YouTube from Manish. Simple strategy for replication places replicas on consecutive nodes in a ring. Does network topology strategy also does same? No, it doesn't. It's much smarter. I love questions I can answer fast. So, okay. How different is Cassandra from CouchDB? I'm sorry, I have literally zero experience with CouchDB, so I won't be able to answer this question. Maybe you?
CouchDB is basically the document database.
Mm-hmm.
That's all. It's the main difference. It's a completely different type of the database. It's closer to the MongoDB. Also, I will say it was a nice feature. We need also to talk about it's like CouchDB versus Couchbase. It's there because there are the differences. Because Couchbase could be also used closer to Cassandra as a key value. CouchDB itself, the nice feature was you could provide a custom conflict resolution for you for the database, not only like what Cassandra is doing using the timestamp, but also whatever logic.
Yeah.
But
Sarman?
Yeah, it totally depends on the use case as mentioned here by Alex, right? It's a document database. So if you're looking at Mongo, then compare between Mongo and CouchDB. It's actually very difficult to compare between Cassandra and Couch. So maybe just stay with the type of the database you're looking at. especially NoSQL has 4 types, so we have to research on that.
Good. Yeah, so it's you see, it's like to compare airplane to a ship. Which one is better? Well, man, they are just different. So that's nothing like airplane is better than a ship or vice versa. It all depends on your use case, and they have different use cases. So we are almost at the end, and there is still so many questions. How many data centers can Cassandra cluster have? Let's make it quick. How many data centers can Cassandra cluster have? Guys, I have no idea.
You can have 100 data centers, but why do you want to have so many? just have 3, right? I would go with 3. One is your live, one is your analytics, and third one is the backup.
Yeah, it's heavily dependent on the use case, because we had the customers like shipping companies, etc., that like basically 2 data centers in the US, East Coast, West Coast, then something like Japan, then separate Australia, EMEA, this kind of separation. So it was like 6, 7 data centers. But you need to like theoretically, it could be a high number, but then you have an overhead with communication between the data centers and operations and other things. You need to design the data model correctly, or replications, for example, that especially if you talk about the GDPR requirements, it's really, and as you, for example, starting to create the different key spaces for different combinations for regions, basically explodes. But yeah, I agree about like analytical backup, etc. Also, we always recommend to have all data centers, maybe except the analytical equal from that perspective, and be active everywhere. Mm-hmm.
Perfect. Next one. Right. What is Kundera and Hector in Cassandra? How are they related? Who are all those people? Like, Cassandra world is huge.
Hector, if I remember correctly, it was an Java client for. Let me look if I remember it correctly. So Hector, it's one of the clients. Original clients, I would say, to Cassandra at the time when it was Thrift-based primary.
Okay, so it's a long forgotten story.
Old time, and like if you go to the Hector GitHub, it's saying use Java driver for Cassandra.
All right.
Kundera, I don't know. I think it's for something like Scala library. Don't remember.
Okay. Salman, anything? You don't have to.
No, I don't have experience with both of them.
So. Good. Yep. Okay. Meanwhile, there is a side question. Where can I get this session recording? We will send all the materials in the email to everyone who has registered for this event. So don't worry, you will get every recording, every session. Now I will answer very quickly to this one. What does local quorum means? Very easy. First part, so that's about consistency levels. First part, local, means what we require confirmation only from the local data center. So it's the data center which is considered closest to the application server you are running instance of your application. If you run your application in the United States West, you want it to work with United States West data center, right? So it means we wait for confirmation only from the closest Cassandra data center. Quorum means what we will wait for half+1 server answers from these data centers. So for example, if you have replication factor 3, it means what we will have, we will wait for 2 confirmations what data has been stored, for example, from the closest data center to us. I hope it's clearer now. I like this one. What is the term snitch in Cassandra? Give some example. Gentlemen?
I can say, I mean, snitch is a very large topic, just like gossip. But snitch provides the network knowledge to Cassandra. So it basically helps in replication of data and placement of data for safety. Like snitch is a very large topic. I would say snitch is the network information for Cassandra.
Yeah, it's convert basically the gives the information about the topology, and depending on the implementation, it could be the either from the local file, it could be from the cloud provider, like mapping the availability zones, for example, they presented as an Rex, and data center and regions are represented as a data center, for example. So it's but usually we are recommending to use the gossiping property file snitch even in the cloud, because it's making your potential migration to other clouds or having the multi-cloud setup easier.
That is cool. That's actually quite interesting. Yeah. So in general, as the gentleman answered already, snitch is about, you remember Cassandra network, oh my God, Cassandra replication strategy, network topology aware strategy, network topology strategy. Network topology means what this replication strategy understands network topology. And the question is how exactly it understands network topology. It understands network topology with a proper snitch. There are multiple kind of snitches. You can just describe your topology in a configuration files. You can enable gossiping for that, or you can use, for example, I don't know, AWS-based snitch, which will help you to use availability zones, features, and so on and so forth. But this suggestion by Alex is indeed very interesting, because for the migration, if you will need to migrate that, then switch off, if you want to migrate from AWS, for example, to shut down AWS snitch is going to be a lot of fun, I bet. So, okay, I hope we answered that, and we are almost done. So let it be the last question. Now, what to... Okay. First this question, because I just like it. Does it mean Netflix majorly uses Cassandra over relational databases? Well, that's better to ask, obviously, Vinay than me. But as far as I know, yes. Netflix majorly uses Cassandra over relational databases. It doesn't mean that don't use them. After all, as I said, there are still many use cases you need to have both. Good. That is briefly closing some questions. How is DataStax Cassandra software as a service different from vanilla Cassandra? Very simple. Vanilla Apache Cassandra, you deploy, you maintain, you take care of the servers and upgrade and so on and so forth. DataStax Astra Cassandra as a service is we maintain, we deploy, you just use as a client. So it's our headache. It's all about headache for me. Do we have... Okay, that was the answer.
I would say maybe also sometimes the Astra gets new features of Cassandra before the release.
Yeah, right. So Astra is a different story. That's why it gets Astra is Cassandra as a service, but not Apache Cassandra as a service. And there are some features what exist as Cassandra enhancement proposals, but not yet accepted and pulled it into the Cassandra. So, for example, Astra use storage attached indexes and DataStax Enterprise as well, but Apache Cassandra not yet, because this Cassandra enhancement proposal is not yet accepted. Same goes to unified compaction strategy. I don't remember if it's rolled out already for Astra, but it's going to be sooner when it will go to Apache Cassandra, because Astra is managed and controlled by DataStax, and Cassandra is managed and controlled by Apache Software Foundation. So community has to agree what this improvement is indeed worth it and has to be included into the open source Apache Cassandra. And last question we answer, I'm sorry, but we are out of time. Shouldn't we have replication factor closer to 10? Gentlemen?
It depends how large is the cluster. So if you have 10, if you have 100 nodes in your cluster and in one single data center, maybe 10. But it depends. Are you trying to have your data more secure for against losing data? What is that you're worried about? That is more important to answer.
Mm-hmm. Yes, agree on that. Usually what we see, like typical recommendation 3, so in some cases I have seen the 5, and then maybe once we had the 7, but then you need to, like, you have, and like if you using the local, even if you use the local quorum, you have the increased latencies, because more machines need to read the data from the disks. They could have GC pauses or something like this. Usually this will lead to the more increased load on the servers. Better if you really worrying about the your data, get the things around an additional data center, what Sarma mentioned as backup data center, for example, because even if you have the 5 replicas or 7 replicas and your data center is going down, you lose everything. And even on the clouds, sometimes there are regional downtimes. In this case, having more data centers will help you to make the data more available. It's a primary. You need to, like, I agree with that. You need to reason why you need that, but you need to think about the latencies increase, etc.
Yep. I would.
So,
please go on.
One follow up on that. If you have too many replicas, right? There are several issues with that. One is your storage requirements increases. The second thing is, how do you keep everything in sync? Is repairs. So you need to do a lot of repairs, and that takes time. So you just have to calculate all that before you increase the replication factors.
Yep. So what I can add from my side, first of all, you definitely makes no sense to have more replicas than racks or availability zones, because you just start to duplicate it for with nearly no real benefit, except of a situation when you have a single rack, of course. So I mean, like, you don't have to go below 3 replication factor 3. Second, don't forget what there are multiple. What you need, a replication factor is set not per cluster but per data center. So technically, forgive me please, but this question is not really good one. I mean, there is a solid mistake. Replication factor of what? 3 data centers, 3 servers per data center, or I don't know, 10 data centers of 1000 servers overall. Replication is set per data center, and different data centers may have different designation. So you may have your clusters spread by geographically, United States, Europe, Asia, but also you can have, working on the smaller regions, you can have data centers spread, splitted not by geographical idea, but by the responsibility. As Sarma said, you may have one production, one backup, and one analytical. In this case, for example, for analytical workloads, you definitely not need anything close to replication factor 10. And for production, again, as said, another problem mentioned already, more servers you have, higher probability you are going to wait for the response than executing query on a high consistency level like quorum or especially all. If you are waiting for a response from 10 servers or 100 servers, definitely chance is higher to get a delay than you are wait only for 3 servers. More servers you have, higher chance you run into trouble sooner or later, just mathematically. Okay, ladies and gentlemen, there are such a lot of questions. I'm going to show you something. Like, it's still 118 questions. I love you. Thank you so much for that flow of questions. Now, how do we keep in contact? Because I still want to be able to answer your questions. There is a special link for you, and I send it right now to the YouTube chat. Discord, 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 Discord. I send it 5 times, so you won't miss that. You have to join our Discord server. There are more than 12, I believe, 1,000 members, and you always can find someone to discuss Cassandra. And it was indeed the great thing. I see Nagesh asks how to submit homework. I will send one more link to you. GitHub, DataStax Dev Workshop Intro to Cassandra. So all information about the homework and participation page is located here. And Apur thinks we have very cool instructors, and I'm absolutely agree. We indeed have great speakers. So, ladies and gentlemen, that's an incredible day. I'm very happy we spend it together with you. I'm happy to say thank you, Alex. Thank you, Sarma. That's incredible, and we got so many questions answered. You are the best. You are really the best. And there are last points for me to say to the attendees. I will say them in 1 minute.
Alex.
Yep.
Alex, 1 second. So between both the rooms, right? I know that RL and CL rooms.
Yep.
How many users registered and how many attended? Approximate counts.
Oh, that's hard to say. We have more than 2,000 registrations. And regarding the attendees on YouTube, it's extremely hard to judge because people are switching from one room to another a couple of times, and YouTube every time counts it as a separate view. So there is a lot of duplications, but we have many thousands of views, and that is amazing.
Yeah, we need that replication factor, so it's not a duplicate.
Yeah. Okay, so thank you, Sarma. Thank you, Alex. I believe we are done with you for today, but I will definitely call you to our next event because, well, it's going to be amazing, and you did a great job answering questions. And thank you, Sarma, for so much for your talk. Alex, I hope next time you will join us as a speaker as well, because you see, world needs your expertise. So thank you so much, and say goodbye. I will be live 1 minute later with some last words. Thank you.
Okay. Stay safe. Have a
Stay
nice weekend.
safe.
Bye.
Okay, so final words. Final words. We are almost done, but we still have a few things to tell you, ladies and gentlemen. And first, I will start. You are the best. You are literally the best. You stayed with us till the very end, and that makes us absolutely happy.
Yeah,
Isn't
it's very
it
nice to
amazing?
see so much interest in Cassandra, and yeah.
Good. Now, last few words about what is important and what do you need to know. It was over when it was like altogether like 12 hours of content, I believe, and there's still many dozens of people in this stream. I mean, like that's insane. You are the best. That's incredible. Voucher link, please. Not a question, voucher link. We won't answer Cassandra questions right now. Please proceed to Discord. But we indeed have to dispatch a couple of links.
Let me drop the link to Discord.
I found it already. So you will throw it to Discord.
Just so everybody knows how to keep in contact. And that's here.
Actually, everything I wanted to tell right now is about voucher. Not about voucher. We got stuck for inside of workshop and technical things. I'm sorry, I'm not sure what's the question. So, Cassandra Day India is done, but Cassandra's story never ends. What matter for us? Cassandra is one of the best and most powerful databases, no worries, and I would say one of the very rare open source communities which stays truly open source and doesn't stick to any commercial company with commercial interests, but stays Apache Software Foundation project. Now, in 21st century, amount of digital information grows exponentially. By some investigations, by some researchers, estimations, we are going to have many hundreds of zettabytes of digital data in the world by the year of 2025. So in just a few years, amount will basically more than double, go many times. Most of this digital information is, of course, videos and photos of cats, but that also about all the information you use it to store in the database. Now, more and more companies realize that to be successful, they need to have a lot of data and make decisions based on this data. It's called data-driven companies, and more companies in this field. All the biggest and most successful companies realized it a long time ago. And to make reasonable decisions, you need to have a lot of data to build them in. And then you need to store this data somewhere, and Cassandra is obviously one of the best choices. Now take a look. Cassandra is in high demand already, and this demand grows. But what's the problem? Cassandra is not the easiest tool. You need to really learn how to use it. It's not a bicycle, what you can sit and ride, but it's more like an Airbus or Boeing, and you have to learn a lot of knobs, buttons, tumblers, lights to understand how do you ride that without falling down from the skies. That means you need to get skills. And DataStax on this way is your best friend, because DataStax first features free education if you want. Academy.datastax.com is free and open. You just go, register, and pass the courses on the Cassandra data modeling, fundamentals, administration, operations, application development, and so on. Now we work on a special course on Cassandra version 4, because there are some major changes coming. So you will be able to handle them as well. And all of it is completely for free. Now you have to say, yes, DataStax, I love you. Because, well, yes, it's a great project. Then, second point. Knowledge is great. Knowledge is the essence. And it's very important to be a skilled engineer. But how to confirm that to your employer or your potential employer? What you are skillful in this way, our suggestion is you pass a certification. But certification costs money. DataStax now suggests free certification. You get our courses, you pass the certification with our voucher completely for free. You can become a qualified data expert engineer able to handle the power of Apache Cassandra, certified absolutely for free. Again, thank you, DataStax. What to do now when the Cassandra Day is over? There are 2 steps. First, I will even send it to a chat. Grab the voucher. It's the step number 2. It's the step number 1. Second, pass the course. Pass the course. Take a look. Today talks are overview. So, you need to be better in understanding to pass the exam. Voucher lasts 30 days since emitted. Okay, good. Thanks, Stefano, by the way, I didn't know. Pass the course. Courses are at the https academy.datastax.com. Right, pass the course. There are 2 paths for developers and for the administrators. Pick any of them, but one part of this course, data modeling, I do recommend to attend both of you. Doesn't matter if you are a developer or if you are administrator. And notice, one voucher gives you 2 attempts. So if you get complete course, but you can do it within 30 days, definitely. You can take it within 1 week, basically.
Yeah, in 2 weeks you get to a great level of preparation.
Yes. Yeah. And finally, then you pass it the course, pass it the development or administration and data modeling. You go, each voucher gives 2 attempts. And finally, pass the exam. And enjoy your life. You are great. You just got better in software development, informational technologies, and that's a great way to get higher salary, get a better workplace. There are a lot of great companies hunting Cassandra-enabled developers and administrators, and after step 3, you are going to be one of them. Isn't that amazing? So, if one completes all courses on DataStax Academy, does it make her eligible for the certificate? Completion of the courses doesn't make you eligible for the certificate. Completion of the courses make you eligible to pass the exam. And if
also to get a free voucher also in that way.
Yep, you can also get voucher for the completion of the courses. And only then you pass the certification, then you are certified. When you pass the exam, you are certified specialist. Okay, so we need more speakers too. So take a look. We have this amazing Cassandra Day program. This is Cassandra Day India. 1 week ago, we did Cassandra Day Italy. We did Cassandra Day Russia a little bit earlier, Cassandra Day China. And we will go and spread Cassandra love all over the world. So, but you know what? We need more speakers. And maybe that's you going to be our next speaker. I would really love this idea. So for next call for papers, I want to see your proposal.
Good idea. Learn Cassandra, use it in the real world, and come back to tell us and to tell everyone.
Definitely sounds great. I believe, Stefano, do you want to add anything?
Well, it's been a very intense and wonderful day. Thank you all for the attention. Thank you for being here in such numbers. And I hope this was enough to make you interested. So go ahead and learn Cassandra, because it's a unique and fantastic database. So, and don't forget to come back to us if you have any question and everything. So,
yep,
we hope to see you soon. Oh yeah, right. The Discord link.
I just sent the Discord link so we can communicate. And Sarma says it was no doubt an amazing day. And indeed, it was an amazing day. Thank you so much for attending.
Yes, such a feedback in the chat is what makes us go ahead and gives us the fuel. So thank you for this appreciation.
Okay, and Sarma asks, is there a next Cassandra Day in some other region? Nothing scheduled yet, because actually there is some period of vacations. But as soon as we will have anything, you will definitely know about that.
Yeah. We have a link to keep you informed on upcoming workshops. That's a specific link here. Let me paste it. If you visit this page, you can stay informed. And I think we also have a mailing list for those who like to get mail about upcoming workshop. This is it.
Take a look. Dumani says, never enjoyed a full day tech discussion as much as we enjoyed hearing the speakers today.
Wow, it's so nice to hear.
You make me cry just
Yeah,
like I'm
yeah.
almost. Thank you so much.
It's
Yeah,
very
we
nice
put
to
a
hear.
lot into that. Okay, so we are done for today. A little bit of music for you to relax, and you are the best. You spend your weekend to get better engineers. It means what you will be better engineers.
Yeah.
Just keep going the right way. Thank you so much for coming. That was Stefano Lattini and Alex Voleshnev, developer advocates at DataStax. And we wish you all the best and have a great weekend, or what left of that.
Have a nice weekend. Thank you, everybody. See you next time.
See you next time.
Bye-bye.